Good morning, everybody. How are you doing? How tired are you? Okay, good. Okay. Well, today is a bit shorter, but I think we have amazing talks. We have a lot of things. We have spicy panels. You see, you have some. I've watched the Telegram. You're going to have some fun. So I would like to introduce Ishaya, who is the first session chair.
All right, let's get this show on the road. Happy to be kicking off the second day of DSS. Happy to be here, and I'm not going to waste any time having you guys listen to me. So to introduce Mark Toda, he'll be speaking about modern smart contract design and security without compromise.
Hello. Good morning. Yeah, I'm Mark Toda. I'm a protocol engineer at Uniswap Labs. I'm sure many of you saw that we released our Uniswap v4 protocol a few weeks ago. I'm going to be talking about it today. I only have about 10 minutes, so I'm going to be giving you a brief overview of kind of the architecture of Uniswap v4, specifically talking about our singleton and flash accounting pattern and how it sort of affects the security of the system. Okay, so kind of a standard design principle for smart contracts, and one that Uniswap really cares about, is this idea of sort of defining your invariants and enforcing them explicitly and tightly on your smart contracts. And sort of a famous example of this is the xy equals k curve from Uniswap v1 and v2. There's like a single line of code where we're enforcing the invariant, and it sort of ensures the security of the Uniswap pools. And sort of one important thing to note about the way that we sort of traditionally have handled these invariants is sort of that they use the smart contract as like the base unit for invariant checking, right? Like one pool in Uniswap v1 and v2 and v3 is one smart contract, and the invariants sort of apply to one pool. And so any operations over that pool, the invariants are enforced. And like each pool is sort of its own set of invariants and its own checks. And this is a really nice abstraction for smart contracts because it makes them quite easy to audit, right? Like every smart contract has these things that you can verify and things that you can test. It makes it quite a bit easier to reason about changes to the protocol as well. And sort of the asset positions, specifically for Uniswap, are segregated by pool, which allows for some nice checks. But it does have a few downsides, which I'll try to explain here. One is that there's sort of, if you're performing operations over the Uniswap protocol that affect multiple pools, then there's some intermediate checks between the different pools that have to be done, which can cause some gas inefficiency. It's also hard to do more than one operation at a time, and I'll give examples for both of these. So here's an example where someone is doing a swap across two pools on Uniswap. This could be Uniswap v2 or v3. So for example, here they're swapping WETH to DAI, but there's this USDC intermediate step. And so the first thing a router will do would be to swap WETH for USDC on the WETH USDC pool. And because the invariance and the logic is handled contract by contract, pool by pool, the WETH USDC pool checks the curve and sees how much USDC the user should get for a certain amount of WETH and sends that back to the router. And then the router has to do the second stage separately, where it goes and talks to the USDC DAI pool, sends its USDC there, and it swaps for the DAI secondary pool, checks for its invariance sort of separately, right? And so the key thing to note here is that this USDC is kind of like an intermediate operation in terms of the protocol itself, but because each pool is handled separately, it has to be sort of fully settled in the middle, right? So this USDC is like transferred back from the protocol to the router and then back to the protocol. So you can see how that's kind of a potentially inefficient extra step. Another example here would be if we're trying to swap and add liquidity to one single pool. Like if we just had one side, if we had just WETH and we wanted to add liquidity on WETH and USDC at the same time, it's one pool, but it's two operations on one pool. And the invariants are checked operation by operation as well. And so the router would have to send the WETH in, swap it for half of it for USDC, and then send them both back to the pool to add. And so again, you see this intermediate step with the USDC that potentially is unnecessary. And so as we were sort of thinking about designing a new protocol, we were thinking, how can we improve this trade-off while also making making it easier to interact with the pools, easier to build integrations, and also maintaining this sort of invariant checking system. And so the first thing that we did, which seems kind of like the main way to do this, is to make Uniswap a singleton as opposed to like a multi-contract system. And so in Uniswap v4, there's one single contract that holds all the pools. We call that the singleton or the pool manager. And so all pools live on this contract. Instead of being separate contracts with separate asset balances, all the asset balances are shared, and the pools are handled by a struct and a library construct that handles all of the curve math. So each pool is still able to maintain its invariance and maintain the balances of its curve using that library and struct construct. But we have the ability here, as you can see, to kind of perform multi-pool operations in the same smart contract. And the way that we actually do this is using an interaction pattern called flash accounting, which is specifically enabled by a new EIP called EIP 1153, or transient storage, which is not out yet, but it should be out in the next hard fork, Cancun. And so the basic pattern of flash accounting, and again, I'll go through an example of this, is that the router can still make calls one by one operations, swaps and add liquidities across different pools. Each pool still asserts its invariance on each operation, but instead of settling them right then as the operation occurs, they sort of store the delta, or they store like what needs to happen for these operations to be valid. And as all these operations happen, those deltas kind of aggregate. And only at the very end, when the router or the integration is done operating on the pool, is everything fully settled. So I'll explain an example here. So here we have like a router, and we have the v4 singleton pool manager, which has many pools. So it's going to be the same thing where we're swapping WETH for DAI with USDC in the middle. So the first thing the router will do is call a function called lock on the singleton. And lock is sort of the way that you start this context, or that you start this like multi-operation transaction. And so calling lock does two things. It sets up a lock accounting context on the singleton, which is a transient storage mapping, basically, of two sides, like debits and credits, where one is tokens that the pool is owed for the operations to be valid, and the other one is tokens that the pool owes to the user that they can take. And then the singleton calls a callback on the router, which lets them perform operations under this context. So first operation here might be, let's swap one WETH for USDC. And what happens in the singleton when that operation is called is it talks to the pool construct, which is just like, it operates pretty similarly to a Uniswap v3 pool. And the construct will say, okay, if I get one WETH, I can give the user 1,800 USDC based on the curves and the liquidity and so on. And then the singleton will add that sort of delta to the lock accounting. So in this case, it says, I need one WETH because that's what the user was swapping, and I owe the user 1,800 USDC. And then if we do the second swap here, where we're swapping 1,800 USDC for DAI, we'll talk to another pool, and again, that pool operates independently using the library and struct construct. And it says, okay, if I get 1,800 USDC, I can give the user 1,800 DAI. And importantly here, those deltas cancel out. So when the 1,800 USDC is sort of given to this USDC DAI pool, it cancels out from the lock accounting because it was an intermediate step. And now the lock accounting says, okay, I need one WETH, and I can give 1,800 DAI. And now the router can call a function called take, which literally just takes from this O side of the lock accounting, and it pulls the tokens into the router. And then there's another operation called settle, which is basically like you send in funds, and then it settles the need side of the lock accounting. So the router might send in one WETH and call settle, which would clear out the lock accounting. And then once the full lock call is done, the singleton essentially needs to just check, like, is everything settled, right? Are all of the deltas 0? And if so, then we know that every pool was satisfied, and the full swap, the full operation was done properly. And so, yeah, again, transient storage is really important here because, as you can imagine, all of these operations and all of this accounting is happening on every call, like separate calls. And so if we had to do this before transient storage, it would be full S stores for every delta. And so with transient storage, because these are sort of only temporary state, it's only needed for the context of this operation, we can throw it away afterwards. And transient storage is much cheaper for that operation. Also, this is quite flexible in terms of operations or in terms of integrations, because you can call many operations on many pools in whatever order you want, integrate with other external protocols as well. Makes it quite easy. Also, yeah, the invariants are still managed tightly by the pools, so we can like fuzz test and formally verify those pool constructs, which is a nice security principle. Okay, that was it. It's very short. There's many more talks on Uniswap v4 at ECC. I put a few of them here. Yeah, go see them. Thank you.
Thank you so much, Mark. So who has questions about Uni v4? Oh, there's a lot of questions. Break you the mic.
Hi, thanks for the talk. In terms of invariant check, usually it's encouraged at the end of the operations, and it's great for the protocol itself, but do you think it opens other attack vectors? Because it basically ignore the middle steps in a largely sense. For example, read-only reentrancy. And what's your take on that, and how should we deal with that?
Yeah, that's a good question. I think from my perspective, kind of I'm not sure if you've read the code, but it's quite similar actually to the code of Uniswap v3. It's just like instead of being the whole smart contract, it's a library inside of it. And so basically the only change to the ways that the invariants are handled is that instead of checking the required tokens in and tokens out after a swap, they just get added to the deltas. And so from the perspective of a pool, as long as the deltas are being satisfied properly throughout the entire transaction, all of the invariants are satisfied, if that makes sense. I think the sort of reentrancy and multi-operation flow is actually pretty unchanged in this case. Yeah.
Hello.
Hi.
So how do you handle tokens that do weird things in this new model of only one single pool?
Yeah, that is a good question. Again, it's actually pretty much the same as Uniswap v3. Like, you can make a Uniswap v3 pool with any random tokens you want, and maybe the sort of behavior of that pool is undefined in that case. And that's the case on Uniswap v4 as well. But because the sort of logic and state and checks of every pool is segregated within the singleton, it still actually doesn't affect the solvency of the pool as a whole. Or pool might have less tokens. What do you mean by that?
If somebody, if weird behaving coin actually removed your balance or increased your balance, the pool's accounting, the total accounting might be off.
Right. Oh, right. I see what you mean. Yeah. That definitely would be true, but it would only affect other pools that also have this weird token, which affects balances, right? Okay.
Cool. Any other? Sorry. Is Jeremiah here? Yeah. Awesome. Awesome. Well, thank you so much, Mark. Let's give it up for Mark again. And now we'll have Jeremiah Smith from Open Cover talking to us about the state of DeFi insurance. Take it away, Jeremiah.
Thanks, Asai. Hey everyone, I'm Jeremiah, co-founder and CEO at Open Cover. I'm also one of the lucky 280 or so. Is it this? What I'm supposed? Okay, sorry. I'm also one of the 280 or so lucky people in the world that got wrecked by the Terra USD DPEG, but then got unwrecked because I had purchased insurance, or more precisely, DPEG cover. And it was interesting because I had professional experience working with DeFi insurance protocols on a personal basis. I had been using the product since 2021, but it was the first time I had a claim, and it was also kind of the first time that the industry had a major stress test. More money was paid out in connection with the UST DPEG than any other event before it. So it was, it wasn't perfect, but it worked. People got their payouts, and it was a kind of fascinating moment or fascinating kind of experience to have. In fact, it was so fascinating that we decided to build the first data aggregator for the DeFi insurance industry. Really, the idea was to shed light on the different players, the different approaches, how much underwriting capital there was. And that's how we launched OpenCover. Long story short, we've been collecting data for 12 months now. A couple of months ago, we released what we believe to be the first comprehensive industry report on DeFi insurance. It's on opencover.com if you want to check it out. And really this talk is sort of sharing the top 10 things we've learned in the process. So I guess the first thing, what we typically call DeFi insurance is actually oftentimes DeFi cover. It is the sort of DeFi native on-chain equivalent to insurance. It serves the same purpose as insurance, but it is unregulated, which means that it does work a little bit differently. So for example, payouts are typically discretionary rather than contractual. There's no ombudsman recourse, etc. We're seeing about, or I should say at least 15 teams working in working as insurers, doing the underwriting. So there on the bottom, you've got the regulated players, so the ones offering sort of bona fide insurance, and on top you've got the on-chain ones offering the cover products. And really there, the main sort of difference, or one of the important differences anyway, between the on-chain providers is in the claim assessment. So there are different approaches. There's community voting. There's parametric approaches where effectively you can claim a payout automatically if a certain condition is satisfied on-chain. There's optimistic oracle approaches where effectively new claims are considered valid unless they're challenged within a certain period. If they're challenged, there's an arbitration process. And then there's the expert claims assessment approach, which is more similar to the traditional one. In terms of the kind of standard categories of products that you could find on the market today, you've got protocol protection, which will protect you against things like smart contract bugs, oracle manipulation, governance attacks. You've got DPEG protection, which is typically like stablecoin DPEG protection. You've got a new one, bridge protection. Basically, the idea there is that you pay a little bit more for your bridging transaction, but you get a guarantee of the outcome within a certain amount of time. And then you have the sort of non-retail ones, the slashing protection for validators to protect them against slashing penalties and/or missed rewards, and audit cover, which is effectively kind of like a guarantee on an audit. If a bug filters through an audit and then causes some sort of financial loss, the protocol can claim from the protection provider. Moving to sort of the core metrics of the industry. So here we're really looking at the on-chain providers. Mostly it's a bit harder to get data for off-chain providers. So if we look at the top 10 on-chain providers and the associated underwriting capital, what we've seen in the last year is a drop of about 15% in the amount of underwriting capital. So that's the capital really backing the policy, the stuff that gets paid out. If there's a valid claim. That drop is in line with the overall drop in DeFi TVL, so no huge surprise there. But worth noting that 80% of this capital comes from one provider, which is Nexus Mutual, if you've heard of them. More surprising is the drop in active cover. So we're seeing an 80% drop in active cover in the last year. So we're at about 45,000 Ether, which is something like 0.2% of DeFi's TVL at the moment. Even more surprising is that at the same time, we've seen an increase in the number of covers purchased, so the number of wallets that have purchased cover for the first time. If you see, there's like a little spike there around November, the FTX collapse, and then between, what's that, like Feb and May, there are also some spikes. We think the latter is due to airdrop farming. I think Arbitrum's airdrop was around there. But overall, I think the insight is like the number of covers sold is in the low tens of thousands. So all time, the number of unique wallets that have purchased these types of products are in the low tens of thousands. And I think there's more than 6 billion wallets now that have interacted with DeFi. So we're looking at like a really, really low penetration. It's still very, very early. So I guess that's like 0.2, 0.3, 0.4% penetration. If you look at the payouts, on the top 10 providers, we've tracked 580 claims, and that led to a bit over 40 million paid out, as I said, mostly around the UST, I'd say around and after the UST DPEG. And if we look at what that means in terms of provider, cover provider profitability, If you look at the loss ratio, which is the ratio of the amount or like the funds paid out and the funds collected as cover premiums or cover fees, were above 100% for most of the providers that have had significant payouts. So that means that they've kind of paid out more than they've collected. So unfortunately, although it's a very important part of the ecosystem, it's not yet super profitable, I guess, to be a cover provider. But you know, hopefully things will change soon. And talking about, the future. So what's the future really of DeFi insurance and DeFi cover? I guess that's the same question as what's the future of DeFi? And that's a Pandora's box that we're not going to open right now. But what we will say is that on the provider side, we're expecting a continued shift to marketplace, to sort of marketplaces. So basically anyone can create a cover or insurance product. Anyone can fund the capacity for that product. Anybody can buy that. So it's sort of more collaborative, decentralized approach compared to the traditional one. So we've seen this with Nexus Mutual V2 that launched basically a couple of months ago. It's pretty much a marketplace. Other leading providers like Insurace are working on marketplaces, and newer providers like Neptune Mutual, Cozy, names are going to market directly with a marketplace product. On the protocol side, as we've been discussing for the last couple of days, or I guess if you were here at the workshops, we are expecting a focus on security architecture. So basically not just like preventing attacks, but limiting their impact if they do happen. So things like circuit breakers. And overall, we expect that will lead to lower premiums. And in terms of end users, we expect to see a lot more embedded protection. So that's protection, cover, or insurance offered at the point of transaction. So like in wallets, in portfolio trackers, in dApps, kind of like bridge cover, where you're basically bridging. There's a toggle. You toggle it if you want to pay a little extra to have the outcome of your transaction guaranteed. I only have a minute left, which is perfect because that's the last slide.
All right, thank you. Nice, thank you so much, Jeremiah. Maybe we have time for one question. Anybody have a question about DeFi insurance? All right, well, I think it's time for a break in that case. Thank you so much.
Thanks.
Morning. So we have a quick 10-minute break. And this is not a coffee break, so that's going to be a little later. We're going to start at 9 on session 12 on vulnerabilities and exploits. It's going to be chaired by Spencer from Spearbit. So please make your way. And if you're a speaker in this session, please make your way to the first row. Do we have Andre? From BGD? morning. Do we have Jin Won from Uniswap Labs here? Ah, great. Can you please make your way to the front?
All right. Good morning, everyone. I'm Spencer from Spearbit, session chair for session 12, vulnerabilities and exploits. I have a really diverse group of folks going to be talking over the next hour and a half or so. So first, I'm going to introduce Andrei Kozlov from BGD Labs. He's going to talk about some security challenges in Aave.
Good morning, everyone. It's not about most like our security challenges, but yeah, like more about our governance. Yeah, my name is Andrei, and I'm working last almost 5 years around our protocol. Originally, I was the part of our Genesis team, and last year we created the BGD Labs initiative, and now we engage directly by the DAO, and we are trying to think mostly about the DAO itself. And what will be the talk about? I want to make a short introduction, which everybody aware of, how our protocol was evolving, but from a bit different perspective. Like initially, a long time ago, let's say around 4 years, we got Aave v1. It was in mainnet. It was controlled by multisig. And but on the early stage, everybody was accepting it, and it was fine. But then, over time, it was not an option, and we developed our governance, which allowed us to control the pool completely through the voting system. So, and we was in a quite good spot, good position. But over time, it was quite high demand of expansion to go to the different networks, like to Polygon, then to Avalanche, to some other. Also, we grew in the mainnet with some other components, with the safety model and so on. And very interesting question appeared, but how to expand? Because, okay, we can go to optimism, which happened a bit later, but security of the breach on optimism is the same as the security of optimism itself. So we can go there and it will be fine. Another option, we can go to Polygon, and there is official breach, but it's not the same security as Polygon itself. And then we can talk about Avalanche, where there is no official breach. There is just some breach which is just doing the minting, burning tokens, and what to do. Because Guardian or multisig is not an option, because we are going back to the same centralization point which we had, let's say, 1 or 2 years ago on our V1, on the main pool on Ethereum. Then, yeah, we can choose one of these bridges if it's not rollups, but then we end in the same centralization problem, because we are fully depending on one particular bridge, and we don't know anything about this bridge. Like, yes, for sure, we can check the code base, we can check what they tell about validators, we can trust that all these validators are independent, but then even one line of code can ruin everything completely. It's quite a fragile situation. And also, if we want to expand more, like, okay, imagine we checked one bridge, it took for us, let's say, 1 month of the engineering work, and now we want to go to another network. We need to spend another month, and still we don't have full assurance that we will be living in peace, we will have like good decentralization level, and so on and so forth. So, what should we do? And how to survive in this environment, because like it's more and more networks over time. And that's actually what we were working in the BGD Labs last year. We were thinking about this particular problem, and now we are coming with our delivery infrastructure. The main idea is, you know what, why we should depend on one particular bridge provider? Why not to do aggregation on top of them? Because if we have 3 providers, all of them have different community, and it's quite remote to imagine that 2 out of 3 or 3 out of 4 will disappear in the same moment, or will be hacked, or like will go down, whatever. So with this thing, we can have quite good level of security, and Also, we don't need to dig so deep into every breach. Like now, for us, more important question, how reliable is it? I mean, in terms of availability, also the cost. For sure, security is also a very important question. But if we fail once, we can survive. And yeah, the high-level architecture is that we create our own transaction, let's say, on our aggregation level, which is completely on-chain. We send it through 3 or 4 or whatever different bridges, and we accept it as confirmed only when we receive it multiple times, let's say 2 out of 3 on the destination network. Before, we think that it's fraud, or like we don't know what is it. Apart from this, we like a bit going deeper in the technical. We have a couple of levels of abstraction inside the system to guarantee the delivery, because if we will lose the consensus, maybe we will want to retry the message, and maybe we will not be able to send the message to enough bridges from the beginning. So yeah, we have also some retry mechanisms for that, because I think that it's very important. If you send the message once, it should be delivered like for sure. But imagine what will happen if it will really happen, and 2 bridges out of 3, let's say, will be misfunctional. Maybe they will not be malicious, like nobody knows what can happen. And for that, we have emergency mode, because we still have Guardian in our system, but in normal mode, the Guardian operates more like spam attack protection. If you need to retry some transaction, or if we need to execute some action receiving to not spend our funds on the bridge, we have a Guardian. But in case of emergency, and to activate an emergency, we need to create the voting on mainnet, activate a specific oracle, which is like independent delivery channel to this network. Then Guardian takes more or less full control and can reconfigure the system. So here, like if you want to screw the system, you need to have control over social Guardian, and you need to also have control over, let's say, oracle of the like chain link level. I mean, which is also quite tricky. So it's quite good. But is it good enough already? Because it seems that we solved the problem of centralization on the cross-chain communication in a very simple way, which I really like as the application level developer, because we don't need to dig so much into how the rollup work or how the communication of this particular bridge working. But still, we have some problems, because originally when our governance was designed, in the good old times, the gas was 1 gig away. There was no so much of a bull market. So the voting was efficient. We were able to vote with, let's say, $1 per person, and the participation was not the question at all. It is still like debatable, is it a problem or not so much, but the holders of, let's say, $50 worth of our token, or $100, or even $2,000 or 5, maybe they don't want to spend $50 to make one particular vote, because gas on Ethereum is crazy. And in the same time, we don't want to go again to centralization point, because we will be happy to move voting out from Ethereum, but what do? We cannot just do it on some centralized entity. And that's why, yeah, we are coming with our governance V1, V3, sorry. And our main idea is to move voting out from Ethereum, but now, because we have quite trustable infrastructure, which we control from the both sides, and we understand how it works completely, we can move it out. And how to do it? Very simple. It's the storage proofs. Because the current version of DAO governance is based on the on-chain proofs. So on every transfer, the same as Uniswap and Compound and all like mainstream governance, on every token transfer, you create a snapshot to understand how was the balance of the guy. But it's good, bad, and it's not so gas efficient. But the Ethereum like native mechanism is the block hash, because block hash contains all information about the blockchain in the moment of time. So all we need to do, we just need to breach this block hash on another network, which is cheap, and to start vote from there. And it's very simple, as simple as this. But yeah, I will give just high level picture. So we breached the storage proof, And then any user just go into the normal RPC of Ethereum. You don't need to bridge any funds. You don't need to do anything. You just take the proof and you deliver it there. And that's it. And also because we are on the chip network, we can improve the user experience because we can add relayer in between and say, you know what, governance will gonna pay. Because every vote will cost, let's say, 20, 30 cents on Polygon or on Avalanche. So whoever can participate, even not having Polygon and Avalanche, and even don't have any funds at all, just our tokens. Why our delivery infrastructure is also very efficient in the case of the governance, because governance is a very slow system. And when we send the message through like 3 or 4 different bridge providers, it can be slow, it can be expensive. But if you're working with a governance system and you want something now, it means that you're in the big troubles and you're in the wrong place, because our vote takes 5 days and then you have time locks and so on and so forth. And for that, like to have another half-hour delay on the bridge or 1 hour, it doesn't matter at all. So we have multiple phases. We create the proposal. Then there is like some time lock before activating the voting for people to prepare their balances. Then when we deliver results, we also have another time lock, because still, even if we trust to our cross-chain infrastructure, there can be some malicious action. So also we try to design cross-chain independently from the DAO itself. So DAO don't trust anyone, even own cross-chain. So the guardian can cancel if something. And then, yeah, you deliver to the destination network, and there you have another time lock, and you can execute it. Another key features of our governance, apart from storage proofs, now we can have multiple voting machines. Like, also we not depend just on Polygon, for example. If we will put a voting machine there, we can put our voting machine on Avalanche, we can put it on Optimistic Rollup. Unfortunately, we cannot put it on ZK at the moment because Kichak costs too much money. And I think many people noticed it in the last year of development. Also, we have a mainnet backup, which guarantees us that even if all sidechains will go down, still we can vote for proposals and make them work. And another quite important thing, which sounds a bit smaller, but we think that it's very important, because last year we were working a lot on improving the, how is the name? On simulation of the governance proposals, because it's hard to predict what will happen if you will just be checking code. It's good if you can check all state transitions which will happen in the transaction. You can understand what exactly happened. So in the current governance system, we bridge the full payload in the bytecodes, let's say, and the bytecode through the bridge, but it's not efficient because you don't know what you will receive on another side of the bridge. Yeah, you expect that it will be this, but maybe some extra IDs will appear, maybe some other stuff. So now we have payloads controllers, like the place where we create our payloads on every particular network, and we bridge just IDs. So in terms of simulation, for us it's very simple. We just say, okay, ID 15 appear, and all the code and all like information is already there. We can say how it will be in the end, quite in advance. Okay, and what we learned during this development process. We was like heavily using properties and formal verification, and for me at least I understand that it's the best debugging, because when you're trying to define the properties on the system like cross-chain communication or like or DAO, it's very, very important, because many things you think that you thought but you actually didn't. and formal verification explains you very, very fast. And another thing, that the basic blockchain mechanisms are very underutilized on the application layer, because for sure, like when you hear something about rollups, when you hear about like core mechanisms of chains or some circuits, you hear a lot of them. But when you go and check, at least like how it was a year ago, when we wanted to find at least simple example of with a good code base just to make a test, with the storage proofs it was nothing. Like it was some examples, but they was not working. And we think that it's still like quite undiscovered and interesting direction. Just the point like how to find good application of it. And yeah, that the communication protocols are very, very hard, because when you dig into them, then you see, and when you see all the hacks around, it's a very tough story. And decentralization is even harder. So now we think that we're in a good shape, but it's hard to imagine it actually, how to make it still perfect. Okay. That's all I wanted to say. Questions? Thank you.
Any questions? Anyone?
Hi, you mentioned that you potentially will have different voting machines across different chains. Would they be happening at the same time and aggregated back to mainnet for the decision, or do they exist only one at a time?
Of course, they exist only one at a time as the backup mechanism, because you can take decision based on the gas cost and everything, like where to vote right now. Because when we start going this direction that we want to aggregate some data across multiple chains, it becomes very, very complicated. Like originally we had also high demand. People were saying, oh guys, but we want our tokens on Polygon voting because there is also important supply. But when we go into the synchronization topic, how to understand in which particular moment of time we lock both networks, it's impossible. So that's why the same thing. It's also impossible to have voting on two machines. You need to have exclusion. I mean, possible, but useless.
What was your approach to testing? Did you attempt to automate the testing? Communication protocols, especially cross-chain, are difficult to test. Just curious, how did you approach that?
Because in our case, we accept some parts as the black box. I mean, the breach in the middle itself, we cannot test it. So in our case, testing is way, way more simpler system, because we have cross-chain like sender and cross-chain receiver, and they are quite isolated between each other. It's a very simple system. So we were using, apart from formal verification, the test, but it was mostly like unit testing. Because then, like, I send the message, and I can be sure on another side that this message is from there. So, but why I can be sure? Because I received it from the multiple breach providers where they have like big community behind, and we cannot consider that all of them will disappear in the same moment in the same hack. If we consider it, then it's a different story. Thank you very much.
All right, everyone. Our next talk is going to be Hassan Mohammed from Halborn. Give it up for Hassan, everyone.
Hello, everyone. So we're going to talk today about breaking digital assets custody solution. So, okay, so yeah, more intro about me. I'm senior security architect at Halborn. My background is vulnerability research and offensive security operation over like 7 years. Mostly like iOS and Windows in terms of vulnerability research and red team in terms of offensive security. Right now doing R&D at Halborn, and yeah, running around and stuff. You can follow me on Twitter. Yeah, so more about us, Halborn. We are like specifically as R&D. We have found like some 0 days, a lot of them, a lot of vulnerabilities. This one of the most two famous vulnerabilities we have disclosed recently, the minimalist wallet, and the one I personally found is the Dogecoin vulnerability, which is affect also 280 network. Yeah, this is what the brands we are working with. Yep, so today's agenda is going to talk about what's the digital asset security custody solutions. We got to talk about MBC, some cryptography stuff, and we got to talk about real vulnerabilities. And this original presentation has been like for 1 hour long presentation, but it has been like squeezed to just fit the timeline we have today. So like what is DAX or digital asset custody solutions? Like banks or centralized exchange, they're not holding their assets differently like in MetaMask wallets or their own self-custodial wallets. They have like a more complicated procedure to execute large transaction, let's say, to move like from treasury to another one. And they're using technically something called like custody solutions. This is just a market overview. I believe that this slide is really out of date because right now the market value is really different than the one we are seeing here. Yeah, so what's the difference between your MetaMask wallet or your self-custody wallet versus like a really enterprise-grade kind of digital asset custody? So your wallet's like small amount. When we talk a small amount, it could be like some few million of dollars. That's considered small amount for the amounts operated through custody solution, enterprise-grade custody solutions for big financial institutions. Simple cryptography, digital signatures, it could involve like some multi-sig, some simple multi-sig wallets. You're using it like normal users are using it, like not financial institutions, not crypto exchanges and stuff like that. But for digital custody solutions, banks are using it. Like this is where banks are storing their digital assets like Bitcoins or ETH or any kind of cryptocurrencies. And also like centralized exchange, so like when they're holding their liquidities and stuff like that. The transactions is like more frequent, large amounts. It could be like billions of dollars some cases. In terms of the cryptography behind that custody solutions, it's mostly like MC protocols, shareholder signature schemes, and other complex cryptographic protocols. We got to talk about each one of them. So yeah, it's simple as that. Like when you are initiating a transaction from your self-custody wallet, it's just like a few buttons. Maybe you're entering a password. But for a custody solution, like I have seen something close to that one, like kind of custody solutions where you have some people like required to enter a specific room, use like specific laptop or an iPad to sign a specific transaction and stuff like that. There's a lot of procedures like for that, mostly for financial institutions. So yeah, there's stuff like that for digital custody. So why we should care about digital custody securities? Actually, like the digital custody solutions, they are designed for security, like to provide security for the digital assets. So that, like, I would call them like a security product or a product have been built with a lot of security consideration would make it like really hard to break. But let's assume like two following scenarios, like in Web 2 space and Web 3 space. In Web 2 space, we are breaking into a financial institution, we are gaining access, we are becoming like domain admin, stuff like that. We are compromising like the SunGuard or the SAP, start to craft like some Swift messages. Yeah, that would work like 10 years ago, but right now it's like more complicated stuff. Like, yeah, when attackers like gain that much access and they start to actually craft this kind of messages, yeah, there's a lot of procedure and action response. So, like, it will not work that much easy. But in Web3, like, you can just like gain control over the infrastructure, and this is definitely optional because you can do like some cryptographic attacks, some smart contract attacks if smart contracts are part of the system. You can compromise like the key materials or the private keys, and like just sign your transaction, send your transaction, and all of your funds gone. It's that much easier in Web3. That's why like threat actors nowadays are focusing on more attacking like kind of Web3 institutions and Web3 related stuff other than regular financial institutions, because it's really easy to make profit over them. So yeah, that's like a kind of compromise scenario of a normal, let's say, a centralized exchange. They're not using any kind of custody solutions. So the attacker is just compromising the operation machines, and the operation machines interacting with the backends to handling the private key, let's say, and sign some kind of transactions, and they just send this transaction, broadcasting it to Bitcoin node. But in a secure scenario, or like where is that exchange using kind of custody solutions? So we will have something like this one's a function inside is like the custody solution, let's say, or like the multi-secure competition or whatever. So when the attacker is trying, oh, okay, I want to initiate a request for transferring $1 million, there's like kind of a part of the custody solution, it's like kind of a policy manager. We'll talk about this. A regular policy manager will like give some alerts, initiate some MPC and start to like ping people. They have been transaction. People will just like kind of, okay, reject the transaction. It's not us. And yeah, the attack will fail, or the attacker will be like, not really able to take the money out. So yeah, the core functionality of a custody solution is like MPC or TSS or multi-signatures. They are not all the same, definitely. So like the MPCs use like multiple parties coming together to compute a value based on like private inputs. TSS is like distributed key generation, and the multi-signature wallet is like just like multi-signatures we are using almost like every day in our crypto life, where we like have a group of people trying to authorize a specific transaction. So we'll talk more about MPC, because MPC is like the core part of a custody solution, but definitely there's a lot of other things related to custody solutions, like the communication channels, but the core thing is happening inside the cryptographic primitives of the custody solution, which is mostly based on MPC. So MPC is not like an actual cryptographic protocol, but it's more like hashing. Like when I say hashing, like there's a lot of functions can come to your mind to make the actual hashing. It's the same for MPC. You can employ like multiple cryptographic primitives to build like an MPC or multi-secure competition. So it's early in 82, like some historical stuff, and the MPC is that when cryptographer actually started to talk about MPC, it wasn't really about cryptocurrencies and digital asset security or digital transactions, because that time they didn't have kind of this stuff. So some research, yeah, definitely they're not like publicly classified informations, but most of like the MPC research paper was related to some military activities that time, when they are like launching missiles and stuff like that. So nowadays we have like really common papers for the digital asset security, like people who's building like custody solutions. This is the most top protocol I have seen when people are implementing their own custodies or the custodies that have been auditing. So like GG, good game. Buzz, Genera, and Goldfeather, that's the most common one I have seen. And DMZ, I don't know what DMZ is standing for, but there's a lot of open source libraries using DMZ paper implementation. So note about like when you start to the end like the GG protocol or the G implementation, you will see like there's a lot of research have done like attacking these protocols actually, and there is no one attacks. But people like, for example, when you just like grab this repo or you're trying to implement your own protocol, you're not gonna really like scroll down to all the references. I know. Okay, yeah, definitely you will check the security because there's something security, but you will not read each like kind of research paper. That's really time consuming. But there is a lot of learning attacks on the GG protocol, but it's still commonly used. Easy to find bugs, let's say, because for example, when I'm getting an audit, they're using like GG protocol. I'm not saying GG protocol is not secure, but yeah, it's more common to find implementation errors within the protocol. So ways like to do like the MPC is it can be done like through secret sharing schemes like streamer secret sharing or shell secret sharing, and other cryptographic primitives you can just put all together and create your own MPC. Like if you are a cryptographer, I don't recommend you to do that, definitely. So what do you need to break a digital asset security custody solution? So you need to have a breaker mindset, read some codes, some masses required, I do believe. Understanding digital signatures definitely, but yeah, I mean the actual core of custody solution is more in terms of cryptography stuff, but you can still break a custody solution like attacking their web interface or the API interface or other stuff. Yeah, this can work, but you can also attack the cryptographic bar stuff. Trust no one. Every component inside the actual custody solution is, let's say, is a vulnerable because this threat modeling of a custody solution is should be kind of rated completely different other than a normal software because, for example, you don't even trust your CPU or operating system, and we're going to talk about that in a moment. Yeah, work at Halber if you want. We are hiring. If you're interested in this stuff, you can bring me after the talk. So yeah, we're going to talk about red flags when we are starting kind of engagement with auditing digital asset custodies. So the most common red flags is, and by the way, this flag has some real scenarios, but I have just squeezed it because of the time. So yeah, we are running our own implementation of the cryptographic protocol, or we are started our own MC implementation or CSS implementation. That's a red flag, and we're going to talk about this in details. We don't have secure enclave or trusted execution environment. Or, okay, we have secure enclaves, we have HSMs, but we don't know the context management and domain management, C and C++, and or unsafe memory languages. So we have first scenario, we are running on our implementation. We are running our implementation could be closed source implementation, or it could be an open source. The actual argument is not related to whatever it's open source or closed source implementation. It's just their own implementation because most of the people, they don't have access to rockstar cryptographers where they will be able to implement the protocol error-free or bugs-free. So that's definitely kind of a red flag and requires definitely more work from you in terms of audit, in terms of securing this product, because it's me. You're gonna read and inspect a lot of code. So how you break that or how you solve that? So you need to understand the actual protocol. You just drop the client code and go understand the actual protocols they are trying to implement or the actual paper. Yeah, definitely reading research papers is not that much easy. Definitely if you're not a cryptographer. But I do believe having the basics math of computer science level math, you will be able to understand the paper. But yeah, if there's some parts of linear mapping, for example, you don't understand that, you just go ahead and Google it. We are internet age, you don't need to go to the library and look at Fatbox. Yeah, so. Review the implementation, try to identify the core points of the implementation, for example, the key generation flows, the actual protocol steps, verification and signing. And once you spot this few entry points, you will go and identify the same entry points in another implementation of this protocol or open source implementation of this protocol. You might not find them, but try to, for example, if they're using, for example, the other implementation of protocol, for example, they're using a entire different curve. So you will start questioning why is these people in their implementation using this specific curve, and you might start asking the client some questions, and you might come up with a finding. So the other one is we don't have secure enclave or trusted execution environment, and this is breaks the actual idea of custody solution because it's you are running you are processing your key materials or your private keys or your cryptographic operations on pair machines, I would say. Or, for example, if someone compromises your machines, they can just dump your private key. So there's kind of no security. So you don't need to break it because it's already broken. So there's no custody solution or kind of MC running outside of trusted execution environment that's completely broken thing. Okay, but we have like trusted execution environment, we have like secure enclaves, but we don't know how to manage the context, or we fail to manage the context management between both of them. For example, we are doing like kind of, we are extracting the key materials from the secure enclave and we are processing them into like as a web app or the API. And we keep them like we are not zeroing the values or whatever, so the key can be extracted around time in case of the compromise of the untrusted domain. And the untrusted domain is, let's say, like, okay, all of your cryptographic stuff are running inside the trusted execution environment or the secure enclave, but the attacker gain access to your like web interface or the web app container, or they start like you are already dealing or you are executing some calls to your secure enclaves and you are keeping your private key stored in like in a variable or whatever. So that's where you are failing to manage the context between the secure enclave or trusted execution environment and your untrusted domain, which is like the interfaces or your APIs. So you're like C and C++, like that's it, like C and C++ using memory safety issues is really common, for example, at the communication level, because it will help you exploit the untrusted context, let's say. Maybe that will lead to further attacks, but definitely like most of the cryptographic protocols are user implemented in two languages that have privacy. It's like C and C++ or Rust. There's like some TypeScripts, but it's not really common. But most of them like are in C and C++ because people are just getting on-shelf cryptographic primitives from other libraries and they start to use it in their own implementation. So also like academic people are more comfortable writing in C and C++ code. So it's more like you're starting to write kind of the message processor or the message parser or the communication parser in C and C++ as well. So I have seen like some issues related to that one where you don't need to attack the actual cryptographic protocol, but you're just attacking the memory safety of C and C++, like, or the communication protocol, causing like some heap overflows in the case I had. So like how to break it is just exploit some memory corruptions because I don't think there is any advantage for the attackers to see inside C, C++, inside the custody solution other than memory corruption vulnerabilities because yeah, it's definitely they saw like some cryptographic flows. That's an entire different thing. Yep, so that's all for today. Any questions so far? Complicated topic, right? Okay, thank you.
All right, our next speaker is Jin Wan from Uniswap. Give it up.
Hi everyone, I'm Shin and I'm a researcher at Uniswap Labs. Today I'll talk about the economic security of on-chain oracles. Let me just quickly flip through the slides so you kind of know the structure of the talk and then we can come back and revisit. So the first, oh, how do I, this one? The big one? Okay. So I'm going to start by motivating why we are talking about this, but given that people are coming to this particular conference, I'm assuming people know the importance of the on-chain oracle security. Then the second part will be analyzing the exact cost of manipulating a particular on-chain oracle, given that you know everything about the pool and how the oracle is designed, which will serve as a foundation for the third part, which is if you know the exact calculation, you can then evaluate the security of any particular pool combined with a particular oracle design. This will be an incomplete framework, but it serves as a starting point to asking the question of how do we design better oracles and enhance the manipulation resistance of a particular oracle. The fourth section will just be some stylized examples of how do we think about designing Oracle and implement better ones. And the last one will just be some recommended best practice in terms of having your own, Oracle design that's manipulation resistant. So let me go back to the beginning now. Whoops. Okay, so we know that a lot of protocols use on-chain oracles to function. Specifically, lending protocols are a prime example. There's hundreds of billions of dollars, and you need to know whether their collateral is enough to kind of collateralize the debt that people are borrowing. Specifically, Chainlink is a very popular oracle that feeds into them, partially because it's seen as this more manipulation-resistant oracle. Well, ironically, because some of it is somewhat centralized. And then there's newer lending protocols like Euler, who experimented using Uniswap protocol as a decentralized price feed. But they did switch to Chainlink after the switch to Ethereum switch to proof of stake, which I'll talk about why. But these, even Chainlink is not 100% safe. And we have seen these highly profitable trading strategies executed against it, mostly because some pools are, there's only a few venues, so the price feed can only come from certain areas. And if you basically manipulate the entire market, then there's no way of being kind of manipulation resistant because there's no other source of truth. And specifically, proof of stake changes things for a simple implementation of, for example, TWAP on Uniswap, because previously, if you manipulate a pool in one block, you don't know who's going to control the next block. So you effectively has to defend your position through somewhat of a priority gas auction, and you might have to pay back all your potential profit by bidding the next block. And so it's effectively impossible to keep a manipulation going for more than 3 blocks. Whereas in proof of stake, you kind of know the proposer of the next 32 blocks in ahead of time, and some of the large validation pools or staking pools, they might even control quite a few blocks sequentially. So it's very easy for them to do it, assuming that they're not behaving benevolently or anything. And that's kind of the concern that drives Euler to, switch to Chainlink post POS. So let's look at one example that demonstrates why. So assume that you have a particular target. Let's say there's a Uniswap pool, and you say, hey, I want to manipulate the 30-minute TWAP by 20%. What do I have to do? Well, first of all, you need to know how the 30-minute TWAP is calculated, and specifically, it's a geometric mean of kind of a snapshot at the end of every block of where the tick is in the pool. So if you want to manipulate a 30-minute average, or the geometric mean of it, by 20%, you effectively have to, let's say you control one block, then you have to move the tick within, or the price within that block by somewhat near the scale of 250,000 ticks within one block, which is a lot of money for a deep pool. And as the number of blocks you control increase, this amount kind of decreases pretty fast. So if you control, let's say, 10 blocks in a row, and you can basically keep that, you can basically censor all background transactions or censor all arbitrage, and keep that manipulated price in place, then you just need to move it by 1/5 of what you have to do, or actually maybe 1/10 here. So the point is to demonstrate that as you control more blocks, the cost of manipulation is reduced drastically. The tricky thing is, at any point in time, the distribution of liquidity within a pool is unknown, right? So this is showing the distribution of liquidity through time. And so it's not the most straightforward thing to know exactly how far you need to move the price within the pool to achieve certain amount of manipulation. But we did have some tools internally to figure it out. So this is the amount of WETH that's required to manipulate the USDC WETH Oracle TWAP by 20% throughout time. So as you see, like the pool has been initiated, there's some initial instability period, but after which it costs on the order of hundreds of millions of dollars to attack. Granted that that's a very, very deep pool, it might be pretty costly, but if it's a shallower pool, or if you somehow control a lot more blocks, then it's definitely an achievable target. Okay, so now that we know the foundation, we can look at some frameworks. So in my mind, the trade-off that you're making when you're designing oracles is you're trying to trade off between a few parameters. So let's say your liquidity is fixed. You kind of take the amount of liquidity you can gather as a given. Then you're making a decision between achieving a more live oracle, meaning it reacts faster to a new data point, versus the cost of manipulation, right? And if you want your oracle to be more sensitive to new data points, then it's inevitably going to be more subject to a big data point that's not kind of right. The second thing is, and these shape, they're kind of like intuitive shape. They're not really the scale here. The second thing is, if you have a latency in mind that you're willing to tolerate, then your game becomes, how do I gather more liquidity in my pool? And this is something that prompts maybe a design space, which is kind of protocol-owned defensive liquidity. So you might even create a lending pool where you say, hey, you lend me money, which I put in the pool as a defense against my own oracle, and you're paid this much over time for providing protection of my oracle from manipulation. The third thing is how much deviation you can tolerate for the oracle price to be moving away from the true market price. And that's kind of interesting because there is somewhat of a optimal distribution once you have an exact deviation tolerance in mind, because you can kind of just concentrate your pool to the extent that it becomes overly expensive to manipulate. But beyond that point, if there's no liquidity in the pool, or at least assuming there's no defensive liquidity in the pool, then it's kind of trivially easy for people to just push price farther out when there's no liquidity. Okay, so how to make better oracles? These are all kind of hand-wavy ideas. I'm happy to talk about them more offline if you want to hit me up on Twitter or anything. But the first thing is, this is a case-by-case analysis. So the first thing you want to know is, what's your objective? Are you making perpetual oracle for a perpetual protocol, lending protocol, NFT? I think they all kind of warrant different type of design. You also want to know your constraint. So how far can you tolerate your oracle to deviate away from the current market mid, for example? And how much liquidity do you think your pool will attract over time? And finally, how live do you need your oracle to be? You need to assume that someone is out there who will always try to execute some highly profitable trading strategy as soon as it's profitable, right? So it's kind of not okay to say, oh yeah, like most of the time it won't get hacked, because that's not how it works. And finally, get audits. Audits involve audits of your code as well as some sort of economic security analysis. And Mark has just talked about Uniswap v4 hooks. We believe that there's abundance of design in custom design hooks that can sort of expand the design space of oracles or on-chain oracles vastly. Some of the ideas that my colleagues and we at Labs have explored are, for example, truncated oracles, which is basically an oracle that whenever they're faced with a big kind of oracle price update, I will say, whoa, 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 let's take it easy and slowly. You have this price change of, say, 500% in one block. Let me gradually take that information in, right? Maybe 5% a block, 10% a block. And if it somehow immediately goes back to the previous level, I only taking how much I have taken so far, and I kind of throw away the rest of the update. So that's one way that's kind of sacrificed a little of latency, or maybe liveness. But on the other hand, you can say, wait, like if things are immediately reverting back to normal, maybe that data point should be thrown out anyways. So yeah, try v4 hooks. So here's one example that I've written out. You start with your objective that you want the highest resistance against an attack to move 30-minute TWAP by over 20%. Your constraint is you have a liquidity of $20 million, and you assume that like the profit of a successful manipulation it scales linearly with an attack of like your TVL or whatever. And then once you know all of this, you can say, okay, if this is what I'm working with as parameters, maybe I can kind of find the optimal defensive liquidity distribution in my pool. Or maybe I can find the best like truncated oracle design or medium oracle design, something like that. And it's basically just solving a constraint optimization problem and check if the cost of manipulation is greater than the gain by some margin. You know. And the last thing here I want to talk about is, I guess I'm just kind of reiterating some of the design space that's maybe new in Uniswap v4. So for example, you can, well, this is available in Uniswap v3 as well, which is you can kind of generate your own defensive liquidity and use it as a means to defend against these attacks. And bear in mind, the really kind of convenient thing or things are, number one, it's a geometric mean, at least in Uniswap v3. So as you push price farther away from your current mid price, it's kind of mechanically true that it becomes exponentially more expensive the further out you go. And also there's a fee component. So it might be only a 30 basis point pool, but if you're buying ETH for like $1 billion per ETH, then it's really, really expensive to push price marginally further. The second thing you can do to increase your liquidity is you can first start bootstrapping your protocol around pools that are well established, right? So for example, like WETH USDC pool or USDC USDT pool, these are pools with very deep liquidity. And if you start with those pools, you don't have to bootstrap your liquidity from zero. And you can just say, hey, you know, here's my v4 hook that implements this very stable oracle. Why don't we try that? That's a good starting point. The second thing you can do is increase latency tolerance in your oracle design. And that's really up to the product that you're trying to push to market based on the oracle, right? So I've run this poll of like which use case has the highest demand for oracle liveness. I think it's just related to the inherent leverage in those products, and perpetuals won the race, I guess. But again, like these things, you can kind of design them around the most feasible oracle that you can come up with. And there's truncated, medianized, and many more type of design that you can implement in Uniswap v4 through hooks. yeah, same thing. You can kind of increase the max deviation tolerance. Again, Uniswap v4, hooks, good place to start. And that's all I want to talk about today. Oh, sorry, I just realized I added some lines for other talks at Uniswap Labs. If you want to watch them, maybe just check their Twitter account. I'm sure there's a calendar out. But yeah, otherwise feel free to DM me on Twitter or through my own personal website. I'm happy to look at your design. Thanks.
Hi.
Hi.
AMMs arguably can't represent the whole market, no matter how close tracked they are. With spot price, it's manipulatable, and the top price is not accurate enough. What do you think, as an industry, we should just drop the idea of using AMMs as oracles at all?
I think it's a radical idea. I think, yes, I agree that AMM is not the entire market, but also like no other market really is. And it's really just compare, again, like the whole point of this talk is to say, you know, you can't just wave your hand and say, hey, this is the best possible. It's never going to be manipulated. But rather, it's really a cost versus benefit comparison in the mind of the potential hacker. And you have to be one step ahead and say, hey, I know this is what you're going to do, but every time you do it, you're going to lose money, so you might not do it. And so, again, like AMMs, they're not the entire market, but they're subject to arbitrage, and so their price is basically tracking the global price somewhat. And working with that design, you kind of work out and back out your math of saying, this is really a constrained optimization that I'm doing, and my oracle is somewhat close to the true price. And it definitely brings the benefit of decentralization and all that, and I'm sure you know of.
Any other questions? All right, David. Oh, over there.
Hi. Are you familiar with Anja Finance, by any chance? It's a random new protocol.
Not yet.
Okay, yeah. So they have basically, it's a borrow market. I'm not super familiar with it, but they actually are Oracle free. And I think they use some kind of arbitrage for that, which is specific to their protocol. But I'm curious if protocols could use maybe AMMs or even centralized oracles, but then have some kind of fallback mechanism where you can have some kind of arbitrage if the oracle is like wrong, basically.
Yeah, I mean, it is one of the design. A lot of option oracles are trying to build basically this market-oriented approach and say we're oracle-free. But just as Uniswap pools, oracle-free kind of means that we just don't update and we wait for the market participants to update us. So if you're working with that assumption, then you have to know that just as there's some toxicity flow discussion occurring on Uniswap pools all the time, that might happen to your own design depending on how you have incentivized people to participate. So no oracle just means there's an inherent oracle of like not updating. Yeah. All right. I think time is up, so maybe.
Everyone give it up for Jin. Thank you very much. Everyone give a warm welcome to Matthias from Chain Security. Take it away.
The big one. Okay, I'm very happy to be here for the first time for DSS. Last year at DSS, Anton, one of our engineers, was there to then present what is now known as read-only reentrancy. And I'm using this opportunity to present something new we have been working on also here for the first time to address more a practical problem. And that is like to validate deployments. So just very quickly about me, I'm CTO at Chain Security. have been in the space for some time, right? But the authors of what I'm presenting here, especially Hubert, has been in the space for a lot longer. The only time you'll hear the quick chain security thing, so we are auditors, right? We work with all the big projects and have been doing this for quite some time so far. So now to the interesting part. What challenges do we face with deployment validation? What challenges do we face if deployments go wrong? So, simple things, like you can incorrectly configure your deployment, right? You can have wrong code deployed, something you didn't intend, or perhaps like something you didn't have audited. You can even think of malicious deployers pretending to deploy one thing, but really deploying something else, right? And then on Etherscan, you upload a code which actually doesn't reflect the reality. We can have incomplete or broken deployments, right? Deployments can go over multiple steps. You need to make sure that in the end the system is consistent, but you are deploying in a system like on Ethereum, which is public. Everyone can interfere in between. And in some cases, you might do an upgrade, right? And in this case, you did have previous state, and now with the new code, the previous state might interfere in ways which you didn't intend it. Now, to those of you where you think, wait, okay, that all sounds a little bit theoretical, I don't know how many those are, but there are many examples actually of how this really did go wrong. Now, this is where the presentation doesn't go slide by slide, so you can't see all the tweets. Sorry for that. So I'll just have some cases here. Like the most, like perhaps one of the famous ones, Tornado Cash governance takeover, right? So it was a case where someone deployed an upgrade and wasn't perhaps checked carefully enough that there was a self-destruct inside of that code, and that allowed the person to, like, because it was deployed with create2, right, to redeploy. Other cases, like of systems where actually the security on the code might be fine, but it's secured by some multisig, which is actually not a multisig at all, right? We had several very big hacks, which happened to be like that. We had the iEarn, I don't know if I pronounced it correctly, case, like the predecessor to Yearn, which had a wrong USD token configured, right, and got exploited this way, and so on. So I can go on, and for all of these cases, there have actually been exploits. The thing is, like, this is not covered by auditors so far, right? We as auditors, we do focus on the code. We do expand from there, and this is a natural expansion. So what if you could easily validate, just for starters, like which address contains audited code, right? You can go in Etherscan, but you don't know, has this code been audited? It's very hard to figure out, actually. You have a Git repo, right? Where is that code? Is that the code which is live? Am I looking at a newer code which has been updated, push domain, whatever, right? Very hard to figure out. As an auditor, you do have some implicit idea of like a trust model, but is it still valid? Is the system still behaving like that? How can I detect suspicious admin activity? How can I warn for the Tornado Cash case of self-destruct and create2? Can I make all of that not like a lot easier to validate? And in the end, a nice bonus, if you know a system is insecure and you want to prevent people from using it, just to warn them, like, be careful here, right? Can't you somehow do that? So there are some solutions for that, but that's a nice side effect of what I'm going to show here. So, welcome to deployment validation. We propose something we call deployment validation files. So there's very simple files. They describe a correct deployment. They just state this is what it should be. There's one file per contract. You can have them composable. You can upgrade them. And it's a system which is meant to be like trustless, independent. It's not controlled. It's not something from chain security, right? We present a new standard here, which can be used to achieve that. We give a reference implementation, but all of that is open and free to use. So I'll give you quick motivations like for these kind of files from the different perspectives. So you are a project and you did write your code, you got it audited or not, but now it's time to deploy or it's time to upgrade, right? Depending on your use case. But did it go correct? Like, did the deployment work as expected? You can have transaction reordering, you can have reverts in there. Some people might, some bots, right, might have seen something, try to front run your initialization. Are you now really the owner or not? Are all the contracts you used, which you set up, the correct ones, right? And is it what you tested? Is that also what happened on chain, right? You might do the thing which we always suggest people to do, like do fork mainnet tests, but also they depend on some historic state, right? They seem to work. Now you deploy, you want to make sure it's the same thing which I used to assume the case is. From the auditor perspective, why stop at just auditing the code, right? So you did audit the code. You do understand that system, but deployment often is out of scope. So now you can check it, right? You can say constructor parameters, are they what they should be, but also are the follow-on config changes done in separate transactions, are they what they should be? And as an auditor, something which I also struggled with when creating that presentation is like you do have an implicit or explicit trust model in your head, like assuming certain roles behave in a certain way. But often that's not documented. Very few audit reports do say what the trust model is. And then for users, it's hard to say, is it like safe to use, right? So all of this is from the auditor perspective. Now, a simple perspective from the user, like really you just want to use safe smart contracts, right? So how do you figure out, has this code been audited? How do you check if the deployment is still secure? Did they do some upgrades or not? Did configuration changes break the project, right? I mean, all of that happened. A very practical use case. Some of you might be delegates. Some of you might be in charge of having to sign off on an upgrade. And I myself am, and that is too much work in that sense that you think it should be easy to check, but it's not, right? It's really hard to figure out, is that upgrade what they really wanted to do? Did they set all the correct parameters? Very tedious work currently. So who audited it and who checked those values independently? Why does everyone have to do the same work over and over again? Lastly, integrators' perspective. This is another project. Like many people want to integrate with Uniswap, with Aave, with all the big projects, right? And then you always need to make sure, are you integrating with a version you are expecting? What trust assumptions did that version have? Is the code I'm looking at the code which is on chain? It can be pretty annoying, right? Some projects do a good work, but many, it's very tedious to figure this out. And lastly, some assumptions might change over time, right? So famously, you might read that in many audits reports, right? Fee on transfer breaks your project, but you say, well, I am not going to onboard any ERC20 which has fee on transfer. But then again, like USDT has it. Like they can activate it, right? Another thing which sometimes happens, like for Uniswap, LP fees. So the fees which like Uniswap would get directly through LPs, they are disabled, right? A big discussion. And what happens if they get activated? Like these assumptions for integrators, they are very important. So I'm going to introduce this. So we want to have that new format, which if you come from the DevOps side of things, think of it as Terraform, right? It's a file which describes the state how it is supposed to be. It ensures That's the starting point. What you have in your Git repo is what's on chain. Pretty simple, but it goes way beyond, right? So here, like, it documents the expected state, the expected critical contract state. For example, proxies, right? The proxy should point to some implementation, right? And if it changes, you want to know. But there are many other variables, like it can detect if those things change, and it can also make sure they didn't change and change back, right? You can imagine this case, someone upgrades to a malicious implementation, does some state changes, updates back to one which you think is fine, and you will never notice, right? So it covers this by tracking the state diffs over time. And lastly, it allows you to reference other deployments. So you can say, like, I'm dependent on that system and so on, and that system has a certain assumption about the behavior and so on. So you reference that in the files. But I'll just quickly show you, let's see how well this works, what this would look like. Okay, and just very quickly, general idea. Project deploys contract at some point, runs a lot of configuration transactions. Someone who creates that file would then go ahead and later create it based on a snapshot after the configuration has done. And then at any point in time later, right, usually much later, a user would validate, is that file still valid? Is that deployment still what's expected to be? Okay, so just to show you some stuff. How does it look like? I picked kind of a random project we are not associated with, and in this case, that's Eigenlayer, right? So all you need to do, you need to say, like, this contract is at this address. And then, version, chain ID, but that's very simple, right? That's all you need to do. Then you start, you see the command line here, right? So you say, like, hey, my code is at Eigenlayer contracts. This is a proxy you saw before, like I was saying, like it's a transparent upgraded proxy, right? So we tell it where's implementation. In this case, it's an implementation strategy manager. This is needed to resolve storage variables. And then you just reference that file. In this case, I'm also giving the initial block. And this is because by default, if you don't provide it, it will take the block right after the contract has been created. But in this case, a lot of config settings were set in future blocks, so that we see what happens there. I have that. So I might switch to my laptop because you did not see what was supposed to come here. Is that possible? No? Okay. Okay, that's a little bit hard. So you, Is there someone who can support this? Like what? Just keep going? Okay. So you'd see some output here, which is not visible. And it would tell you, like, the bytecode has been verified, and it would decode state variables. Let's see. So I assume this also doesn't work. Like, this is a longer video on how the thing works, right? So that's unfortunate. The presentation will be online, so you can check there, and then all of that will be available. So I'll just try to briefly explain some important parts in there. Most importantly, so it generates a JSON file which describes the critical storage slots. It decodes them in a way so it's clear for you what you are actually doing, like it's balances and not some random hash and so on. It tells you where these things are, right? And then you can edit that file. It dumps the full state, but for us it's important to define the critical state. So basically your job as someone who creates those files is to delete a lot of stuff out of them, where you say, like, look, that's not a critical state, it's supposed to change. It will dump all the events which happened, and then you'll delete everything which you say it's not important to stay the same. But some critical events like upgrade it and so on, you would want to keep it. So now the big thing is like how does it all work, right? And most importantly, because we are in blockchain, who do you need to trust to make this thing work? So the idea is no one, right? So anyone can create that. There is an on-chain registry where you can say, I am someone who creates these DVF files. You can register there, but in the end, the user is empowered to say where they want to pull it from. The DVF files can be signed, right? You can sign them with Ledger or with private keys or whatever. And users would generally say, look, I trust certain, perhaps auditors, certain providers to give me good information to delegate trust to them to some degree, but also you make it very easy to inspect what did they actually sign off on. So some hard things we faced while doing that. Obviously, how do you make it pretty smooth to decode those values? You can, like a slot, Ethereum storage slot, looks like that, right? So that's a mapping in this case, and you need to tell someone what it really is, right? In this case, balances.owner, and the value is not 246D hash whatever, but it's 42 times 10 to the power of 18, a lot more easy to understand. If someone put in state you didn't expect, it will not be able to decode it. It will warn you about it, so you can say like, hey, what has been going on here? We have versioning included, so because contracts do upgrade over time, right, and so on. So you can do all of these things. What works already is if you have a Foundry project, and like a big shout out to EtherRS and the things, all of that is built on top of that system, then you can run it already. All right. Then we can validate them. We can do upgrades, create new files based on new state. They can already be decentralized distributed and fetched and so on. All of that is working. You can sign them so far, either you have a private key on your disk, right, or you do have a letter to sign off. So all of that is working. As a quick summary, take-home message in this case, like deployment validation enables like projects to show that their project has been deployed correctly, both to them and to others. Auditors can document what deployment states are safe. Users now have a very easy way to check if that code has been audited, if it is still what they intend. Like DAO voters have it much easier to see like what I'm actually signing off on was the intended changes. And lastly, integrators, and then obviously we like builders, this is very important. They can really ensure that they are interacting with the right system, make that much easier. And also they get the trust assumptions around this. Then they're very, like, you would have seen it before, but they're very easy to generate, right? And then very understandable, like much easier than anything which I have seen before, where you had to go to multiple websites to do this kind of things. And my message here, of course, you should start using them. Now, using them is currently something which we want to enable the first people to do it. Like we never brought this out, so we want to get feedback. Please, if you are interested to try this, to use that, go to GitHub/chainsecurity/deployment validation and say you're interested. Before we make it public, like open source, we want to get some initial feedback from everyone to fine-tune it, to incorporate that feedback. And we have an idea of future features, there should be an EIP which describes that file format. There should be like perhaps hardhat support to support older projects and so on, right? Or ones which use hardhat today. Many of these ideas, very welcome for input from your end, what you would need for this kind of stuff, and then obviously collaborate. Like this will be an open source project. So. Ah, okay. The video? Nice. I know I'm out of time with the speaking time here, but. Yeah, sure. Oh. Okay, yeah, I think that's it. Yeah, so you see this file which was created, like contract name, right, where it's at, the code hash which has been deployed, these are the important parts, and now the list of the critical storage variables. Like, it has been initialized. Initially, I was very confused when I did it for the first time because it wasn't initialized. You see the owner, you will check, is that the intended owner? You have some other variables, like for example, the status here. You might say like, okay, status is not a critical one, right? You get rid of it, you delete it. Then we check all the others, implementation and so on, generally very critical storage slots. We go down and see that there are critical events, like the admin has been changed, right? What happened here? You'll want to reason about what happened here. The beacon upgraded. It did never happen, but you want to document that it never happened, like, because when it would change, you would want to make that this file becomes invalid. And here you do see that actually this contract has been upgraded twice, right? And actually it first was upgraded to empty contract and later to the implementation contract. So these kind of things you can very easily see here. We still work a little bit on like making it even easier to decode. And then in the end, you can also say a little bit like who you are. You can sign off on this. You can describe what you are seeing. And the idea is this file will live in the project repo. So people have it very easy to say like, hey, this is where things are deployed. This is what it describes. But it will also live inside auditors, like auditors or other trust providers will give this out and then give their idea of what they think the system is safe. And then you can compare. So, yeah, this is how the file currently looks like. Thanks for making this possible.
Give it up for Matthias. Thank you very much. And the last presenter of our session, Dimitri from ABDK. For Dimitri.
Hello, everyone. How does this super cool thing work? Okay. Is there any back? Where's the back? Okay, cool. Hello, everyone. I'm Dimitri Kovatovich from ABDK Consulting and in parallel also from Ethereum Foundation. So some of you may know me as an auditor, some as a cryptographer. And today I'd like to talk a little bit about security of DeFi and internal applications in the world of zero knowledge. And well, the talk is pretty short, but I would like to introduce you to some really nice bugs that you can see there so that you can get some understanding what are the real problems of when you coding your application in zero knowledge. So you may be familiar with zero knowledge not only in the context of proofs, but also in the context of rollups. And you may know that a typical scenario in Ethereum is, of course, you just submit a transaction, then it's executed on all nodes, and then the storage is updated with the results of the transaction, well, if it's executed correctly. And in the ZK rollup scenario, it's a little bit different. So instead the transaction itself is fully executed on the nodes, the transaction is crafted on the side of a so-called prover, but then it's a proof of its execution is submitted to Ethereum, and the proof is verified on all nodes. And then the storage is updated. So the proof
just convinces all the nodes that the storage updated has progressed correctly. So the node themselves, they don't know what are the all steps that led to the storage update. They just check that the update was done correctly. So what's interesting about it is that, of course, the nice thing about it is that when a transaction is big, then it's, of course, better so that it's executed only on the prover side, and the other just verify that it's correct. So the verification is faster than processing the transaction itself. The downside, of course, is that still the verification of a ZK proof is somewhat expensive. So we may hope that in the future we can aggregate these proofs, we can batch these proofs, we can do various optimization with those. But so far, well, as you correctly mentioned, so ZK rollups are still somewhat expensive. Another interesting downside, well, not a downside, but rather a feature of ZK programming is that the language that is used there, it operates on a bit different domain. So you may know that in usual programs, well, in Ethereum virtual machine or in Solidity, you operate with 256-bit numbers and you use 256-bit arithmetic, or in a regular x86 machine, you use like 32, 64-bit words, bytes, and so on. So they are all aligned to powers of 2. But in the ZK code usually uses a different domain. It's called a prime field. It's a set of numbers that are smaller than certain prime p. And as you get, and you can infer from the name, this prime is not a power of 2 because it doesn't factor into other numbers. And because of that, there can be all sorts of issues when you code in ZK. So we at ABDK, well, I'm DK in ABDK, and the other AB is my beloved wife, Anna. So we at ABDK with my longtime colleague Mikhail has audited a lot, really numerous projects that did ZK programming, and we have found quite a number of bugs. Well, most of these bugs are pretty subtle, so I will not go into details. But I will try to cover the most kind of simple ones, but still kind of informative enough for you to see what's the issue of ZK programming. So when you talk about ZK programming, we usually talk about so-called circuits. So circuits are not exactly the programs. So circuits, the feature of circuits is that they consist of so-called constraints, and these constraints are relations between the variables rather than functions that are executed on those variables. So in regular coding, you just do instructions one after another. In the world of constraints, you impose relations on the data. And if you are familiar with, for example, database programming, working with the relations is way more different than working with real code. And with circuits, when we code in circuits, we have to satisfy two basic properties, which cryptographers call completeness and soundness. So, and they are like two sides of pretty much the same thing. So the understanding is that the circuits should behave exactly as the code. But what does it mean to behave exactly as the code? So on one side, the data, by completeness, we mean that every valid code should satisfy the constraints. But on the other hand, if constraints are valid, this means that the code must be valid. And this is called soundness. If you make a mistake in either side, there will be problems. So sometimes people say, well, completeness is not that big a problem because, well, in the worst case, maybe you can just regenerate your code. So the problem with completeness is you have some execution that is valid, you just cannot make a proof for it because of some bug in the circuit. But the thing is, of course, this may also lead to fund loss. For example, if what you are going to do is to withdraw some money from a rollup, for example, and if this transaction doesn't work, if it cannot be converted to a valid circuit because of a circuit bug, then you're screwed. So both may lead to funds loss, of course. And let's see some concrete examples. Well, not about the fund loss, but let's see concrete examples of bugs. What bugs are there? So the interesting thing about problems in the code and in the circuit is that when there is a bug in the code, is usually when someone exploits this bug, it's noticeable. You can usually, so the traces of exploit are stored, in particular when you submit, when it's in the blockchain, that everything is in the clear text. So a person submits a transaction, you see who calls which contract, you see all the commands, you can see the entire stack of code execution, and everything is clear and it's very noticeable after after the code was exploited. The situation in the circuit is different. The difference is that since only a proof is validated on the nodes, the transaction itself is not validated. And because of that, if there is a bug and an adversary is able to create a proof, a valid proof for an invalid input, this means that the proof will be seen as valid. Everyone sees that the proof is valid. But the input is not known. The proof just asserts there is some input that satisfies the circuit. But if the circuit is wrong, you just don't see this input itself. Well, for data availability purpose, we often require that the data is provided so that the transaction should be reconstructed. But in general, if the proof is valid, you don't see what happens inside. And because of that, it might be very difficult to trace. If there is a subtle bug in cryptography or a bug in code in circuit programming, you may not see exactly how it was exploited. You just see, well, there is a valid proof, and then all funds are lost. So you must be very, very careful when programming circuits. So let's see some small examples, what I mean when I talk about constraints. Suppose that I execute a code where I compute a square root of x, so y is a square root of x. Assume that x is a perfect square, so we don't have any irrationality here. So suppose that y is integer here, and then in the circuit program that y and x are linked by some relation. What relation is that? The relation is that y is a square root of x. It's the same as y square is x. Is it the same? Well, it's almost the same, because we want to exclude ambiguity here. The ambiguity is that if you tolerate negative numbers, then you should make sure that, for example, y is bigger than 0. Well, I already have strictly bigger than 0, but if x is allowed to be 0, then y can be 0 as well. And constraint here is that y square equals x, and y is bigger than 0. So far, so good. So for this sort of arithmetic operations, writing constraints is not that difficult. Well, ensuring that y is non-negative, somewhat difficult, but we can omit that. So assume that you can do this range check. So this is a simple constraint. But let's go into some more interesting examples here. So before we go into examples, I explain why it's a problem that you work on a different domain. So in ZK programming, and when you talk about things like ZK snark, we operate on so-called prime fields. This means that all operations are done modulo p. This p is typically for snarks, is close to 2 to the 256, but it's not at all 2 to the 56. Because of that, when you do operations where the result or intermediate variables get close to this barrier, to 2 to the 56, you may get problems. And these problems are exactly here. So you see, for example, when you have like two variables, x and y, and so that they are multiple overflows to 2 to the 56, then in plain EVM, you just get model reduction. In Solidity, starting with SafeMath check, you'll get a panic. But in zk-snark, what you have is completely different. You don't get panic, you don't get modular reduction. Well, you do get modular reduction, but this reduction is modulo a different number. So you multiply 4 by this 2 to the 54 plus 1. What you get is 2 to the 56 plus 4, but this modulo p. Well, this p is known, it's a constant, but it's not at all 2 to the 56. So the result is some weird number, possibly 250 something bit long. And as you can see from this example, you have to take care of this so-called edge cases. So whenever you approach, wherever your arithmetic may approach 256 bits, you have to somehow constrain it. So basically, you have to prove that overflow doesn't happen in your case, because if it happens, it's very difficult to recover. So let's see which problems it brings us. And let's consider the second example. The second example is modular reduction. Suppose I want to prove, so I execute in the code A modulo B. Well, A and B are just valid numbers, valid integers, they're both bigger than 0, and R is, there is the remainder. So is it okay if I program my circuit and I write this constraint that A is just Q times B plus R? This is the definition of modular reduction, right? So is it enough? A equals Q times B plus R. Well, clearly it's not enough. You should probably introduce R smaller than B. Then it's almost enough, is it? It would be enough if we worked in integers, but we work in modulo P. What happens modulo P? In the world modulo P, everything that may overflow will overflow. So how it looks exactly here. The thing is, adversary who want to submit invalid data and get a valid proof, adversary may be able to select both Q and R maliciously. The Q, you don't even care here. You may not, you think, okay, what's the problem with Q? I ignore Q, I only care about R. But the thing is, you do have to care about Q. Why is that? The thing is, in the field, any number can be divided by any other non-zero number. The division is always producing a valid operation and a valid output in the field. And the thing is, if adversary wants to get certain R as an answer, for any R smaller than B, bigger than B, there exists a Q that leads an adversary to this result. So if you simply give this as a constraint, what adversary gets, what adversary selects, he selects Q equal to A minus R divided by B. And this division always works. In the field, everything is divisible by anything non-zero. And if you substitute A minus R over B to the constraint, you see that the desired R will be the output. So if an adversary is able to select both Q and R, then you're screwed. I will later see how we get around this problem, but this get around is rather complicated. So let me maybe outline several sources of bugs, several kind of most error-prone scenarios when we have this or similar problems. So whenever we have arithmetic that goes over the entire domain, so if you work with numbers, then that with multiplication approach to 56 bits or close, then there might be a problem because you have to range check almost every operation in your arithmetic. Whenever you have divisions, you see you have a problem because division in integers works differently from division in fields. You have to take care of that, you have to always keep in your head that everything is divisible by anything and the result may explode. For example, in a field, you can divide 2 by 3 and the result will be just a huge number. whenever you have branching in your code, it's usually non-trivial in the circuit to implement it, because you have to compute all of the so-called flags, and you have to make sure that only one part of the circuit is executed or taken into account depending on the flag value. And of course, whenever you have so-called invariants, and you have to work with relations among the data rather than direct functions with the data, then you also have problems. Let's see if, no, I don't have this update. Okay, so these were the most popular things. The less popular things are, I just listed here, so if you want to program some kind of finite automaton, like in zk-sync and its relatives, if you do range checks, then sometimes you may have problems. If you work with different flags, like if A, B, C, and D happens, but E and F don't happen, do this. And at the same time, if B and D happens, but E doesn't happen, then do that, and so on. So all this sort of exploitable. All the edge cases that in normal code are never executed will be exploited, because an adversary can select all the variables that are part of a circuit that are not enforced from outside, and usually an adversary can exploit these edge cases. So these edge cases that can't be reached in a normal code will be reached by an adversary. So you have to double care about those. And of course, whenever you have some implementation of cryptography in your circuit, it's also error prone, because usually cryptographic schemes have very strict restrictions on how they are used and with which parameters, and because of that, it's easy to misuse those. So getting back to modular reduction, let me see if I do have modular reduction here. No, not exactly. So with square roots, actually, the problem with the square root also here, the so-called geometric mean bug. When you have two numbers, both of those smaller than 256 bits, and you want to compute their geometric mean. The problem is that the multiplication may overflow, and it's not even obvious how you deal with this overflow, because both A and B are valid inputs. So you can easily program the second part, that x squared equals to z, but dealing with overflow is non-trivial. What you have to do, you have to partition the number into kind of chunks and do kind of schoolbook multiplication and deal with those. So you see how it's done here. You can you split actually not into 2 chunks but into 3 chunks, because when you multiply these guys, you have to ensure that they will not overflow themselves. You have to switch the representation for A, for B, for X. You have to multiply all these guys. You have to check the equations for different terms. And only after that, you can make sure that this geometric mean is computed correctly. Pretty much the same thing happens for modular reduction, for a long multiplication, and so on and so forth. So I think I'm running out of time, and I will not go into branching bugs, but those who are interested may go into our audit database, where we have a number of audits for various zero-knowledge projects and circuits, and see what kind of critical and not so critical but also dangerous bugs we have uncovered. Thank you.
Thanks a lot, Dmitry. Time for one question. Anyone? Okay, cool. Thanks a lot. 15-minute coffee break. Thanks, everyone.
No, don't. Okay. We have a break until 10:55, but we have good news. We're going to have coffee downstairs all day long.
Oops.
Hi everyone, we'll be starting again in 3 minutes. Thank you.
No, you're good, you're good. Oh, good. Yeah, all sorted. Thanks, Lou. All right. Good morning, everyone. We're about to kick off session 13, Monitoring and Incident Response. My name is Mehdi, co-founder and director of Sigma Prime. I'll be your chair during this session. If you are still downstairs grabbing coffee, croissants, please make your way up to the auditorium. We'll be starting with Andy Zhu, CEO of BlockSec and professor of Zhejiang University, who will be talking to us about securing Web3 through proactive threat prevention.
Okay, thanks for your introduction. My name is Andy. I'm the CEO of BlockSec. Today I'm going to talk about the way to secure Web3 through proactive threat prevention. So Blockstack was founded in 2021, backed by some top investors and customers, and we have a couple of products, available to the community. Like the Falcon, I think most of the security researchers, they already use our Falcon Explorer to virtualize the transactions, and we have the Metadoc, Metasnooze, which are free to the community. So why security matters in Web3, right? So even in this bull market, even in the cycle of the bull and bear markets, the losses caused by the DeFi hacks and DeFi scams are really increasing. And this is not just the numbers, right? We're receiving the emails every day from the victims of the attackers and the scams saying that they have been attacked, they lose all the money, and they want us to help them. So this is just not the numbers. They represent the individuals who are facing the bankruptcy after being attacked, right? We have to help them. So why DeFi hacks are very common today? I think there are a couple reasons. One reason is that we have the attackers, they have the economic incentives to perform the DeFi hacks, because by performing the DeFi hacks, they can get paid. They can get paid by a lot of money, right? So, and we do not have enough security qualified developers. Some developers, they are more focusing on the functionalities of the protocol, right? They do not have enough security trainings, and the universities, they do not teach the blockchain security courses. We do not have too many courses currently available in the community, in the universities. And also, some hackers are performed by the countrywide organizations. I do not need to talk too much about this. I think most of them will understand that. So when talking about the security of the protocol, most people will think about the code audit. Yes, and the code audit is the most common way, to solve the security issues in the DeFi protocols. We think the code audit helps, but the code audit is not enough, right? That's because the qualified auditing services are very expensive and also time-consuming, right? You need to wait in 2 months or 3 months, even half year to be audited by a top audit firm. So you can, some protocols, they do not have enough time to wait, right? And also, we do not have enough qualified auditors in this space, right? So if one auditor firm, they just issue the auditor certificates, and this certificate will eventually no longer be trustworthy by the community, right? So because of these reasons, the protocol have to go live without some battle-tested threat prevention and attack prevention solutions. They just go live without any security measures in their hands. So because of this, we need to have a more proactive approach, right? So the more proactive approach means that a protocol needs to know what is currently happening to their protocol. They cannot just put their protocol online, then go to sleep, right? They need to know what is currently happening, who is interacting with the protocol. Then something bad happens, the protocol needs to know how to automatically respond to such attack transactions, to respond to such bad things, right? So why the proactive approach is much important in Web3, right? Because we also have the Web2 security, and some guys saying that, why do we need that in Web3? Because we do not have that in Web2, why do we need have this in Web3? That's because the Web3 introduces much more attack vectors, and the openness in the blockchain makes the attack much easier than in the Web2, because everyone can looking on a smart contract on the blockchain. Most of the smart contracts on the blockchain are open source, so the good guys and the bad guys, they can see all the same source code, right? They can find the vulnerability in the source code. Then if there is a vulnerability, then they can attack the vulnerability to gain a large number of profits. And also because the blockchain is anonymous, it's very hard, if not impossible, to track the funnel flow of an attacker, right? So when an attack happens to the DeFi protocol, we always saying that the protocol asking who can help us to contact Beyonce, who can help us to contact some exchanges, because it's very, very hard, to track the funnel flows for the attackers. And also, the flash loan helps to enlarge the money that an attacker can have, right? So in the Web 2, if you find a vulnerability, and in order to launch this attack, you need to have $2 million, but most of people, they do not have such a big money to launch an attack. But in blockchain, you have the flash loan, right? You can borrow a very large number of money from flash loan services, and then launch an attack, and then pay back to the flash loan. And also some private transaction services, it can be abused, to launch an attack. We have seen so many attacks, they were abusing the Flashbot services, to issue the attack transaction from being observed in the memory pool. So because all of these unique properties in the Web3, the attackers happened in Web3 space cause more damages to the protocols, cause more damage to the users, right? And it's much hard to track the attackers in Web3. So because of all these reasons, so in BlockStack we have developed a prototype system since last year, since February 2022. We are thinking about how to solve these issues besides the code auditing, right? So we think can we take a more proactive solutions to defend the DeFi hacks? So based on this source inside BlockStack, we have developed a system called Falcon Block. So Falcon Block, the basic idea of Falcon Block is that we can listen to the transaction inside the memory pool. We can listen to the transaction on the blockchain. We also listen to the reverted transactions, right? So why do we need to listen to the reverted transaction? That's because the attackers, they may make a mistake, and the attack transaction can be reverted, right? So if we can capture such reverted attack transaction, we can also automatically make some response. After that, we can reconstruct, right? We can reconstruct the attack logic by replaying the attack transactions and copy the essential logic, attack logic of the attack contract to synthesize a new rescue smart contract and then issue the rescue transactions through some flashbots or through by giving a higher gas fee, something like that, to make sure that our rescue transaction can be much quicker or can be on the blockchain behind the attack transactions. So by doing so, right, we can even block the attack transactions, right? So because we are much faster and we are we are in the header of the attack transaction inside the block. So the essential part of this mechanism or this system is how to automatically reconstruct the attacker transaction and the attacker contract. So I think the basic idea is think about attacker transactions and an attacker smart contract. What matters most in this attack contract, right? So what matters most is the attack logic inside this smart contract, and also the attackers they will perform some authentications to the callers of this attack smart contract because they do not want their attack smart contract being called by others. So you need to bypass all these checks automatically, right? So what do we do? So we replay this attack transaction inside the memory pool. We can get a chain of the basic blocks or the trace of this attack transactions, right? Of a chain of the basic block. So in this chain of the basic blocks, we can replace the jump I instructions. We call the frozen the jump I instructions into the jump instruction, jump to the attack logic instead of the reverted basic block. That is because of the failure of the authentication of the attack contract. So we can simply replace the jump I instructions to the jump instructions. So this is the basic idea of how the methodologies. But when we do the but just simply replacing the instruction does not work in all cases because we have some technical challenges. One of that is how to deal with the reuse basic block inside the smart contract. The reuse basic block is a very common usage by the bytecode generated by the compiler to reduce the size, to reduce the code size. So suppose we have like two different jump targets, RA1 and RA0, and we have some new jump targets, right? So we need to have a mapping between this old jump target and the new jump targets. So we use a trampoline basic law for this purpose. So the basic idea is it's just similar with the binary code rewriting, which we have started and developed, I think, more than 2 decades, right? Even earlier for the code rewritten techniques. So we borrow the similar ideas and used into the bytecode rewritten. And by using this system, we have a couple of successful stories to rescue the funds to block the attack transaction for a couple of protocols. Like we rescued $500 million this year for the Perispace and $3.8 million for the Settle Finance last year, and a couple of others. So in the following, I'm going to talk about a couple of representative examples of how we block these transactions. So for the Perispace, which happened, the attacker happened this March, right? The attacker made some mistakes, right? So they did not give enough gas to perform the attack. So the attack transaction reverted. As I just said, we listened to the reverted transaction on blockchain, and we found that the transaction was reverted, and we found it's an attack transactions. And then we automatically synthesize a similar attack contract by replace the profit addresses with our own addresses, and we issue these transactions, and the transaction successfully on the blockchain to rescue the $5 million for Perispace. And another example is a Platypus, which was attacked in this February. The smart contract has a vulnerability, and the attackers they attack this DeFi protocol. But the attackers, he or she made a mistake. There is no logic to withdraw the funds inside the attack smart contract. So the question becomes how to withdraw the remaining $2.4 million inside the attack contract, because there is no logic, to withdraw these remaining funds inside the attack contract. So because we have an internal system to automatically disassemble the attack smart contract, and we have some heuristic, to analyze this attack smart contract, and we found a couple interesting facts about this attack smart contract. First, the flash loan callback of that contract is open. Second, the USDC approved to the Platypus pool contract. So what can we do? We can upgrade the pool contract and use the approved privilege by the attack contract to withdraw the remaining USDC, right, inside this attack contract. And we shared the proof of concept to the protocol, and the protocol successfully, withdraw $2.4 million from this from attack contract. So another is the transit swap. Transit swap was attacked and front run by MEV bot. So we found that the addresses of the MEV bot was generated by a vulnerable profanity tool, right? The profanity tool, because the vulnerability, we can calculate the private key of this MEV bot, and we can, withdraw our funds and return to the protocol. So how to make this system more effective? I think we have some insights. You need to act fast, right? You need to know fast, and you need to act fast. And accuracy is the key. You cannot introduce too much false positives, as we have a panel yesterday, and we are talking about the false positive of our monitoring tool. If your monitoring tool reports too much alarms to your customers, then the product cannot be used, right? And we can take a systematic way to act, not just from around the attackers. We have some tools to analyze the contracts, to disassemble contract. We have some heuristic, to perform more analysis on the body code. We take all these measures to build a system, to build a product. And we saw an arm race between the attackers and the security researchers. We see some attackers, they are using obfuscation, some runtime measures, to defend all these things. So based on this, we build a Falcon block system, and we have a waiting list so that if you guys are interested, you can join our waiting list, to get updated information of the Falcon block system. And we also have a TG group under the Twitters. You guys, if you're interested, you can follow us. Thanks, and I'm free to take in questions if you have. Thanks very much.
Thank you, Andy. So I think we have 2-3 minutes for questions. Heidi's here.
Hey, I don't want to shill their tools too much, but they're really badass, first off.
Thanks.
Second off, the one question I have is you guys do a lot of hackbacks, let's just call them that, right? How do you guys protect yourselves from the liability of doing that and all of the legal garbage that comes along with doing that?
Yeah, this is a very good question. Yes, and the security ethics is we are taking very seriously. So for the hacking back or for the blocking attack transactions, we only perform these actions after we saw an attack transaction in place. We do not perform such attack transaction, without seeing other ones is doing that. Yeah. So I think because we are, protecting users and we take a proactive approach, if we do not take action, then the bad guys, they will take action, they will take all the monies. Right.
Any other questions? We got a bit of time. Nope. Well, we got one over there.
So maybe that's a follow-up to a question, but so that means that if, let's say, somebody finds a vulnerability that has not been exploited and there is no attack transaction, you are legally prevented from acting on do a white hat hack and save the user's funds?
So we are not, so let me rephrase. So we are not hacking the user's funds. So we just automatically reconstruct the contract by the attackers and then move the funds inside another wallet. Then we will return back to all these funds to the protocol and to the users. So yeah, I think it's debatable for the ethics issue, but if we only do these things with the heart of protecting users, I think we are good here.
Got time for one more. Don't be shy. Yep.
So it's clear you're doing the right thing. Do you have any actual legal protection in place? Do you have a lawyer sitting there and checking that?
Currently, we do not actually. Yeah, but we will consider, hire a new one. Yeah.
All right, cool. Thank you, Andy. Thanks so much. Thanks for your time. Give it up for Andy. Thank you. And just before all the volunteers that have been working very, very hard to put this together. These events, wouldn't be happening without their hard work. So yeah, thanks to every single volunteer who's dedicated their time to making this happen. Thank you all.
All good.
And our next speaker is Adrian Hetman, tech lead of triaging at Immunify. And he'll be talking to us today about stories from other side of the table, how Immunify is fighting for you behind the scenes.
Hello, can you hear me well? Okay.
Get closer, maybe?
Closer, okay. Yeah. So, hello. I'm gonna tell you some stories that shows what it takes to actually handle critical vulnerabilities at Immunify, or basically whenever. Stories that shows the importance of proper handling of responsible disclosures. I'm going to share stories that actually haven't been made public until today. Of course, I wouldn't be disclosing any confidential information because I don't want to dox any security researchers nor the projects, but I will shed you some light on how Immunify and triaging team works behind the scenes. What we do to actually make the project secure and white hats rewarded. So welcome everyone to the stories from the other side of the table on how Immunify fights for you. Next slide. Okay. It's winter evening, 9 p.m. I'm sitting in an almost empty parking lot. in my car, groceries in the back. I'm about to head home to my lovely wife and to newborn child. I start the engine, and suddenly I get a notification. I look at it, and it's from work. I never got notified that late. I open the notification, and suddenly, within 2 minutes, I'm finding myself in a war room situation, because White Hat has found a critical vulnerability that can shut down any EVM RPC node. Number of affected projects on Minify, 15. And yes, that was actually just a Monday for me. So how do you form a war room in a matter of seconds after you still experience some shell shock after receiving the news? You take that deep breath, and you remember that you've done this before. We've been at Minify in this situation many times before. We've dealt with such cases multiple times, dozens of times. I don't know even the hundreds, but possibly that could be true. We've been in that spot before. So we stayed with the hacker, communicating with him over secure channels, and we started planning the responsible disclosure. Because yes, he has found the vulnerability, but we needed to be sure that the impact is actually there, that the report is rock solid, that it wouldn't be dismissed, that it would apply to all the bug bounty program rules for all these different affected projects. And it took time. And actually, we wanted to, apart, of course, keeping hackers' best interests at heart, the bounty rewards themselves, we also wanted to have projects be secure. So after mass disclosure, the chase had begun. We started contacting every project that was affected to look at the report immediately. Some of them responded to us within minutes, some of them within hours, some of them within days. Some of them patched the issue, resolved the bug report, and rewarded the hacker, because the report was well written because we prepared it so well before. But some of them actually, as it turned out, didn't have this impact in their bug bounty program. And some of them claimed that they were protected against this. So through mediation, Minify could officially step in and mediate this case. We look at all technical details across all 15 cases. And we managed to showcase a real impact on the out-of-scope bug to some of the project and get the hacker rewarded. It took us 5 months of effort, 5 months of constant back and forth between the project and the White Hat, analyzing every little detail of every bug report that they submitted. Yes, the bug was actually common on the same on every project, and the 95% of the bug report was exactly the same. But that 5% was so crucial to actually being able to resolve this issue. And it took us 5 months of us battling for you, battling for the project to actually get their project secure, their user secured, and White Hat get appropriately compensated for this. And it's important to know that whenever there was a slight dispute, a slight disagreement, we always encourage White Hat to actually call us in. Because in some of these cases, if we wouldn't be called in, the case wouldn't be resolved. And by resolved, meaning that the project would still be open to vulnerability, and White Hat wouldn't get rewarded. Because sometimes information can get lost, misunderstood. And we are here to actually step in and provide all unbiased technical information, to provide a just and fair platform to everyone to actually talk to each other and to report such vulnerabilities through Minify. And you may sometimes be thinking, okay, this took 5 months, but does it always take that long? No, not necessary. So, some of the issues are more straightforward, some of them are more complicated, but we always do our best. We'll do every length to actually resolve the issue. But actually, who am I really to talk about this? It may be a strange time to introduce myself, but my name is Adrian Hetman. I'm the head of triage at Minify. I've been in Web3 security space since 2020. I've been in crypto since 2016. I personally triaged and mediated some of the most paid bugs on Minify. And I'm honor to stand in front of you and tell you some interesting war room stories from my work. Our platform is built on the idea that the project and white hats can collaborate to mutually benefit one another. By utilizing their backhanding expertise, white hats can help projects secure millions of dollars worth of assets. And in return, projects share a bit of that wealth with the white hats to thank them for their time and effort. And however, as much as we try to build objective metrics into bug bounty programs on our platform, sometimes gray areas are still there. Sometimes edge cases happen. And in such cases, it's always important to call us in for a mediation. Because every crisis situation that we ever handled, and that also I'm going to present right now, was eventually resolved through a mediation process, because then we could officially step in and fight for you. So let's now look at some of examples of different mediations that were eventually a war room situations or a worthy of name of a crisis. This is the case where white hat was right. This is the story that a few of you already may know. Pwning.eth, an elite white hat, has found a critical vulnerability in Moonbeam twice, within the span of 2 months. He got paid for those 2 bugs over $2 million in bug rewards. The first bug resulted in $100 million of potential value at risk, second bug in $200 million of value at risk. Amazing bug report, amazing effort of both sides, but you might not know all the behind-the-scenes details. Because, actually, those 2 bugs were out of scope initially, per bug bounty program rules that Moonbeam has set. So it was crucial, as with every case, to call for a mediation. Because yes, Moonbeam wanted to reward the hacker. They understood the severity of the vulnerability, the severity of the impact, but they weren't sure how to actually reward the hacker based on their bug bounty rules. So they called us in. And also we stayed on a line with the Pwning.eth. And whenever there is such case that bug bounty programs rules aren't clear, as I said before, call for a mediation. And we're always encouraging and pushing for fair compensation as determined by value created for the project. And in this case, the value created was obvious. In total, $300 million saved, right? But it wasn't that clear how to actually progress with that. So through many weeks of effort of navigating through the rules and understanding the technical details of the bug report itself, we managed to showcase the real impact for Moonbeam in both of these cases, and through collaborative efforts of Moonbeam and Pwning.eth acting in a good faith, just wanting to get this bug resolved, fixed, and later, of course, Pwning.eth getting rewarded and appropriately compensated. After Immunify helped, we managed to resolve this, because as with every case, I'm going to repeat this constantly, some of these cases wouldn't be either as successful or successful at all if we wouldn't be called in, because we handled thousands, hundreds, thousands of cases, difficult cases, and we are experts in that. We know how to navigate bug bounty program rules. We know how to navigate impact. We know how to navigate all the technical information because we've done this before. And through collaborative effort, as I said, Bug Hunter was eventually rewarded. And by result, we also updated lots of our bug bounty program rules, created some updates, because with every edge case scenario, every crisis situation, we are always constantly improving, because we don't want such case ever to happen again. And if that case happens, then we can just do business as usual, because we already know how to handle such cases. That's why we're making constantly smaller updates. And each smaller update is based on one of the difficult cases that we have. Next case. Project was right. Because from the previous story, you may think to yourself, why on earth project didn't pay maximum payout immediately? Because it isn't actually always clear if the impact is actually real. In this case, White Hat has submitted a beautiful report. All technical details were already in there. POC was working. It was runnable. He even included funds at risk calculation, $10 million. Everything was in a report. From triaging perspective, it was a piece of cake to triage. But it wasn't a piece of cake for the project. Project disagreed with this report, disagreed with the White Hat. And after having disputes on our platform between the White Hat and the project, we were officially called in. We analyzed every bit of technical information that was shared in the bug report itself, in a POC, and also within the conversation, because new information came to the light. And we eventually got in a call with the project because we had one piece of a puzzle that was still missing before we could give our judgment and our recommendation. And after that call, it became clear that the liquidation mechanism, because bug was around that, was working as intended. And project was actually right. And project closed the report. But the issue lied with the POC itself. Because you see, White Hat made some assumptions about how POC should work, how the liquidation mechanism of the project should work. And that assumptions were wrong. Those assumptions weren't tested. And we always encourage everyone to actually test every assumption because we are dealing with facts. And every fact that we have help us get to the resolution of the bug report. And in this case, we managed to look at only the facts to state that the project was actually right. We provided with all technical reasonings and information to the White Hat. Project did the same. White Hat understood what he did wrong, so the case was closed. And White Hat left happy, knowing how to do better bug bounties in the future. Next case, middle ground. Because some of these cases may be quite obvious, sometimes from the beginning, sometimes after a while. But some of cases aren't as black and white. And it can take months of constant discussion, technical analysis, twice, or even 3 times, analyzing the same thing over and over again to actually understand what's going on. And one of such cases we handled this year, a few months back. 2 elite White Hats submitted a critical vulnerability to a VIP project. The attack vector was very complex. It was weaponizing randomness. And after the disclosure, both White Hats and the project were working flawlessly together to develop a fix to protect the project. And from our standpoint, the collaboration was beautiful until it wasn't. Because you see, the dispute happened when it came to deciding on the final payout and the severity of the bug. The project thought that this was a medium severity impact, not a critical one, and the project, of course, disagreed. And with severity, also the payout recommendations were way smaller than the White Hat actually wanted. And White Hat did point-by-point counter arguments. Project responded with the same, and such arguments arose tension between the two to a higher degree when finally, when project still didn't want to budge about their reasonings, White Hats acted in a bad faith. They threatened the project to go to make this case public to get a higher reward. We at DeFi don't take blackmail easily. We treat it really seriously because we want to provide a fair and just platform to everyone to actually be able to act together to get the project secure and White Hat in the end compensated. And blackmail doesn't help with that. We either straight ban hackers or heavily warn them. Of course, everything is based on case-by-case basis. In this case, I cannot tell you all the technical details, which I wish I could, But the end result was this. The impact stayed at critical. The project didn't pay the max critical payout that White Hat wanted, and they paid much less based on the actual funds at risk after our technical assessment, removing all the assumptions from the POCs and the impact. And middle ground isn't always in the middle. White Hats were left unhappy. Yes, they found a critical vulnerability, but the payout was much less than they expected. But they still got a few $100,000 in reward. And the project was also a bit unhappy because they needed to pay way more than they initially thought. But it's always important to emphasize, in such cases, why we reach such a decision that regards the payment. The decision, all technical details, to lay them out to every party so we can base our mediation on truth. And of course, we have many more cases I could talk about grey hat activity. And as with previous case, this case could go really nasty if we wouldn't be called in. We help to diffuse the tension, and that's what we do in such cases. We diffuse the tension, we go straight in, analyze everything, we clean everything, and provide with clean technical information to everyone, just looking at the facts, to be fair and just to anyone. Because we have rules for a reason, and we execute our rights to ban security researchers or the projects if they go against them. We want to create a fair platform for all parties involved, and we won't accept any bad faith behavior. And each mediation like the ones that I presented, even if we cannot make it public, always results in some improvements on our platform, in some articles that we write for the public to better educate the white hats or the projects. And we will always fight for you, no matter what. But we need all necessary information to do that. We cannot make a judgment call based on a hunch. We need to analyze every possible scenario, every possible edge case. And for that, we need all technical information. And as I said, we will go every length possible, as long as needed, to prove your point, if, of course, you have a valid one. Making predictable outcomes out of BPPs we host is something that we work on every day. And for the future of mediation, we're codifying our best practices. Learn across thousands of difficult cases. And we will form that into a new BPP that will form the basis of our work for a few years to come. And with that are coming investment in other areas around the BPP. We are making tons of improvements, tons of new articles, explanations to make everything more predictable when bug hunting for the white hats and for the projects. And with that, I want to thank you for the talk. It was a pleasure. Sadly, I had a funny video at the end, but it doesn't seem like it will work. But thank you, everyone.
Thanks, Adrian. What up, Adrian? Thank you. We may have time for one quick question. All right. You're very quick.
How do you educate your team on communication skills, peaceful resolution, and like negotiation?
As with everything, we are trying to be always respectful to anyone, no matter who are we talking to, even if to someone who's on basically a grey hat and is threatening a project. We're always respectful, and we always basing our communication on the facts. We just want to have everyone to have a nice time on our platform, and I said that, just and fair outcome. And for that, communication is a key, and we're learning that on every case also because we constantly improving on the ways that we communicate. We starting to add way more information into our remediations analysis that we post to both sides, and we still continue communicating with the White House or the project after remediation has been posted. And with everything, this is just a constant process. We don't have any one way that we can say that we do this and that. We're just trying to be respectful.
Awesome, thank you. Adrian will be around, I'm sure, over the next few minutes, and feel free to grab him for questions. Someone I've met a few days ago and was blown away by the breadth of knowledge that she's displayed. I don't know if you can hear me. Please give a big welcome to Heidi Wilder, a lead blockchain security researcher at Coinbase. The title of her talk is Wrecked Pilled, What to Do When Your dApp Gets Owned and How to Stay Calm.
Hey guys, can you understand me okay? Is that good? I'm really excited to present this to you today. I've had a lot of conversations over this past week with people about incident response. And there are a lot of different takes on this. Most people say, oh yeah, we just need better monitoring. We just need better monitoring. And then, you know, I go and talk to various different projects and I ask them, what kind of monitoring are you doing today? Crickets usually, right? And they're not exactly prepared for when they actually get wrecked, right? And we're gonna be talking about exactly what wrecked means today. Now, first and foremost, I probably should introduce myself. My name's Heidi. I'm on the Unit 0x team at Coinbase. Our big goal here is to make Web3 more safe. As Coinbase is getting more into the Web3 space, we want to make sure that we are creating sort of the most safest dApps, but also making the space a lot more safe. One thing that you might say is, well, wait a second, why does Coinbase care about Web3 security? Yeah, sure, you guys are launching Base, but why do you care about maybe the Euler hack? Well, first and foremost, any ecosystem threat is bad for us, right? It's bad PR for us. But there's also fallout from things like the Euler hack that you might not think about. For example, all the CB ETH being drained, right? There's also other fallout from these sort of events also happening. For example, a threat actor might want to cash out with us. So there are a bunch of different facets that we care about and we really are interested in making sure that dApps in the ecosystem do not get wrecked. Now, I've got a couple different things on the agenda today, but we're going to keep it really light. First, we want to define as what does it mean to get wrecked or to get pwned, right? After that, I just want to get us set up with basic 10 questions you as a project should be asking yourself in terms of being prepared for getting wrecked, right? I'm not saying you need a whole monitoring plan today. That's a little overambitious, I think, for a lot of projects today. So let's keep it easy. And then, last but not least, you might be asking yourself the question of, oh my God, my dApp just got wrecked. What do I do? How do I even set up a war room? How do I even think about incident response? So let's get started. What do we mean by getting pwned? Now, I want to make it very clear, and I loved the presentation right before mine from Immunify, because getting pwned or wrecked is not the same thing as an incident. An incident is kind of what, Immunify was talking about, where a white hat or maybe, someone on the dev team might actually find a bug. Yeah, sure, it might be a critical bug, but it doesn't lead to funds loss of users, right? And so let's define getting pwned. Now, getting pwned will depend on your dApp in and of itself and your dApp's risk tolerance. That might be defined by the jurisdiction that you're in. It might be defined by your lawyers. It might be defined by what your total TVL is, and also maybe your LPs. But generalized, pwned basically means the unexpected, sudden, and significant loss of user funds. Now, we're going to go into all of the specifics that I've underlined here, but that's the basics of it. And I think we can all agree on this definition because it also includes things like rugs, right? It includes things like hacks, too. It's very broad, and it's done for that reason, right? Because we need to all come to an agreement as what do we mean here? Now, how do we think about getting pwned? Now, this is all going to be, as I talked about before, is based on your project's risk tolerance. So what is an unexpected event for you? So that might be the USDC DPEG. I don't think anyone in this room saw that coming until, the banks, I don't know, on that Friday went under, but I don't think anyone in this room expected that. What's a sudden loss for you? How do you define that? What percentage of TVL would you actually classify that as, right? Or would you say a sudden loss could even be something like maybe losing funds from your treasury? That's something that you want to think about, right? So, for example, a sudden loss might be suddenly 1 million BNB being withdrawn from the BSC bridge. Now, initially, when this BNB bridge hack went down, I didn't think that 1 million withdrawal was that bad. I was like, oh, it's probably just some big trader. It was only until like, I want to say it was like less than 5 minutes later, there was another withdrawal for 1 million BNB. And I remember thinking, this probably isn't just a big trader whale. Now, the last thing you also want to think about is, what's a significant loss? Like, I didn't think that 1 million BNB was that significant of a loss at the time. But maybe, for example, in the case of Euler, that 34 million USDC that was withdrawn from the pool, that was the entire, that was the entire Euler, pool of USDC. They had no more money left. That is a significant loss. And so when you're, like, just as a project, start thinking about those three very high-level things. Now, many of you probably have been in incidents, have been in war rooms before, but I want to bring us back to the more basic cybersecurity stuff and how the industry kind of thinks about incident response. And then we're going to try to apply it to Web3 and all of the kind of pitfalls that we might see with this kind of flowchart. Now, first, in the traditional sense, there's some preparation that you do for incident response. That could be doing a whole bunch of documentation. That could be writing playbooks. That could be creating a contact list. That could be even starting to monitor, right? Next, you have detection. So that is all about your monitoring program, setting up alerts, etc. Followed by patching, obviously, the bug. So you find a bug, you want to triage it, you patch it. Followed by, obviously, the recovery. Okay, now you've patched the bug, you want to maybe bring whatever your DApp is back, you bring it back. And last but not least, you also have lessons, which you then are going to apply to your preparation. Okay, this sounds all great, right? But how is Web3 a little bit different from this? Well, first off, detection. We all know, right, from crypto Twitter, that a lot of the detection is done publicly. That's not generally a thing that happens in Web 2 or in traditional cybersecurity, where you're literally put on notice by the entire community that something is up. Another thing that's also different is when you're actually thinking about applying a patch. Let's say, for example, you're operating a bridge. Your bridge goes down, right? And you want to, okay, you found the bug, you want to bring it back. Well, when you bring that back, when you want to bring the bridge back, you want to create sort of recovery, right? What do you think is going to happen? Everyone is going to flee from your bridge. You will not have liquidity anymore, right? And so there's a very strange kind of balance that you kind of need to reach when thinking about how you're actually going to go about doing a recovery, right? The other thing, too, with recovery is it's not just bringing that bridge back online. It's also recovering whatever funds you might have lost, right? And funds recovery is a whole other subset, a whole other story. And finally, with lessons, it's not just that, the lessons are learned by the bridge, in this case, it's in and of itself, but it's also by the wider ecosystem. We constantly are taking away lessons from various different exploits as to how we can build better dApps in the future, and I'm sure you guys all are as well. And that's something very different from Web 2. Sometimes Web 2 companies will publish incidents that occur, but a lot of times they'll keep it as quiet as possible, right? Because they don't want the bad PR. But of course, because everything's public on chain, you kind of can't help it here, which is cool. Now, let's go through this exercise real quick with 2 examples. And I actually chose these examples because I thought they'd be a little different, but in reality, they're not. So, and before I get into that, one thing that I also want to mention is that today I'm only going to be covering mostly these 2 sections here that are highlighted in red. Detection, we've seen a ton of different companies do a way amazing job of talking about monitoring, and I think they do such a good job, there's no point in me like rehashing that all over again. So let's go into the Nomad Bridge example that happened last August. Now, we don't know what kind of preparation they did for this kind of event. We can assume very little, though, probably, but we don't know what kind of preparation they did. Now, one thing with Nomad that was kind of fun or problematic was they didn't really detect it. They didn't detect when suddenly massive withdrawals were happening in one specific block that happened, I want to say, around 9 p.m. That night. And unfortunately, crypto Twitter saw this. And I don't know if you guys remember in that one block, there was one threat actor who was a part of the group of attackers that was really hell-bent on participating in that initial block in the attack, and they made the attack public. Because initially it wasn't, and we couldn't unhash it, but this attacker was just very greedy and wanted to push through their transaction. And that, of course, started the free-for-all, where everyone could basically copy-paste the code, just update, right, the input data to include, obviously, their destination address, and boom, they could withdraw a ton of WETH, wrap BTC, and all sorts of currencies. Now, one thing that I have here is that it took the team 3 hours to respond, right? In reality, and I updated this slide actually while sitting over there, that's not actually the case, because I was going through the Nomad tweets. The team didn't really respond. What in reality happened is, if you look at the bridge contract, is the bridge contract just got drained within 3 hours, right? Of course, the attackers initially went for the highest denominations, right? But once they had gone for the highest value coins like WETH or wrap Bitcoin, they then kind of waited around, and then they went for like lower value currencies like cards, for example. So they didn't really patch the problem. And then it took them like almost an entire day later, right? Because remember, other people are copy-pasting this hack. And I remember that there were several people in various group chats I was in, they were like, hey, shouldn't we be withdrawing funds from this bridge as well? Because we can just hand back this money if they publish a recovery address, right? It takes Nomad an entire day to publish a recovery address. And even so, it's been almost a year now since the incident. They've only recovered about 17% of all the stolen funds. That's a very, very small amount. And of course, Nomad has never come back. In fact, they've hardly made a statement since then. I don't know if anyone from the Nomad team is here, but I'd love to talk with you to learn whether or not if you ever are considering coming back. But to me, you guys are just ghosts at this point. Now, okay, let's talk about something more recent, right? I thought, okay, we'll go for an older case. Now let's go for a newer one, multi-chain. That literally happened like, what, a week and a half ago? Okay, so first and foremost, preparation. Let's think about preparation. They've been hacked 3 times, so let's hope they prepared, right? This is hack number 4, by the way, guys. So let's hope they did some preparation. Not sure, though. They've never published any of it. Now, of course, again, how was this hack? Right? We don't actually know if this was a hack. We think it might be a CCP. It's still kind of unclear based on Twitter, based on what they've written on Twitter up until now. But again, the attack was detected by the public. Who identified this? Oh, it was PeckShield. PeckShield at 12:06 p.m. UTC detected this on the 6th. This is kind of important because it took them literally almost 12 hours later to then respond, right, on Twitter to say that funds have been moved to an unknown address. That's pretty bad. That is really, really bad, right? So it was detected by the public, and then it took almost, I want to say it was like maybe a couple hours later, funds were frozen then. So we kind of tried to recover those funds. And why do I mean we? It's because some of the funds were frozen on USDC. So that was the one thing that, that can be done in some of these instances where protocols get wrecked or dApps get wrecked, is that certain assets are freezable. So USDC, which is a conglomeration of Center and Coinbase, or rather Circle and Coinbase, we're able to freeze those funds. And that's something we were able to do in this case. But it took them then, it looks like an extra 3 minutes to then finally then make a post saying, hey, don't use our bridge at all, right? And by the way, if you try to use our bridge, transactions won't go through. That's pretty rough, right? It's not a good look, right? And since then, as we know, they've then published saying, hey, we're still not sure of where the funds went to, but we think it's the CCP who took them because our CEO is still gone, but it's unclear. Again, this is pretty bad response. Right? And this is even, I would say that in this case, a lot of us knew what was going on. We thought that it was rapidly kind of happening, rapid response was going on, but in reality it wasn't. In reality it was pretty disorganized, I would say. So once you start thinking about things in terms of this kind of flowchart, things start to seem a little bit less organized, I would say. Now, okay, now we know what a basic incident flowchart looks like. Let's talk about some questions to ask before getting pwned. And this is where I would say, once I finish talking about the slide, just take a picture of it because it'll be useful. But some questions to ask, right? First off, with monitoring. Do you have basic monitoring? Basic monitoring does not mean crypto Twitter. It does not mean creating a tweet deck of your favorite monitoring tools, your favorite auditors. They're great and all, don't get me wrong. PeckShield, Slowmiss, we all know who they are, who then publish like these insane tweets like, hey, you might want to check this transaction out, tweets, that is not monitoring. Sure, that's a good interim solution. That is not monitoring. You want to have those alerts set up. You want to actually be looking at those. Next, legal/comms. This is something that I've noticed a lot of teams don't think about unless they get a little bit bigger and they actually have lawyers. But many teams, when they first start, they're literally a bunch of devs. So the question that I would ask them is, do you have a lawyer, right? Because when an incident like this goes down, there's a lot of legal liability, and we're going to talk about that in just a minute. But the next thing that you might want to ask yourself is, do you have pre-written comms in case of an incident like this happening? So let's say you don't have a lawyer, right? Or let's say you have a lawyer and you're kind of on a retainer with them. Have them just approve a pre-written thing just in case you ever get wrecked. Remember, in crypto, communication is key. We know with Nomad, we also know with multi-chain, that the reason that their response was so abysmal is that they weren't public about what was going on, but instead kind of let the chain speak for itself, which is not the right move ever, right? The next thing is do you have an insurance plan? Do you have any insurance plan whatsoever, and have you notified any of your users or LPs of that, right? It's not to say that you necessarily need an insurance plan, but it's something that you might want to think about. Now, the last question is a little controversial, is do you have connections to law enforcement? Now, some of you guys might be like, no, we don't want to deal with law enforcement at all. Nope, we're out of here. We're about a free financial system here. But the thing is law enforcement might come in contact to you. And you kind of don't want that. You kind of want to already have someone on your side from the get-go. It's just something worth thinking about. Next is incident planning. Do you have an incident lead? So when you have a war room, and it was really cool actually, the previous presentation here, they were talking about having a war room. Now, what I'm talking about here with incident response is going from war room all the way forward to trying to recover and actually learn from an incident, which encompasses a lot more, right? But when you're in a war room, what you need to have is an incident lead. That person needs to be ascribed to that. And I've seen various different war rooms where it's a hot potato and no one wants to take it on. Just sign someone up immediately and just say, hey, you're down for this, you gotta take all of the notes. Next, what you need to have is you need to actually have a tech lead. And what is a tech lead? A tech lead is someone who communicates with all the devs to figure out where is the bug, right? That's followed by a comm/legal person. Having someone in those war rooms is critical. They can help very quickly, help write the tweets, help send out communications, help communicate also with law enforcement, et cetera, whoever reaches out. And another question is, for incident planning is, in order for those devs to figure out where the hell the bug is, how well have you documented your infrastructure? And a lot of you guys might be sitting there, especially if you're in a smaller project, is like, we don't even have time to document it out. Like, that's a luxury that larger projects have. We just do not have that. Just start thinking about keeping it simple and doing some sort of form of documentation. And another question is do you even have a list of contacts that you can reach out to in case anything goes down? Right? And what do I mean by contacts? I mean law enforcement. I mean people like incident responders, even here in this room, who have been through various different incidents, et cetera. And last but not least, obviously, economic analysis, right? What projects have invested in you, and what are the wider ecosystem threats that might actually happen if you try to turn off your tool, or your dApp, or if you try to turn it back on? And one thing that I didn't get to, but I really want to, even though I have 1 more minute left, is the main point here, which is, what if my dApp actually gets pwned? And I just want you guys to first not panic, and then take pictures of these slides, because I'm going to go through them really quickly. But this is the step-by-step plan. You want to prepare. You want to set up monitoring and all this other stuff that I talked about. Then obviously you want to triage, and you want to create that team that I talked about. But here is the real step-by-step flowchart. So first off, let's say you get an alert from crypto Twitter. I don't want you to, but you probably will, right? Monitoring. And then let's say you triage it and you know that, uh-oh, we lost money. What do? Okay, so let's say you don't actually think you lost that much money. It's not that big of a deal. Not an incident. Close it. Forget about it. This is the one part of the slide that I really want you guys to take a picture of, is when you call an incident, what do? So there are 3 big areas that you want to be scoping out and you want to be asking yourself. Legal comms questions that are critical, engineering questions, but then also investigations questions. Because if you get wrecked, you are going to want to try to recoup that money. You really are. And now that you guys have taken pictures of this, I want to show you guys two different kind of offshoots of that. Let's say you find a patch, right? You need to then start asking yourself what your liability is for implementing that patch, and do we have any insurance, and what are the wider ecosystems of us, ecosystem threats of us turning this thing back on? And, you know, last but not least, investigations-wise, we're still out all this money. Are we going to pay these people back? Are we actually going to track down this money? And then, because a lot of people like this, is they believe that when attackers try to negotiate, that maybe they're going to get money back. I would say 99% of the time, do not even bother. But in case you try to bother, I wanted to do this slide for you. Here are the questions you should be asking yourself if you want to negotiate. The main point is here, don't get distracted by negotiation. It's not worth it. And let's do some takeaways here real quick. Just prepare, prepare, prepare. That's like the main point here. And obviously conduct exercises. And if you guys want to talk to us more about some exercises we've conducted, let us know. But thank you so much.
Thank you, Heidi. We have a bit of time before lunch, or lunch is starting now, but if you guys have any questions. Yep. Okay, I'm going to start. You can go next.
I wanted to ask, isn't it a bit unfair to assume that the public response on Twitter is correlated with the time that the team actually began to assess and respond to the incident? Because assume like if you're a project and you get an incident and the first thing is not go to Twitter, it's like actually try and solve the issue, right?
You used to work for Nomad, no?
That is a great question, and you know what? We should give the project team some credit. Here's the problem though. The blockchain is public. All of this stuff is public. If you don't make a statement, people are going to make assumptions about you. So you may as well just make a statement, and it should just be a coverall statement like, hey, we've noticed something weird, we'll get back to you. Something along the lines of that, but something that will protect you maybe a little bit more legally. But at least that's the bare minimum. Because if you don't say anything, the assumption is you're not doing anything. Is that unfair? Yes. But have we all seen that time and time again? Absolutely.
Yeah, great talk, by the way. Do you have like an example of good incident response?
It was kind of difficult. So I was thinking initially when I was looking through the flowchart of good incident response, and a lot of times the best incident responses have been from companies like Blocksec that actually presented earlier, where they tried to literally front run an attacker, right? But I didn't want to include that in this presentation, even though that's something that's very unique about this industry, is that you can front run an attacker, right? And that the public is already aware and that there are companies out there doing that. But it felt a little strange to include that in there because it should be actually the project team doing that, right? So yeah.
Any other questions? Yep.
Are there monitoring tools that you recommend to help front run the attacker?
I'm going to stay unbiased here.
Fair enough. Any other questions? We've got time. Don't be shy. Well, Heidi's going to be around for a bit longer, so feel free to grab her and ask questions. Thank you so much. Epic talk. Thanks.
Thank you all for joining the morning session. Thanks to Mehdi and all the speakers this morning. So we now break for lunch, and we're going to regroup here at 1. So there's a fantastic set of talks and panels on formal verification, auditing, bridges, and many more. So we'll see you soon. And for those of you joining today, the lunch is downstairs.
Do we have a, do you
have
the clicker?
The clicker?
Oh. Yeah, we have.
Did you plug in the...
I mean, I can do it without.
Not, this is, you have to plug this in.
Just in. Fine. Okay. Let's see if it works.
Nathan, I am
It's going to work
socials,
pretty
okay?
seamlessly, I think. Yeah,
all right.
It works.
Never say that about technology.
Okay.
Thank you.
Okay, good. Welcome to the formal verification session. I'm Yanis Maragdakis of DDoB. I will chair the session. So our first speaker is Netanel from Certora, and he's going to tell us about everything nice you can do with formal verification to avoid getting wrecked.
Wow. Well, thank you very much for the presentation. So actually, the title of my talk is much more modest. It's just improving the security of DeFi Met libraries, easy specs for preventing. Easy specs for preventing complex bugs. So let me explain the plan for the talk. I'm going to be talking about 4 things. The first is kind of an intro to DeFi and exploiting the trade function. The second is a PRB-MAT library bug, which we announced a few days ago. The third topic would be how did we find it, and the fourth would be when formal verification is easy. So okay, let's begin. So I assume that a lot of people have seen this kind of slides before, but I'm just going to talk about them a little to touch base. Okay, so what is an automated market maker? So I should first say, what is liquidity? Well, assets have, as well as a worth, they have their tradability, which is the reason that you probably Do you prefer this? Oh, thank you. So you can't really buy lunch in the cafeteria with an antique 17th century piano, and if you want to do that, that probably means you're in a bad situation. So assets needs to be basically what market makers do in classical finance. There are people who are willing to trade one asset for another. They're providing this ability to convert 2 types of assets to each other. In DeFi, this is done by an automated market maker. Often, and we have liquidity providers, which can be anyone. They give, in the most basic model of this, they give a pair of tokens, token A and token B, and they get back an LP token, which you can think about as a receipt to a certain percentage of the amount of tokens in the pool. And we have traders. Traders give in some amounts of token A, and they get back some amount of token B, right? Any questions so far? This is familiar? Great. Okay, so of course, the main question you should ask is how does the AMM know how many B tokens an A token is worth, right? And the answer is we don't need any kind of oracle or anything else because in essence, a market itself is a price discovery mechanism. And for a mathematical perspective, virtually every kind of automated market maker that's currently in existence, I think, on the chain is an example of a constant function market maker, which means its trade behavior is dictated by a function that has these 4 variables, and it maps into real numbers. And these numbers are X is the reserves of A tokens, Y is the reserves of B token, delta X is how much the trader wishes to give, and delta Y how much he wishes to receive. And the key point is here is trade is executed if and only if the AMM believes it's profiting, which means it should be that this psi of xy, delta x, delta y is bigger than psi xy 0, 0, which means if trade was not carried out. So, any questions here? Maybe I should give an example, which is this is much more familiar, right? This is the classical case, right? Everybody's happy. You have psi xy, delta x, delta y, equal x plus delta x times y minus delta y. What does it mean? It basically means we want to preserve the product of the reserves to be an equal number, right? It's x times y equals k. That's everybody's favorite. The idea was Martin Kupelman and Vitalik Buterin, and it was first implemented by Uniswap in 2018, and a lot of people since then. So this is an example of a trade function. There's nothing magical about this x, y equals k formula, and there are many other kinds of trade functions. Some of them are quite involved mathematically. And different trading functions optimize the underlying properties of different token pairs. Okay? So, what happens if there is some kind of a bug in the computation of the trade function? So an arithmetic flow in the trade function would allow an attacker to basically force the MM to systematically accept unfavorable trade. Maybe just a little, but consistently. The key point here is money has to come from somewhere. So this is kind of somewhat of a subtle attack because the number of LP tokens each liquidity provider is holding remains the same in the end of the attack. What basically the attacker is doing here is kind of draining them of their worth. A rough analogy to this is inflation, okay? It's a rough analogy. The liquidity provider still has the same amount of currency in their account, but it just can buy a lot less with it. Okay, so the key point here is that computational errors in the trade function would enable an attacker to drain the funds the liquidity providers deposited into the pool. I should probably say this is not really restricted, these type of attacks, to AMMs. I took this example because I felt it would be very familiar to everybody. It's also true for, for lending and borrowing markets, right? We know from ERC 4626, they're telling you that, oh yeah, you should definitely make sure that the rounding direction is in specific opposing directions to make sure you're never violating this like trade it's called the trade function, the MM invariant, or the CFMM invariant in different places in the literature. So how much damage can a simple rounding error cause? That's like famous last words. There's been a bunch of like attacks. There was the Alpha More hack. There was the SPL token lending bug, which was stopped by the developers in Solana program library. There was the YLD HDL distribution bug, and I think two recent ones, 100 Finance and the second Midas Capital exploit. Okay, so any questions so far? Okay. So I should speak about that bug. It was first discovered as a critical vulnerability in a non-live code of a leading DeFi protocol. And upon further inspection, we realized that the root cause was actually a public library function. They've signed. It lay dormant for almost 2 years. It's present in every version from 1.05 to 4.0. And it's temporarily fixed in 4.01, where there's a warning, if you can see in the net spec, that says that this is wrong. We'll get to it in a moment. And the long-term solution is going to be part of a roadmap to support multiple rounding modes in PRB-MAT. So since I'm mentioning PRB-MAT, I should probably just say a few words about it. In case you guys are familiar with it, it's a Solidity MAT library for advanced fixed-point computation. It was written by Paul Rasvenberg, and it's based on work of Remeko Bluman on the algorithmic side. It's popular. It's fairly complicated. It's very, very gas efficient. It makes heavy use of YOOL. It has a lot of like byte hacking tricks. It has a lot of math magic and a bunch of number theory in it. It's well written, documented. It's actively maintained. It has a lot of commits, a lot of unit tests. It's really very good. And I think this is, to the best of my knowledge, the first library bug that was found by a semi-automatic tool. Maybe I'm wrong, I don't know. So okay, now let me explain the bug, okay? So I'm slightly simplifying the algorithm here for the purpose of presentation. So the goal of this function is to compute the floor of x, y divided by d with full precision, without losing any precision. So you separate the signs at the absolute values. That's the first. And then you compute the absolute value by you basically reduce to the unsigned case by calling moldiv, which is a function that computes the floor of x, y divided by d on the absolute values. And then you compute the overall sign by taking XOR on these signs. So to give an example, you take xy equals minus 20, minus 30, and 7. So you get 20, 30, and 7, 1, 1, 0. And the absolute result is floor of 85.714. It's 85. You compute the overall sign, and you get the right result. The problem is the second step is logically wrong. when the absolute value is smaller than 0, rounding, taking a minus of floor is seal. As an example, if you take minus 180, 114, you will see that like the absolute value is 12, and what you get is minus 12, but if you compute the right number, it would be minus 13. So for example, you know, it's possible you should have gotten 0, and you would return minus 1. OK, that's the bug. And it's in. How did we find it? OK. So formal verification process. What is formal verification? Well, very roughly speaking, you have a bunch of invariants, and you bunch a bunch of code, and you put it into a big machine called a Sator prover, and it throws out either a proof that every behavior is correct to the spec, a timeout, or the behavior violates the invariant. This is not a fuzzer. Basically, you convert the entire code into a bunch of logic equations, and you try to prove that the behavior is correct. Like try to prove basically a theorem. I should probably say any questions so far? OK. So the other point that I want to make here is that basically spec writing in general is hard work, OK? And therefore, it's kind of expensive. This is like security researchers, you know, they have to do their work perched on a pile of gold. It's just a fact. They do their best work this way. But this is not always true. Encoding integer equations is really easy. And for arithmetic libraries, basically, this formal specifications just write themselves. Okay, here's the example of this is the entire like spec that detected this bug. It's basically automatic. The only thing that you're seeing here is basically I call muldiv signed compute in code. I compute the code result. I compute the result in logic. And I ask, are they the same? The only thing that I need to write is this thing. Now, this looks like solidity, feels like solidity. It's not solidity. We worked really hard to make it look like solidity. This is SMT, basically. OK? What you're seeing here to matint are unbounded integers. They're not uint 256. They represent the logical numbers in Z. Okay? They represent arithmetic integers. OK, and the other thing is like, well, when you run on this type of like arithmetic libraries, you also get really nice counterexamples. Like the counterexample I gave basically just came directly from like the prover. Just spit out this counterexample. So you get X, Y, and D, and you can just put this thing into Remix, for example, and just check where things go wrong. So yeah, this is actually all the spec you need to detect this problem. You don't need anything else. And you don't need even access, really, to the prover. You can there's a pay-as-you-go option. You can just, like, you know, just run this script, just pay for the minutes, and just find it. It's a bit surprising, like, that this is found by such, like, an easy spec. We were surprised. Math libraries are the foundation, basically, of DeFi, but they're not easy to get right. I think that's maybe the takeaway. These are things that auditors usually don't like looking at. I didn't include here the code of how the entire computation looks like, but it looks, there is a lot of like low-level stuff. There is a whole bunch of like number theory. It's easy to get lost and to miss that the point is like the entire logic is actually incorrect. So writing specification helps ensure that nothing slips between the cracks. So this is a very, very, very well-written library. It has unit tests, it has everything, but because if you make, often you do like frequent commits, but sometimes you refactor a function and you forget to put some kind of a unit test to that specific function, that is the function that you find a bug in. So I think even just the process of like, you know, touching base and checking in the end, writing a formal specification of what everything in the program is supposed to do sometimes can find bugs, even without any automatic tool. And the other interesting part is, I think, the specification really easy to write. I should say that this bug is very common. It could have probably been found by a fuzzer, like easily. But in general, we also found some other bugs there that are, I think, less interesting that you can't really express, I think, using a fuzzer. The point is like, it's almost automatic in these kind of mathematical functions to write what the spec should be and to express it. And you can't really write it in Solidity, because if you could write it in Solidity, you would not need a mat library to extend Solidity's functions to make it, right? Again, I think the conclusion is, in retrospect, kind of obvious. So if you have mathematics or economy, like this kind of like core parts, or just do computations, and you form a verification, that's like a really good match. You have some function, you don't know what it does, you just throw it into the prover, and it either tells you if it works or it doesn't. It makes sense, I think, a lot of sense in this case to utilize semi-automatic tools for increasing security. Okay, thank you. Questions?
Thanks. Silly question. How did you come to the idea that rounding down for negatives means pushing further away from zero, not closer to zero? I think that's kind of, in the first place, that defines the difference between the two approaches, that you at some point decide that you have to make the number more into negative rather than closer to zero.
So, thank you for the question. So the mathematical definition of floor has like a floor and ceil have a well-defined mathematical function. They're basically very rounding towards minus infinity. I mean, the definition that appeared in the NAT spec was you need to round down. Okay, what basically was changed in version 4.01 is the observation that like it actually does not round down because the MOLDIV is based on the algorithm that Remco Blumen wrote, which takes floor, but basically rounds towards zero because it is in unsigned numbers. And when you modify it and you want to keep it efficient, then you make it like in signed numbers. But then basically what you notice, it no longer gives you like floor. It gives you basically rounding towards zero, which is not always what you want. For example, if you're raising it to some kind of a monotone function in a trading function, etc., then it gives you the wrong result. You're going to lose money from it. I mean, I don't know if it answered your question. I mean, the definition of floor is like rounding towards minus infinity. Definition of ceil is rounding towards plus infinity. I mean, that's the mathematical definition. Maybe I did not understand your question. This is floor, yes. That's the, yes. So yes, that was the definition. That's how I...
Should I go? Okay. Would you say there's any trade-offs between writing the specification in the CVL language versus maybe like a lower level proof assistant? If there's anything that that you're trading off or missing from what you could get by specifying like the whole thing in a proof assistant?
I mean, I don't have a lot of experience with proof assistants. I think the main advantage is like, if I remember correctly, like proof assistants like K, etc., are much harder to like to work with, and I think like you need a lot more effort to like do the verification. So it might at this point like be actually easier to just go and do it manually. I think the advantage of like CVL is that it looks like Solidity, and basically the specs of mathematical function are just literally okay. Take what's in the NAT spec, throw it in, and check. Like you don't need a special verification engineer. You don't even need to put considerable amount of effort. I mean, you just need to do it. It's like easy.
Hi, nice talk. I was just curious, you've been using the Certora prover to handle these math libraries, but a lot of these libraries have a lot of nonlinear computation. I was just wondering, which is like notoriously bad for SMT. I was wondering if you could just talk a little bit about like, what you're doing to address the nonlinearity. Maybe you could talk on how Certora prover does on those kind of
yeah, so that's an excellent question. I'm very happy somebody asked that. Thank you. So it depends. So for algebraic functions like roots, etc., we have Jochen's work, which helps us like actually we are able. You need to do some manual work, but you can like summarize, for example, square root, and you can prove separately. You prove that the square root is actually equals. You think about Newton-Raphson iterations and loops and that type of stuff, right? And like Hensel's lifting lemma. So yeah, you can actually rely on, for square root, for example, you can now Jochen's work, which proved it. It did like amazing work. For really, really like transcendental function like exponent and lan, it's more complicated. I think in this case, you really need to like either black box some of the things, and either do like a very, very careful step-by-step verification, even manual, or like use a father or something else. You need these things you need to black box out. But if you're talking about algebraic functions, there's like something to do.
We're basically out of time. If it's a quick question, we can take it.
Thanks. So the Satora prover is obviously a really powerful tool. Is it open source? And if not, are there any plans to open source it?
So I think, can I direct this to Muli? No? I don't know how to answer that question of like long-term plans. I think this is a question for my higher-ups.
Okay, let's thank Nathaniel again and take this question offline. And our next speaker is Paulina Tolmak from RV, and she's going to tell us about using symbolic execution and scaling it to DeFi. You can use this microphone, but you cannot walk too far because the video needs to capture you. So you need to be...
Well, I didn't plan to, but thanks. Well, I guess I can start. Bonjour. Thank you all for coming. I'm Paulina. I'm a verification engineer at Runtime Verification. Before that, I was a PhD student, and I also worked with MakerDAO on improving the adoption of symbolic execution tools for smart contract and DeFi security, and that's what the talk is going to be about. So let's start with why do we need something like symbolic execution? And the short answer to that is because we want to eliminate bugs from our code base. And symbolic execution can help us with that because it's one of the formal verification techniques. And there is, of course, more to formal verification than just bug finding, but let's focus on this application in this talk. Let's see how it works. Here I have a small smart contract example we'll use in this talk. So here we have a function. It's called backdoor. It takes an input parameter x. And in this function, we declare a variable y that is set to 0 by default. And then we also have an if statement. What it means from the point of program analysis is that there are two possible ways in which this function execution can take. So there are two execution paths. One, if condition is true. The condition says that x plus 1 is equal to 1024. X here is the input parameter, which means that if x is 1023, then we'll be taking this execution path. In this execution path, we set y to 42, and then at the end, we have an assert checking if y is not equal to 42. What it means is going to fail. This condition is going to be violated, since asserts are commonly used in smart contracts to express conditions that should never evaluate to false. It means that there is a bug in this contract, and that's what we'll be trying to detect using the techniques we consider in this talk. Alternatively, if we take the else branch, nothing happens, y remains 0. 0 is not equal to 42, so the assert is not going to fail in this execution path. So what techniques do we have that can help us identify this issue here? Well, one of the techniques, the most simple one probably, is unit testing. So in a unit test, usually we assume that x has some concrete value. For example, we can assume that x is 5. If x is 5, the if statement, this condition does not evaluate to true. We're taking the else branch, y is 0, not 42. The assert doesn't fail, which means that we haven't identified the bug, even though we know it's there. And that illustrates the insufficiency of relying on unit tests solely for security and correctness assurance in smart contracts, because it provides us with limited information about the smart contract behaviors. That being said, of course, it's a very useful technique, and I'm pretty sure that every project should use them. Besides that, unit testing are usually used to analyze happy path, and there might be a bit challenging to use in order to identify some unknown issues. So in order to increase coverage, we can do fuzzing as well. That means that instead of just running our code on a single concrete input, we'll be running it on a sequence of randomly generated concrete inputs. Fuzzing is It's very efficient. I highly recommend using that as well. The problem with it is that all these random inputs can still drive the execution towards the same execution path, which means that we'll be exploring it over and over again, and we won't be able to identify the bug, because it can be challenging for the fuzzer to randomly generate the value that will satisfy this very specific condition that we have here. And that is, in fact, what happens. I ran Foundry's fuzzer on this example 65,000 times, I think, and it doesn't identify this fail assert, but you can also try it yourself. But I also said that symbolic execution can help us identify this issue, and here is how. So the basic main idea behind symbolic execution is that we don't restrict the value of x to some specific concrete input, but instead we assume that it can take any possible value, and that's what we call symbolic variable. Then we'll go down every possible execution path, and we'll further narrow down the set of values that x and other variables can take based on the conditions that we encounter in this execution path. So the conditions come from things like if statements, loops, assert, require statements, any conditional statement. Here, since x can take any values, it might as well be 1023, so we'll finally get to execute this true branch of the if statement on the left, where the assert fails. The formula on the slide represents the state where the assert is failing. So we'll finally detect it because that evaluates to true, indicating that the assert can fail here. The input to a symbolic execution tool usually looks something like this. Normally, it's the source code or the bytecode that we are going to symbolically execute. The output, we want it to look something like this. So we want it to tell us, the tool, to tell us that the backdoor function should be called with this particular concrete input for the assert to be violated. Symbolic execution is commonly seen as a way to generalize testing, because it allows us to reason about sets of inputs that would be impractical to reason about using, for example, a test suite. We wouldn't be able to cover as much. Besides that, symbolic execution can also be viewed as this translation from the source code or bytecode to this more formal logical representation, such as this formula we can see on the slide. And we can reason about this formula. But the question now is, how do we get from all these logical formulas to the output that tells us with what specific values we should run this code for the assert to be violated? And that is what symbolic execution tools use SMT solvers for. That's a very sophisticated piece of software. SMT stands for Satisfiability Modulo Theories. There are several of them. Some of them are on the slide. But essentially what they do, they take a formula, this logical formula, representing, for example, the state where the assert is failing, in our example. It runs some analysis on it, and based on the analysis, it tells us either that this formula is satisfiable, which means that it can evaluate to true if our symbolic variable takes some particular value, such as the one we expect. If the formula contains some contradictory clauses, which means that it can never evaluate to true, it's going to tell us that it's unsat or unsatisfiable. The third type of of output is, I don't know. So if it ran out of resources, it cannot really answer our question. Here on the slide, I have an example of the manual encoding that I have performed of this Solidity code that we had on the previous slide. That's the translation to the Python API of this free SMT solver. So if we encode this example and ask if the assert can fail, it almost instantly tells us that it is possible if x takes this value that we expected it to show us. Altogether, with typing, this took me 33 seconds, but if you type faster than me, you can do even better. So obviously, it's a very simple example, but I personally think that it illustrates that symbolic execution is a very powerful tool and technique. And personally, I think that a year from now, it's going to have a very big presence in the smart contract development processes. So maybe now is a good time to start adding it to a tool belt. In general, there are many symbolic execution tools for smart contracts, and as part of our effort to improve and increase the adoption of this technique, we have selected and examined some open source tools, the best open source tools, for symbolically analyzing EVM bytecode. So these 4 tools here made it to the top of our list for usability, versatility, and being stable in general. So the tools are Misreal by Consensus, Manticore by Trail of Bits, HEVM, originally part of the DevTools framework, currently developed by Ethereum Foundation, and ETHBMC, which is the only academic tool that made it to our list that's developed by a group at Ruhr-Universität Bochum. So let's get back to our sample contract. And as powerful as all these tools are, only 2 of them detect this fail assert out of the box. Misreal and HEVM. So all these tools are rapidly changing and evolving, but at the moment, to use them efficiently and effectively, you might have to tweak their behaviors quite a bit or slightly change the way the analysis is performed. So here I'm also going to show some landmark tips on how to use the symbolic execution tools in practice. For example, Manticore out of the box doesn't report this assert failure, even though it's there. However, if we look into what happens, it turns out that Manticore only detects and reports failed asserts in Solidity versions prior to 0.8, when the EVM representation of a failed assert had changed. So even if we say something trivial, like assert false, it will not be able to report that either. However, if we downgrade Solidity version to 0.7, it's going to detect this failed assert in less than 2 seconds. And we also similarly added the detection of failed asserts to ETHBMC ourselves. So that brings us to the advice number 1. If the tool doesn't report any issues, make sure that it actually reports something. Add something trivial like assert false and see if it fails, because there are a lot of reasons for the tool not to report anything other than beyond just the code being perfect and correct. One other aspect that we are considering is the support of several SMT solvers. It matters because the performance of different SMT solvers may vary. And for example, here, the timing, all the timings are based on the same SMT solver, D3. But if we use a different one in ETHBMC, we'll get an almost 20 times better timing. Here's another example of a tool reporting that everything is fine over a more complex contract. So that is a simplified contract from the MakerDAO codebase that contains a real bug that, of course, has been fixed. It has a function that's called counterexample that deterministically fails an assertion expressing an important invariant after the execution of 4 function calls. So the contract is called minivat. However, if we run Misrule on it, it will finish the analysis in 4 minutes, but it would not report any issues. However, if we anticipate that there might be some SMT solver-related issues, which we should, and that's advice number 2, we might think that maybe the SMT solver is quietly failing due to the timeout in the background, and in fact, that's what happens. And if you observe some inconsistent behaviors in the symbolic execution tool, if it performs inconsistently between different runs, there is a chance that there is also some SMT solver timeout happening. If we increase the solver timeout, Misrule will run way past this 4 minutes. Does it help? No, it doesn't. That happens because there are actually a lot of aspects that affect the performance of the symbolic execution tool. And in general, symbolic execution traverses all possible states of a smart contract. So the number of states grows exponentially with the contract size. So one of the biggest impact on performance comes from limiting the scope of the analysis. And also, you can, otherwise, you can optimize the interactions with the SMT solver, for example, by querying it less frequently. So all this might be achieved by the options that are present in the symbolic execution tools that you're using. For example, in the end, we managed to make Misrule find this issue in less than 2 minutes. That's the advice number 3. Know your options, know the options present in the symbolic execution tool you're running, and use them to limit the scope and optimize the performance otherwise. For example, you can focus on the detection of only some specific vulnerabilities, not reasoning about gas, and so on. Overall, Misrule and Manticore, 2 Python-based tools, are flexible and easier to use in general. The timings on the chart represent the best, most optimized run of these tools to detect the issue that I have seen shown in the contract on the previous slide. HEVM and ETHBMC, they're written in Haskell and Rust respectively, are on average faster than the other 2. So it might seem that the usability versus performance is a trade-off in the existing symbolic execution tools. But a lot of efforts are currently being put by the respective teams to improve the situation. And one example of that is symbolic testing. So that's one of the emerging trends, which allows developers to apply symbolic execution to existing tests that already exist in the project. That makes it easier to introduce symbolic execution to the development processes. It also limits the scope of the analysis, because the analysis will be restricted only to these things that are being executed within the test. And in general, I think it dramatically improves the usability of such tooling. So symbolic testing is supported by our old friend, HEVM. We added the support of symbolic testing to ETHBMC by integrating it with Foundry ourselves, but that's probably a different story. There is Helmut by A16Z that appeared quite recently, and also there is KVM by runtime verification. On the slide, we also have the same minivat smart contract, but now we have the test instead of the counterexample function, but it encodes essentially the same thing. And we'll use it for benchmarking these tools as well. Right, so since symbolic testing is quite easy to use, we'll be evaluating this tooling based on their completeness, which we define as the support of complete EVM semantics and cheat codes that Foundry uses to tweak the analysis. KVM is by far the most complete one because it supports the complete EVM semantics, and in fact, it also passes all tests from the Ethereum Conformance test suite for Ethereum clients. It also provides extensive cheat code support, and a lot of work is currently being put to make the performance better. For example, when I ran KVM on the same example back in April, it took 32 minutes to finish the analysis and identify the issue on a powerful server, and now it finishes less than in 3 minutes on my laptop. Halmash and EVMC also take a few minutes to finish the analysis, but they are a bit less complete. And HEVM takes just 1.5 seconds. It's blazing fast. I don't have any other comments here. The concluding advice here is that I recommend you finding your tool and learning how to use it efficiently. So with the security guarantees that are inherent to symbolic execution that might give you an edge in safe smart contract development, auditing, bug bounties probably, and all these tools get better and better and easier to use day by day because the teams are developing them very actively. This talk is loosely based on the 2 blog posts that describe the evaluation of symbolic execution tooling that we have performed, and one of them is available on this link on the slide. And in addition, we have also prepared some Docker containers with these tools fully set up so that you can try to run them seamlessly. And that actually completes my presentation. Thank you so much, and I'd be happy to answer any questions.
So in your slide, looking at the usability and the performance, how much impact does the usability have on your performance as the person who's actually setting the thing up to run it?
Thank you so much. Yeah, I actually wanted to say something about it. So I have to say that Mistral and Manticore, we rank them as more usable. So one of the reasons why we do that is because they provide a lot of options. So they're quite flexible. You can turn off unnecessary detectors. You can basically do a lot of things to optimize their performance. And that's why, actually, Manticore and Mistral, in the most optimized runs, don't perform much worse than EVMC or HEVM that are faster on average, but are less flexible. So them being usable and providing more options to adjust the analysis, well, first make them more performant, it's easier to extend them. So we have added similar functionality to Manticore and ETHBMC, and it took considerably more effort to do this in ETHBMC. Well, it might have something to do with my personal skills, because one is written in Python, the other is in Rust. But it's easier to extend, it's easier to add some additional vulnerability detectors, and so on. So I'd say that it has a great impact, but still, well, so there is a limit to how fast Mistral and Manticore can be. And for example, neither of them can complete the analysis in 1.5 seconds as HEVM because they take, I think, 2 or 3 seconds just to start. But in general, well, I would say it's extremely important. Well, I hope I answered your questions.
Sort of. So what I'm trying to get at is, if I go and pay someone to do this work, you doing the setup and the thinking and setting the options, that's expensive time. Right, and that's real time. The difference between 2 seconds and 12 seconds and 112 seconds for a report doesn't make any difference. It's like by the time you send that to me in an email, that difference is completely irrelevant, right? And unless there's a really, really big difference.
Right. Well, to be fair, that's a simple example, and that's why the difference is insignificant. And in theory, more performant tools, and for example, tools that support several SMT solvers, other than one that might struggle with some particular thing we have in the smart contract, and we have a lot of those, might be able to do something in the end. So there are a lot of, at the moment, there are some scalability issues that are being addressed, but the question is essentially whether you can get some results with the tool you're using, and it's easier to get these results from the tool that is easier to tweak. But in general, at the same time, if they're like inherently not performant, if they're bound to use one SMT solver that does not perform well on, for example, what do we have there? Like nonlinear arithmetics, for example, or large bit factors, and we have a lot of those in smart contracts, then you won't really be able to get any results, even though it might work better on some simpler examples. So I guess the bottom line is that it takes some work to find the tool that works best for you. And yeah, that's pretty much it. The question is whether you'll be able to get some results you're expecting, especially if you're talking about a relatively large code base, which might be challenging.
Thanks. Thanks for the talk. So you showed a small example where the fuzzer couldn't find the bug, but the symbolic execution engine could. And what I was thinking there is that a lot of coverage-based fuzzers may be able to easily find that bug because they're going to be coverage directed, right? So could you just elaborate a little bit more on the advantages of using symbolic execution over a coverage guided fuzzer?
Mm-hmm. Sure. Well, to be fair, I'm less familiar with coverage-based fuzzing. I think the question is still whether it would work in with some very sophisticated smart contract that contains a lot of, for example, nested if conditions, if you have to very carefully devise what input variable should be in order to pass all these checks. In general, yes, so I agree that definitely I think the fact that it doesn't identify these issues in the smart contract just characterizes the fuzzers that I have used as having limited ability to reason, because if you simplify it, they'll be able to find it. But in general, yeah, I would say that symbolic execution is probably, is generally considered more useful when it comes to some conditions that are constructed in a way that it's very hard to bypass them without some automated mathematical reasoning about what value should it take.
Thanks.
Thank you.
And next on our schedule is a panel discussion on formal verification. And from now on, Kurt Barry is taking over as the panel moderator, and he will introduce our panel guests.
Thank you, Giannis. Oh, I've got the fan club here. Thank you, thank you. Somebody might have to share. All right, this is going to be the spiciest FV panel ever. Well, we'll see if we can deliver on that. All right, so the general context for this panel is how can formal verification improve Web3 security? And I thought we would maybe start by just having all the panelists introduce themselves, say a little bit about either the project they work on or how they use formal verification, day to day, just so you can kind of know who we have. So you want to go ahead and start, Gila?
Hi, everyone. So I'm Gila Castelnuovo. I work in Centaura. Actually, I have a vast experience from the Web2 security. This is where I come from. I was 8 years in this field. And Certora is, first of all, a security company, and this is what we do. We want to protect the Web3 ecosystem, and we use formal verification in order to do that. We have a lot of formal verification experts in our company, and of course, we implemented the Certora prover, which is based on formal verification. And also, one of our goals is to educate people to use formal verification in order to check the security of a smart contract. So this is also kind of our mission when working with the community. So I hope it answers your questions. So nice to meet you.
All right.
Okay, great. Hi, I'm John. I'm the CTO of Veradice, and so Veradice is a security and auditing company, and so we perform audits in a number of different parts of the blockchain ecosystem, including like smart contracts, ZK circuits, low-level blockchain implementations, and so on. And so we're also particularly interested in building tools because that's what many of the people in the company, have a background in, and so we commonly use tools in order to aid in the auditing process, and one of the tools that we use is formal verification. And so that means for things like smart contracts, we will formally verify critical portions of contracts in order to make sure they're secure and that there are guarantees. And then for ZK circuits, we commonly use more semi-automated or manual methods in order to formally verify that circuits are actually constrained correctly and are implemented in a way that's consistent with the developer's understanding.
Hello, I'm Fraser. I'm the CTO at Cubist, and I'm also faculty at CMU. I actually do more verification in my academic life, where I focus a lot on verifying small pieces of security-critical production systems. But at Cubist, we've been working recently on a key management system, and we're using verification to prove properties of that system. We've also used the Certora prover to prove some properties of liquid staking contracts, and we're collaborating with Verdice potentially on some policy checkers for user policies around key management.
I'm Grigore Roșu. I'm the founder and CEO of Runtime Verification, also professor of computer science at UIUC. My specialty is programming languages, formal methods, formal verification, and Runtime Verification was the company that first audited Uniswap, formally verified Uniswap, also the beacon chain, the deposit contract. We develop formal verification tools and techniques and foundations. For us, foundations are very important. We need to understand why things are correct and why even formal verification tools are correct. Because we've seen so many bugs in verification tools. We saw Paulina's talk. Many formal verification tools don't find the bugs, or if they find the bugs, sometimes they are just false alarms. It's important to understand things from a very foundational perspective in our view. Performance, yes, is important, but to us, performance was never the critical aspect. It's more important to have the right techniques, correct by construction, and then performance always comes. This is something we humans are really good at, to improve performance, once we know what we're doing.
Cheers. Hello, I'm Julian. So I'm the head of formal verification at Nethermind. So Nethermind does a lot of things in the Web3 space, but on the security side, we focus mostly on auditing, monitoring, and formal verification, which is what I do. And currently, our primary focus is on ZK circuit verification. So we have a variety of extractors for various ZK circuit description languages into various proof assistants, particularly the lean proof assistant. And we then can do partially automated and then with some, interactive manual assistance for the verification. And currently, which is something I'm quite excited about, we're working on verifying the RISC-0 ZK VM.
All right, great. So a lot of interesting backgrounds here on the panel. And I thought maybe we'd just kick things off with, just very directly, like, why should Web3 projects use formal verification at all? So many other tools out there. I came from Web 2. We never really did formal verification there. So why should Web3 be using formal type methods? Anybody want to take a start?
I guess I can do it.
Go for it.
Yeah, so formal verification is very important because basically what you have is you've got very complicated code, and people are writing these protocols that have that require some very strict invariants hold. And if those invariants don't hold, then the entire protocol is going to break down. And so that's where formal verification is very useful. It can verify in a very strict sense that the invariant that you need to hold in your protocol will hold at all times. And therefore, that is great for preventing hacks and stuff like that, because there's a lot of people who are very incentivized in order to try to make sure invariants don't hold or corner cases are exploited. And all of these things are things that formal verification is built to reason about and to formally ensure are consistent with your understanding and that your logic is actually implemented correctly.
I would like to add something here. I think that the Web3 ecosystem actually is a very good application on where a bug can be very expensive. First of all, the exploit itself usually involves some stealing of money. So this is why it's very important to have the code properly verified by a formal verification. And also fixing the bug can be expensive too, because we are speaking here about upgrades, and we had a lot of talks about that and how complicated upgrades can be. And also, I think it's a very good application because, first of all, the code is open source. So in a certain sense, it's also more vulnerable because many people are looking at that and looking for bugs. So it's very important to have many eyes looking on that, also good eyes, and of course, formally verifying the properties that we're interested in. And of course, the fact that the code is open source makes also, it makes easier to have it formally verified from many different people and also from auditors. And the third thing, which applies to the Web3, and it's not always right for the other areas in computer science, is that the code is small. So we know that formal verification is actually a hard task and can be hard to do it, like a very complicated system. But usually in smart contract, since the price of having big code is high because of the gas, then it makes the code smaller, and it makes the life of the formal verification tools easier. So this is why I think it's a very good application of formal verification.
Yeah, great answers there. Any other panelists want to add anything to that?
I guess I just want to echo that third point. You can. That's amazing. I mean, if you're working on a web browser, good luck. You can't formally verify anything. That kind of sucks for you. But here, you can do it. So why not at least try, right? There are plenty of good tools that just don't exist in other areas. So worth a shot.
All right, so sort of moving on logically, so we've told projects why they should be using formal verification, but now they say, okay, well, I've got formal verification, that's one thing, but I want to also do security audits, and I want to do fuzzing, and I maybe want to do some economic simulations, and I want to have funds left over for a bug bounty, and but they often operate under constrained budgets, unfortunately. Don't we wish we had unconstrained budgets, right? So when you look at the trade-offs between formal verification versus these other tools, and maybe a project's looking oh, do I get an extra audit, or do I pay to have some formal verification done, or something like that? How should they kind of prioritize formal verification versus other techniques? Can you just do formal verification and nothing else? Does it replace everything? Or how do you think about those trade-offs?
Yeah, so I think there's a lot of things that can be said there. So formal verification, I mean, despite the fact that it definitely scales a lot better in this area, it can still be a lot of work because, I mean, I think Giannis pointed it out at one point, you need invariants. Invariants are very important here because sometimes, even though the code is, smaller size and is actually more tractable, there are things that can mess a verifier up. And so depending on the type of technology that you're depending on, nonlinear arithmetic can get very complicated for at least automated verifiers. There's a question asked about that earlier. You can also have issues with loops and stuff like that. And so really what at least we recommend to clients typically is anything that is security critical. So anything that is going to be storing money or maybe routing money or anything like that should probably be formally verified so you have those guarantees. But other tools are also great at finding bugs as well. So for that reason, we commonly use fuzzers, static analyzers, and stuff like that. And so early in the lifetime of your project, it's great to use a static analyzer. It's great to use a fuzzer and property-based testing in areas that maybe aren't as security critical. And then for those components that you really need to make secure, that's normally where we recommend formal verification. And then for ZK circuits, we always recommend formal verification.
Personally, I can add that I don't think that that formal verification replaces anything, but it cannot also be replaced by anything. I think that there was a talk in the 101, maybe it was yours, that defined actually security by layers, and you have to have all of them because each each security layer will have like some holes. So and no one of them is sufficient to have a whole security coverage. This is why I think that it's great to use formal verification, but when thinking about having your code secure, you cannot give up on anything. This is my thought. I know we are doing formal verification, but actually we are doing a lot of other stuff which needs to complete it, and also auditing. It's something very important after formal verification, and of course also verifying that the specifications are correct. It's also very important. So this is how I think it applies for formal verification.
So, yeah, agreed with everything. One aspect of formal verification that doesn't seem to be entirely clear, because many think that, oh, I formally verify my code, so it is correct, is that formal verification really, what it really does for us is to help us identify the assumptions under which the code has the properties we think it should have. And that's extremely useful because it makes us aware how things can go wrong, and also what to monitor after deployment as well. So formal verification, yes, is a tool, an excellent tool that puts some rigor in the process. It helps us on many aspects, but we believe that the most effective use of formal verification should be under the hood. We believe that tools should be easy to use by developers, and they should use formal verification without even realizing they use formal verification. Same like you have type checking in programming languages, right? You use a type checker without realizing that you use a very complex algorithm under the hood that does something really that people put a lot of effort into. Same should be formal verification. We believe that it should be a smooth process from writing programs, writing tests, then fuzzing, then formal verification, then more properties. So it shouldn't be like formal verification or no formal verification. That's how I think it should be. But also you should have the full arsenal of formal verification tools at your disposal if you really want to do heavy formal verification, to specify absolutely everything and verify absolutely everything. You should be able to. But most of the tools should just be consumers of formal verification techniques. And we should all put an effort into educating our clients how to use these tools themselves. If, as auditors, we should audit specifications, not code. That's what I think we should do.
I think that's a fantastic answer. And this doesn't, I'm now not talking exactly about smart contract verification, but at Cubist, when we're working towards verifying user policies, we start with these invariants you're talking about, and we can actually reuse them for fuzzing first. Then we can use them for lightweight static analysis, and then one day we can actually build on them for full-on verification, and we get like the benefit of that initial specification throughout the lifetime of the code, and we get stronger guarantees over time. So we found that really, really useful.
I love the points about, auditing specifications as well as, just the code itself. Like, I know of instances we had at Maker where, there was a bug in the code and the spec had just the exact same bug. And so you needed another technique to catch that, either review or a unit test. In that case, there really should have been a unit test in that one. But that leads me into another question I wanted to ask, which is kind of like, okay, specifications and provers, like these are yet more code on top of the code we already have. How can we have, high trust in, if the Sartor prover or the KVM, spits out and says, yeah, the spec, is accepted, it looks good. How can we trust that? What measures are necessary?
So I can answer about the Sartor approver. So first of all, it's really important, as you said, to review the specifications. Okay, in Sartora we also offer tools, but you can also have your own tools, for instance, to mutate the Solidity code and just to make sure that if the Solidity code has a bug, then the specification finds it, because sometimes this is not the case, because as you said, you can have a bug in the specification. So this is one option, which is like to mutate the Solidity code. And another option, and this is something that also we truly believe in it, is have as many people as possible to review the specification. This is why we are doing like this contest in which like as many people as possible are writing specifications, and recently we're even awarding people for writing specifications, because a prover can be amazing, but if the specifications are not good, then the security of the code will be as good as the specification. So this is a very important thing, and of course I truly recommend just to look at the violations. I mean, okay, so if you have a violation, let's just look at how it looks like. Does it really represent a real example that can happen in your contract? And another option also to look at the proof. I mean, we also offer a way to look at the pets that were actually evaluated, and this is something that we are working on that we really want to give to our customers, but I'm sure that also other tools offer that. So it's very important to as you said, as you can think, be paranoid about everything from the code itself to the specifications. So this is my point of view on this.
Yeah, so debugging specifications and also debugging verifiers in general is a very hard problem, because verifiers tend to end up being a very complicated set of code. I mean, it's normally relatively large, and it normally has a lot of dependencies, because you've got an SMT solver, you might be trying to perform optimizations with abstract interpretation, so there's a lot of areas where things can go wrong. And so what's important, at least in order to validate that your verifier is actually doing what you want it to, is to have like a proper benchmark set. And I think right now, most likely all of the companies that have verifiers have their own internal set of benchmarks. I don't think that we really have a very good set of external benchmarks that everyone's evaluating on. I mean, in other areas there are verifier competitions, which we don't have in this area, but I imagine every single company here has their own set of benchmarks that they're evaluating on internally. And at least for us, when we are checking to make sure the specifications that we write are correct, we go through a very similar process where normally if something says verified, then we start doing, we normally don't mutate the code, but we mutate the specification and start changing the specification slightly to make sure that if we mutate the specification in particular ways, we end up with expected counterexamples.
So, oh, sorry, a bit loud. The techniques that we use at Nethermind are mostly based on interactive theorem proving. So our trust base is the dependent type checker of whatever proof assistant we're using. Typically the extractor, because we'll have some piece of code that extracts your code into some version that Lean or whatever proof assistant can use. And of course, actually the formal definition of the language inside of the proof assistant. So for the extractor, typically it's a very simple piece of code. There's a sort of a one-to-one mapping there. Obviously, we set up fairly large test sets, etc. But it's something simple enough that it's not considered to be too dangerous, a part of the trust base. The dependent type checker, in our case, we use mostly the Lean proof assistant, which has one of the largest corpuses of mathematics being formalized into it. So in terms of the amount of stuff that people throw at it to find bugs, I think it's one of the better places to be. And in terms of the formal specs, we tend to, of course, make sure that our specifications for the languages, formal definition, is executable in some sort of way. And therefore, we can actually just, like John described, run it against some conformance tests, do fuzz testing, do a specification mutation, all of these sorts of things to see if we get the expected. So yeah, similar situation.
I've been in this field for 30 years, maybe. That reveals my age, maybe. And I've never seen communities of formal methods people agreeing on a specification language. So I think the only specification language I've seen probably is the SMT-lib, which is also used in SMT competitions. Other than that, there are lots of tools even for very simple formalisms, like linear temporal logic, which has only 5 constructs and different syntaxes, completely different names for the same thing. I think that will be a challenge, also for coming up with benchmarks for our tools. And I take this opportunity to say that, again, all my years I've designed lots of specification languages, and I proved lots of theorems, which turned out to be useless in the end. It's very important to pick something simple that connects quickly to your audience mind. And I confess that I really like tools like Foundry. They are not formal verification tools by design, but they are excellent doors into the formal verification field. So if you write smart contracts, you should test. And if you test, you should go to the next level. You should write property tests, parametric tests, and you should use fuzzing, yes. And then just push another button next to fuzzing, symbolic execution, formal verification. And then you do formal verification without even realize you do formal verification. And I want to actually maybe kill a myth. There is a myth that property tests are weak. You cannot express any properties. So no, that's incorrect. Actually, property tests are as powerful as whole logic. Preconditions, code, postcondition. Assume, code, assert. So you can write any Horde triple as a property test. So it's not like they are not expressive enough. They're expressive and they are practical and easy to use. That should be the entry point, I think, that, that we can build upon.
And I want to add on this. I was just discussing with security people, actually hackers think by properties. This is why it's very important that when you want to verify the security of your code, you also need to think by property in order to think about all the possible initial state and middle state that the contract can get into, because this is how attackers eventually will think like. So this is how we want to protect our code. So this is why I strongly agree with you, and this is why I think it's a myth, and I think that even if it's a myth, we need to start doing that to make our code more secure.
Yeah, I love it. Yeah, I've personally experienced, thinking in invariants or properties. It's very powerful when developing, and I also like, the vision of it should just be something, you just kind of do. You've already written a test. Why shouldn't you get a way to formally prove things? And I know that, there are a number of efforts along these lines. I mean, even at Maker, Polina actually, who gave the last talk, right, experimented with integrating symbolic execution into Foundry itself. But this is actually a good lead into the next question I wanted to ask, because, we aren't at this space age future where you've just, you've written some property tests and, you just hit another button or, run the right command and it's all automatically proven for you. Right now, there are a lot of different ways that projects can decide to apply formal verification. They can hire a company to write all the specs for them. That company may or may not also be accompanying that with some sort of manual auditing effort. They might, use a SaaS tool like Certora and write the specs themselves. They might do some sort of hybrid method where a company writes the specs for them, but then they maintain them afterwards. They can also do this earlier or later in the development process, et cetera. So there are a lot of different ways projects can use formal verification. I'm wondering if the panelists have any thoughts on which ones are optimal or which ones they would recommend in different situations, depending on the needs of the project. Big question, I know, so feel free to collect your thoughts.
So developers definitely can and should be using formal verification. If they're, right now we don't really have a button that can press in order to perform symbolic execution from Foundry, but I know that's something Runtime is working on, and that would be something very powerful for developers. But developers aren't going to have the security mindset, and so really one thing is developers should try to do whatever they can to find bugs, and then after that, it's the security auditor's job to go in and basically try to exploit everything that they haven't. And I am of the opinion that auditors should be using tools like formal verification, fuzzing, and stuff like that in order to bring higher assurance audits to their clients, because all of those tools will, one, help the clients feel more, let's say, comfortable with the results of the audit, but also it's something that clients can then keep and move in the future or use in the future. And so yeah, I think that essentially it's important for everyone to do whatever they can. And I know that's not really a very satisfying answer. Developers should be using it. They should be, you know, probably not using it quite as effectively as like security analysts, but it's still useful and important to do, and there are going to be people who are going to become very proficient at it. And then for the properties that they're not able to verify because, you know, you eventually are going to have to fight with a solver at some point or something like that, that's when a security company can step in and complete the formal verification and also review the specs that they have written and find the holes that they've missed. Because, you know, with some, or with most formal verifiers, if they haven't thought of an edge case and none of their specifications target that edge case, then it's going to be missed.
I completely agree here. The only addition that I would like to add is that I don't think that formal verification needs to be done only once. I mean, probably like the goal should be to have it in your CI, because we actually saw with our customers that the code gets changed, and maybe they're working on another version of the same contract, and things break. Like even the simpler invariant, the simplest invariant can break, and this is something that actually CI can be very helpful in detecting it, because having like the old code being audited again can be very expensive. But once you had like the whole process you had like the whole specification, then it can be very easy to just rerun the like any formal verification tool on the same specification to just make sure that nothing broke. So as John said, I also think that should be like from the beginning to the end, and maybe also in the deployment itself. I mean, like, I think it should be ideal to formally verify that also the deployed code adheres to the original specification, because we saw before that something actually gets broken during the deployment. So I think that also we should even verify the code that it's deployed in the blockchain, because it can be also very helpful there.
Yeah, I think that's a great point about, you know, verifying the actual deployed bytecode, because, you know, it is actually public, you know. You know, you can't usually verify what's, you know, running on the servers you're interacting with, but in Ethereum you can. All right, so I think we've made the case to everyone that, you know, they should be using formal verification. You know, there are lots of options. There are lots of ways to trust it. There are lots of ways to do it. Then how do we actually increase adoption of formal verification in Web3? Like, I think it is steadily growing, but, you know, not all projects are using it yet. And, you know, what needs to happen?
I think Gregor already answered that question, ease of use.
Yeah. I think there's one other facet here, which is we're doing pretty well on the smart contract front, but there's a lot of other code that touches the ecosystem that is really, really important, and also not formally verified. And they're, you know, maybe we think of this as more of a Web 2 problem. It's like, okay, your key manager code, that's just some Rust code or some C++ code or whatever. But that's really has to be right? Or like your MPC wallet implementation, that should not have bugs in it. So I think more focus on the non-smart contract pieces of the ecosystem would really help everyone.
Yeah, definitely agree there. Go ahead.
I think that I agree here, but I would like to add a point. I think it's also, we are like a community of formal verification, and I think that it will be great like to motivate people on why it is important. So like publish everything that was actually found by formal verification. So we need to educate also about the motivation and why formal verification is important. And I think that like we are pretty sure about that here, but probably the people in the ecosystem, they're not enough convinced yet. So I think that like having like motivating can be like publishing things and explaining where it actually helped, and in order to educate more people about why it's important.
Yeah, I think publicity can help a lot. Like the more bugs that are found with formal verification, I think goes a long way. Like the talk from NetNL earlier about finding the bug in PRB math, right? I've audited code bases that use PRB math, and usually, you're told like, oh, don't worry about the math, just focus on the business logic, because, the time is finite. But, it turns out you actually take a close look at that and write some specs, and oh, there was some bug in the math, and, that's the best marketing, in my opinion. All right. I thought at this point, I can keep, interrogating the panelists a bit, but, FV is, mysterious, hard to understand. I thought we'd open it up maybe and see if the audience had any questions and wanted to ask any. All right, there's one there.
Hey, at some point, one of you guys mentioned that blockchain is a great place to try formal verification because the code size is small. But with all these scalability stuff, we expect that code will actually, hopefully, at least in my vision, should get as complex as a Web2 server. How does formal verification scale going ahead in the future?
Yeah, so code might get bigger, or the size of the contracts might increase, but that doesn't necessarily mean that your transaction size might also be able to increase, but really, people have been able to do a lot with this kind of asynchronous model that we end up seeing here, where, in a lot of cases, there's a lot of functionality that you want to provide where you want to provide someone with an entry point, and that's going to be doing something very specific. And so normally, people are already, I would say, to my frustration, designing code where you have an entry point, it does something very complex, it triggers like 20 actions, and then that is just going to make things more dangerous. So even though technically, things might increase, that also could end up having other side effects, like making the ecosystem less safe, I would say. And not that it's necessarily safe now, but I would be hesitant about having people write this really complicated function where someone's going to be, I don't know, executing 1 million instructions in a single transaction.
I just don't think we're going to also, or I guess another way of putting it is, say if proofs get good enough that we can really scale to huge systems, that means something fundamental has changed, and the relationship between proofs and verification is deep enough. That probably means something has changed in verification too. So.
And I guess another technique that we could use at that point is abstraction, because I think that's an area that hasn't necessarily been explored that much in this particular area, because for the most part, we've been able to reason very precisely about these things because of the code size, but we can always abstract over contracts in order to perform larger verification, which is what is kind of commonly done for larger systems anyway.
So formal verification is an old field, has been used in many other domains before, particularly in hardware verification. There are entire chips that have been formally verified. And the key insight in almost all instances where formal verification was successful on large systems was compositional verification, or divide and conquer. Split the system in components, verify them independently, and you can scale that way. I think formal verification in the blockchain space is just scratching the surface. It just started. There are fields where very large programs have been formally verified already.
Yeah, so if I can add to that, oh God, sorry, I get used to this. Obviously, as I mentioned earlier, we're verifying the RISC-0 ZK circuits, and that is of the order of hundreds of thousands of constraints. Right, and so a lot of the techniques that we've been talking about here would not scale very well to this. So once again, we rely very, very heavily on abstraction, being able to break down things into sub-gadgets, write specifications for them, and then really in the end, when we're reasoning about the high-level circuit, we're not really reasoning about circuits at all anymore, rather just how these specifications interact, these human-readable specifications interact. And yeah, so I think in ZK circuit verification, particularly where you can have very, very large circuits like this, compositionality abstraction is incredibly important. Although at Nethermind we do try and apply these same techniques to smart contract verification too, because yeah, as we said, they're getting bigger with L2 and other scaling solutions. So
I think we're also in a good position where there's been a lot of verified software already, and so we can build on what's already verified. That's great. It's kind of different from, say, the OS or browser world or something where you have like millions and millions of lines of legacy code, none of which is verified. And if you're just staring down that behemoth, it's like, okay, where do I even with abstraction, like good luck. So we're in a much better beginning point.
So how does the complexity and difficulty of formal verification compare to the difficulty of figuring out what actual humans are going to do with this system and how that's going to go wrong, and what's the relationship between spec writing for formal verification and working out what crazy thing a user will do that turns out to be disastrous?
There are some works in that area where you combine, you actually formalize humans and they satisfy some physical constraints. You cannot very quickly move your hand from here to here, things like that. But in general, same like with verification in general, you have symbolic variables and then you do constraint analysis. Humans can do stupid things, and you have to take them into account. But there are people who do research in that area, human-computer interaction, and they have formal models of humans, even of organs in humans, like formal specification of your liver, and they, so.
Yes, thank you for the panel. Does it make sense to formally verify other components of the Web3 ecosystem, for instance, blockchain clients?
Definitely. So, Julian and I both mentioned how we formally verify ZK circuits all the time. Those can be integrated, kind of in with the smart contract, or it can be with the blockchain. And when it comes to formally verifying aspects of blockchains, that's definitely important. One of the first audits that we did, actually, we performed some lightweight modeling and formal verification over that model of a blockchain, because it can be really important to understand how monetary assets, because again, money makes people greedy and then hacks, but how monetary assets are being exchanged, because you can end up with really bad bugs in blockchains, like double spend vulnerabilities and stuff like that. And so again, with a blockchain, it gets a lot harder because it's bigger, but that's where it comes down to isolating the critical components and then performing formal verification over those critical components, and then having a model of how other aspects of the system should interact with those, and maybe not verifying, but you could perform a more lightweight static analysis in order to ensure people are interacting with that component in a consistent and correct way.
In the same line of thoughts, is there some way that we can have a verification, formal verification for economic models? Where, I mean, we can create invariants for codes, but is it something that can be applicable to economic models? Or is it something that is completely out of the scope?
Actually, this is something we do even more at runtime verification than verifying actual code. We work closely with our clients to formalize their business logic, and then we prove properties about the models. Or consensus protocols, you can prove properties about them, like they don't fork, without even looking at any line of code.
Yeah, starting at the model level can be really important as well, because if you're able to formally verify a model, then that can actually be used to help formal verification in the future. So if you can have specifications that describe the model, then when you actually write the code, you can actually reuse those specifications. And then another thing is, at least in this area, if you have some sort of abstract model or some, kind of high-level model of what is going to hold. And one thing that we see pretty commonly is people mocking other contracts that you then have to formally verify against in some cases, which can be dangerous because that might not be the actual behavior of the contract. And so if you have some sort of model that you've performed formal verification on and you have verified that your underlying implementation is consistent with that, it means that now other protocols can even make use of it to abstract away your specific behavior and then use that when they are developing their own protocols which would interact with yours.
Yeah, I think in continuous cases you might have to accept some level of approximation because, you know, for example, if you're really trying to address like a high-level economic behavior, like is my lending market always solvent? Well, you've got to model price behavior. You've got to make some assumptions about that. Like, are you going to assume geometric Brownian motion? Well, like that's not really true in practice, right? And so you may be limited at some point by assumptions, but you know you can usually do something, right?
Hi, thank you for a great panel. So I'm coming from the perspective of a smart contract developer and not a security auditor. There are lots of different types of tests to write, so standard like unit tests, fuzz tests, invariant tests, et cetera. And each of those comes with a certain model of how to like look at the code, look at the design of the system and structure that test. Do you have any tips or general approaches towards extending testing from just that to using the symbolic tests of tools like Holmos or similar?
I think that it really depends on the language in which you are writing the specifications, because for instance in Certora, like the CVL language looks very similar to the Solidity code, and so it should be, like I'm not saying that it's easy, but it should be quite intuitive to write the specification for one person who is actually familiar with the Solidity language. So I think it really depends on the specification language, and
So going from tests to going to specifications is actually something very powerful and something that we use when we're developing specs for clients, because tests end up encoding the intended behavior. Normally, you know, there might be some edge cases that weren't considered, but it at least gives you an idea of what the developers were thinking about. And so a very easy way to go from test to, let's say, a property-based test is to, instead of testing against a concrete value, make that more of a symbolic value, and now you can use symbolic execution. You could perform some sort of property-based testing. And so just even removing those concrete values, it can already get you part of the way to something more powerful than what you were starting with.
All right, we've got about a minute left. I wanted to sneak in one question of my own, which is actually inspired by the previous, but kind of flipped on its head. So if you're writing detailed enough specification, you're really getting into all the expected behaviors. Why do you actually have to write the code? Maybe you just write the specification and generate correct code from it. Is that science fiction, or
that's
we
called
see
program
that
synthesis?
Okay.
No, that's a separate field of study where you write the specification and then you have something generate provably correct code. And so Ishal, my advisor, is very interested in program synthesis, but that will take longer to discuss.
So not feasible yet.
Oh no, it's feasible. People do it all the time. It's just, it also has some scalability issues. And so like one of my projects that I did a long time ago was I wrote a synthesizer that went from our specification to smart contracts, but I think to synthesize an ERC20 circuit, it took about 4 hours. But you know, that was something that I wrote in like a month, so.
Actually, I'm a firm believer that people should not write code. They should write specifications. And the code should be generated, or actually when before being a professor, I worked at NASA as a research scientist for 2 years, and what I've done was synthesis, was schema-based synthesis. And we generated very large programs, thousands of lines of code. I think the largest was 50,000 lines of C code, and it was provably correct. It was a fragment of C provably correct from specifications for Markov models. So it is doable, especially for domains, specific domains, like smart contracts of a certain kind.
All right, well, that would be really cool. Anyway, we're out of time, so let's have a round of applause for the panelists. I think that concludes the formal verification portion. Let me just look. Yeah, we got a break. So get a coffee. Oh, no coffee, apparently.
Thank you. So we are going to take a break till 2:40. And after that, we'll go start with the panel on bridges. So see you back. Quick announcement. If you're one of the panelists on the Bridges panel and you're in this auditorium or downstairs, please make your way to the front row. So we're looking for Hugo from Flare Network, Irene from Layer Zero, Robert from Autosec, and Valerian from QuantStamp. So please, yeah.
כן. We are starting in 1 minute. Please get ready. I think so far, and especially if you are attending remote, so far it was very calm, but now we're going to have some drama. So get ready. We're going to have some drama. We actually prepared these panels. We have actually 2 panels. I think last year they were interesting. I think this year they will be even more interesting. We have the moderators. I see Moody is here for his first panel on bridges, and then after that there will be a panel auditing. During last year, we know people, there's companies doing auditing, there's community doing auditing, there are personal auditing. So all of it will come together. There will be a lot of drama. Get ready, it's starting soon. Moody, can you bring your people? 41.
Hello, everyone. Welcome to a fun panel on bridges. So we'll get started very soon. But before that, let me throw in some introductions. I'm Mudit Gupta. I lead security and smart contracts at Polygon. And here we have a collection of interesting people. So some of them, you can see the names up there. And we have a surprise entry in terms of Neve from Hexagate. And I guess I'll let everyone introduce themselves and talk a little bit about what they do.
Hello, everyone. I'm Yosuke, and I'm working at 2 companies. The first, I am tech lead at Pheasant Network. Pheasant Network is optimistic and liquidity-less bridge, focusing on Ethereum layer 2. We support Polygon, Arbitrum and then Optimism for mainnet, and then we support any other layer 2 like Linear and then Base for testnet. Yeah, and then I am also technical advisor at Skyland Ventures, which is Japan-based VC, and then they have investments to Taiko, which is ZK EVM, and then they also have an investment for Orbital. Yeah, yeah. I'm very glad to be here, and then thank you for giving me this opportunity.
Hi, thank you so much for having me. My name is Irene. I am head of strategy at Layer 0 Labs. Layer 0 Labs is the creator of Layer 0, the protocol, an omnichain interoperability protocol, and Stargate, the leading native asset bridge.
Hey, I'm Robert. I help run OtterSec. We read a lot of bridge code. Yeah.
Hi, I am Valerian. I work for Quantstamp as an auditor. And I made some audits on bridges.
Hi, I'm Hugo, co-founder of Flare Network. Flare is an EVM layer 1 based around optimized data acquisition. The reason I'm here is we've just released a bridge protocol called Layer Cake, which is essentially follows an optimistic model, but we think we've solved or have good solutions for the griefing attack that comes along with optimistic models and the slashing issues that are very, very hard to implement with optimistic models. I can explain more later, or you can go to our website, flarelabs.org.
Hello, everyone. Thanks, Muted. I'm Neve. I'm the CTO of Hexagate. We're a real-time Web3 threat intelligence company, basically discovering all the threats and on multiple blockchains. So we help protocols, bridges, and essentially like any Web3 developer to be able to detect and prevent any threat that might threaten the protocol or its users. So happy to be here.
Thanks everyone for the intros. We have a great set of panelists here. I'll give everyone some context about this panel. So everyone you see here most probably applied for a talk that was related to bridges. And then Muli was like, that's too mainstream. Let's put them all in a panel and let them fight. Let's have some fun. Let's have some drama. And that's why we are here. So in like this 30 minutes of panel or whatever, we can't really change the world, but we can at least have fun. So and that's the aim of this. There is no scripted questions or anything. It's just all going to be from heart, and hopefully we'll have fun. And with that, okay, I'll shoot with first like a Kickstarter question. I'll ask everyone for one bridge they would recommend everyone to use and one bridge they would recommend everyone to avoid.
I can start. So I recommend everyone to avoid the multi-chain bridge following the last event. And essentially, like there are like great bridges, and I think they're quite unique in the way in the space, in the sense that bridges are mainly off-chain, and that also brings a lot of opportunities to stop attacks, because many times like you have a lot of time to protect before an exploit really happens. Of course, like it narrows down the attack surface, and it doesn't mean there is no attack surface. So all in all, like there is both snark-based bridges, like ZK EVM ones, like Polygon recently launched, and it's obviously a great innovation. And Consensus is also about to launch theirs as well, alongside like the optimistic ones, which there are available, which we've been using like extensively, the ones from Arbitrum and Optimism and so on. So all in all, like they're great other bridges which we're using like any day on Hexagate.
Yeah, thanks for that. Let's keep it like bullet points, just one name to avoid, one name to use.
I'm happy to go next. I'll say maybe a hot take, but to your point about reducing code exposure, I would discourage builders from integrating bridge aggregators, and I would encourage people to use Stargate, the most popular native asset bridge built on top of Layer 0.
That's interesting. So I'll come back to that, but anyone else wants to pitch in? Okay, I guess not. Then let's continue with this. This is an interesting one. Why do you not recommend bridge aggregators?
A few different reasons. I think first one is around code exposure. So with bridge aggregators, there's additional middleware that you're introducing there. And on top of that, you're also creating a basket of bridges and thereby increasing the chances that one shard of it will lead to a hack. And so if you're building a wallet, for example, it might make sense for convenience to allow users to just sort of route to the fastest bridge, like in an airline industry or those like flight aggregators. I don't know what they're called, Priceline, something like that. But with bridging, it shouldn't be an airline industry. Like security is actually paramount. It's like don't take the JetBlue when you're transferring your funds. And then I think the other primary reason I would talk about is services versus protocols. A protocol is something that is immutable and evergreen, open, permissionless. A service requires the creator company to maintain the integrity of the product. And so if in your infrastructure stack you're leveraging something that requires the liveness of that company, it requires the founder to not be arrested, it requires the devs to not get COVID, then you're building in a lot of dependency into your product. And even things like, is a service that you're leveraging, does it require a significant amount of runway? Will they close their Series A? In crypto, we see a lot of projects that just poof, and like the Slack Connect is gone because they've run out of funds. And so you should be leveraging true protocols and ones that are not dependent on the integrity of human behavior, but also the liveness of a creator company.
Fair points. I wish I had someone from bridge aggregator here. Would have been a fun conversation. But those are very valid points to like, since anyone wants to defend bridge aggregators here? Go ahead.
Yes, actually this is something that we've thought a decent amount about. I guess, generally when we think about these sorts of bridge aggregators, you have like some set of like end bridges, and then you choose some threshold of the amount of bridges to sign before you pass some sort of message through, right? So for example, if you want to optimize for like really fast messaging, maybe you have like 1 out of n. If you want to optimize for authenticity of messages, maybe you have like n out of n, or like n minus 1 out of n, or like 2/3 of n over n. And I think one difficult part, I kind of agree with Irene, like in the status quo, I think right now, there's not that many super legitimate bridges. And I think one difficulty is that like, n is probably going to be something small, right? Like n is going to be like 3 or 5 or something. And it's pretty difficult to find, maybe like 7 or 10 really reputable bridges that you can even put in some sort of aggregator set. And I think one difficulty there is like if you have, only 3 bridges, if you have a 2 out of 3, that doesn't really give you a super meaningful improvement in security, right? I mean, I think there's like 2 things you want to optimize for. One is like passing correct messages. The other is making sure that you don't expose yourself to unnecessary denial of service risk, right? So if you have like a 3 out of 3 multi-sig, for example, or 3 out of 3 aggregator, if one of the bridges go down, as Irene mentioned, then your entire set goes down, which is probably not great, right? So you probably want something like 2 out of 3 or 3 out of 5. That being said, I think as more bridges develop and they become more mature, I feel like if we get to the threshold where we have like 7 bridges that we're really confident about, maybe something like a 4 out of 7 multi-sig or even a 3 out of 5 could make sense, right? If we have 4 out of 7, three of those bridges could go down, and we still preserve critical properties of liveness and safety. And I think that gives you a lot better guarantees than if you just have one bridge. It might be hard to know which one to use, even though there's like a lot of relatively solid ones. This way, you're kind of just like spreading out the risk.
That makes sense. I, for one, I'm not a hater of bridge aggregators. I actually use them. They're super cool, but in a different way. So I don't, as Irene was saying, integrating with the bridge aggregators is, I think, risky, at least right now. The way I use them is to search for the bridge that actually supports from where I want to go. I want to go from this weird chain X, from this weird chain B, and I have no idea which bridge actually supports it. Layer 0 maybe, but probably not if these are 2 weird chains. So I just go to the bridge aggregator, and then it tells me which all bridges actually support this path, and then I can choose the best one. I can go there directly and do it. So it's a good
search and discovery.
Yeah, exactly.
I will say there is a huge green space or white space for a tool like this. And even myself, when I'm doing like daily diligence on different pathways, I have so many tabs open at once. But then with bridge aggregators, I will say there are oftentimes issues with the data that they're actually pulling there. And I think every other day we are in conversation with these teams about how to fine-tune that.
Yeah, for sure. They'll get better, but yeah, there's something there they can work on. Okay, moving on to the next question. So as we have seen, like bridges are a technology that is constantly under attack, especially now. The last few big hacks in this space have been all related to bridges. Multi-chain, Nomad, Ronin, Harmony, all of these bridge like over $100 million hacks. So to the folks here on the panel, on the bridges that are left, not many are left, but among the ones that are left, and even the ones that have recently gone down, what common weaknesses do you see? Like what problems do you see in the bridges right now?
Is this on? Yeah. And the biggest fear I have for bridges is essentially criminal charges over essentially what a bridge is. The majority of the bridge models, maybe exclude optimistic, maybe exclude layer 0, but certainly the multi-sig based bridges. So that's essentially, it could be painted as a conspiracy to transmit funds that have not been vetted. And to me, I think, with the SEC losing, pretty heavily against, Ripple, I think that another vector of attack is more sort of criminally based around money transmission without compliance.
It's a weakness, but it's also a consequence of a trade-off. I would say that if a protocol wants to increase the security of some parts, they would have to increase the centralization, for instance, and the centralization has some positive effects in terms of security over the whole system, but in the other way, it has also some drawbacks. And a lot of bridges have some weaknesses based on the components used, but from another perspective, we can also consider this as a choice, a design choice, and we have to be aware of all the components of the bridge before trying to using it.
Yeah. Maybe another comment from my end is that I don't really view bridges as some unique creature, substantially from DeFi protocols, but only the fact there's only the fact that they're normally are in charge of custodying lots of funds because they connect chains together, and this is why they become so lucrative to attackers. And the fact they're a bit more of a complex beast, it makes them much more interesting for attackers to actually research. Because in the DeFi protocols, eventually, you have a few primitives that you can work with the protocol. On a bridge, you have so much more, and many of the attacks that you've mentioned, Mulit, were around even private key compromises, and that's only just Web 2 kind of threats for bridges. And this is because the team probably haven't figured a way to actually operate the bridge in a decentralized and more secure manner, but rather just have those keys managed in a non-secure way. So I would say just really hard to cluster vulnerabilities on bridges, but rather say that the attack surface is so vast as opposed to just just DeFi protocols. So it just can be anything private keys, managing possibly the bridge, all the possibly Merkle proofs that can be validated in the wrong manner, and possibly tokens can be attacked as well, because then you get unbacked minting and so on. They're just so composable in their nature, so it makes them the attack surface just bigger.
I have a feeling Robert will probably speak to this as well. We've used OtterSec for audits, but to your point around the risk vectors for bridges being similar to just general protocols, the majority of bridge hacks over the last year were due to smart contract upgrades and largely made by protocol developers who were intending to introduce something that was positive, like a new feature or patching something. And so if you're using upgradable contracts to build a bridge, you are introducing all of the protocols that have integrated your bridge or all of the users to the risk of like widespread contagion. In the same way that you would never accept an upgrade pushed to your Trezor or to your ledger, why would you do the same for your DeFi protocol? You should be able to opt into it, and those contracts should be immutable. And so that was something that really informed how we designed the Layer 0 protocol. How do you design a messaging protocol that is entirely comprised of immutable smart contracts, but also enables evolution with research over time, with better validation techniques, since what we're using today should not and will not be what we use 5 to 10 years from now. And then to your point around, my fellow panelist's point around like government crackdowns and things like that, also designing a bridge or messaging protocol to be censorship resistant, for example, from day one, and comprised, again, built with immutable smart contracts, guarantees that your technology cannot then comply with or be perverted to fit into different regulatory environments. If you build your technology in a way so that it can, it will be. But if you create these primitives that are evergreen and simply cannot, then they won't.
I guess I'd kind of, can I ask a question or can I disagree with people?
Yeah, sure.
Okay. Yes, I guess one thing on the legal risk. I think I think you mentioned like the legal risk, right? I guess I wanted to clarify a little bit. When you say legal risk, are you saying that bridges are too centralized because there's like one entity that is exposed to all of this legal risk, or is it like bridges as a whole? Like if you send funds illicitly, like the entire bridge can be taken?
No, I think it's essentially, I think Irene's comment between the protocol and the service provision, right? Which is, if you look at, a multi-sig bridge, you have some set that have come together in some manner, usually without, a decentralized process to come together, usually an agreement between each other. That is, if those people are transferring funds across chain that are essentially from a rotten source, that could very easily be painted as a conspiracy to launder money.
Yeah, I think that makes sense.
Okay, yeah, for sure. That's definitely an interesting risk vector, and for sure the governments have their eyes on that. But us being more experts in the tech, let's move on to the tech questions. So I'll ask that, like on bridges, it's true, like there are different types of bridges, not all bridges are same. I broadly categorize them in 3 categories: centralized, MPC bridges, and then the decentralized bridges, which work on proofs and so on. So on that, the MPC bridges have seen lots of hack recently with multi-chain, for example, like turns out all of their keys were with one person, even though they claim to be MPC. Similarly with Ronin, they were MPC, but 5 by 9, and 4 of them were one entity, and that entity also had access to the 5th. So again, just one centralized player. And similar thing with Harmony. So an open question here from a technology perspective, that how would you guarantee or trust an MPC bridge that they are actually using the proper MPC technology and aren't just hiding behind MPC as a wall?
I think we should add some redundancy at the level of the communicator. So between 2 chains, the communicator has a role to watch what happens on the source chain, to verify if it's malicious or normal request, and then to relay on the destination. And the MPC is only one communicator. And I think if we could add different technologies, concurrent, and to make a kind of meta MPC with 2 out of 3 different protocols or different solutions, maybe we could have a better and more secured way to communicate and to relay the messages. However, I think it would come with more commissions because more people would be involved. However, the risk of collusion would be lower.
Makes sense.
Yeah, I mean, I feel like this question is, I guess, more about like how do we ensure decentralization of any validator set, right? Like I think, the root cause of these hacks, I don't think was like MPC. I think it was that, the CEO had all of the validators on his personal AWS account, and like once the guy got arrested, it seemed like that was a single point of failure. I mean, I feel like this is a pretty hard problem, right? It's like you can attest, and I think Multi-Chain did attest, in fact, that they had a relatively independent validator set. When we asked them, I think they claimed that they only owned like 7 out of 22 of the validators. But I think it's really up to the community or people to like dig into the identity of these validators and try to ensure that they are like indeed independent entities that are hopefully reputable and have their own control, right? Because I think otherwise it's pretty hard, like from a pure technology standpoint, like only looking at the chain, I think it's essentially impossible to determine that like the end user of these EOAs or of these private keys are actually different. It requires some off-chain sleuthing or some additional analysis that to paint a more complete picture.
I would just add that another mechanism I've seen more or less implemented by the next solution of Chainlink is to have the actors playing the role of the communicator, split it in 2 roles. One that is doing the communication part and one that is doing the verification that the validators are doing the right job or not. And it's like a level of verification inside the verification component. I think that approach of separating the roles and having 2 concurrent roles, both incentivized to act in favor of the protocol, could be a solution.
Yeah, I kind of agree. I kind of disagree. I mean, I think that like at the end of the day, you have like data from one chain and you want to get to another, right? And then like however you slice it, you have different parties attesting to that data, and then you want to like abstractly you want to like take some aggregate set of those signatures and then come to some sort of conclusion about if that data passing is valid, right? So I think you could split it up in 2. You could have like 2 different roles, and maybe like one set needs to agree, and then the other set also needs to agree, and maybe that mitigates risk somehow. But I think that still kind of runs into the same issue of like if everything's centralized, you're still screwed, right? I don't think it really fundamentally solves the problem. You could slice it up into 3 roles. Like maybe you have like 3 different stages. Like one person proposes, another person like approves, and then the final person executes, right? But does that really change anything? Like I think kind of at the end of the day, if we're using these bridges, we really need to dig deep and kind of understand, like, are these actually separate entities, or are they just like pretending or masquerading to be?
I'll add one thing, which again is more from the smart contract risk angle rather than the human engineering side, which is that client diversity matters a lot as well. We talk about it in very different contexts, like the Ethereum validator context. But in this case, if a bridge has, requires 13 out of 19 validators to agree, but all of the validators leverage ultimately like the same code or created by the same dev company, then the vulnerabilities that are introduced into one are like multiplied across all of those. And so that's incredibly important to keep in mind as well. And some of the architectures that exist right now don't actually encourage client diversity or aren't open and permissionless to allow other protocols to run some of these off-chain components and actively participate in their security layer.
That's a very interesting point. So on that, like, how does Layer 0 promote client diversity?
So it's interesting that you were talking about Chainlink and their architecture. Ours is slightly different. Layer 0 deploys endpoints on all of the chains which we support. So these are EVMs, non-EVMs, rollups, apps chains, etc. These endpoints are smart contract libraries, and these are immutable. Between the endpoints are the off-chain entities, which we call the oracles, plural, and relayers, plural. And all an oracle has to be is an entity which can retrieve and submit a block hash. And all a relayer has to be is an entity that can retrieve and submit a transaction proof. So there are 2 separate tasks that need to be put into play. The protocol determines which oracles and relayers they select. And of the oracles consortium, it could be 3 out of 5, it could be 2 out of 3 that have to form a, let's say, like a yes from the oracle side. And same with the relayer side. The protocol can run one of those components, meaning the protocol could run a relayer of the relayer consortium, and one of the oracles could be, let's say, the top 50 delegates of their protocol and provide more utility to their protocol token in this way. And the message can only pass across the protocol if both the oracles and relayers consortium form an agreement. Otherwise, if one of those consortiums disagrees, the message reverts. So this is sort of, base security layer here, and allows applications to price their security as they'd like. So if you're building a game and you're transacting 5-cent NFTs between chains, it might make sense to use, the custom Chainlink DON that was built for Layer 0 and the Layer 0 Labs relayer. But if you're Circle and you are moving USDC between chains as an omni-chain token, you probably want to price your security a lot higher. You might want to run one of those components yourself. You may pull in a highly reputable entity to run one of these relayers, and you can add in more as you'd like. If you're a decentralized protocol, then your governance can vote to add more or swap in and out oracles or relayers based off their liveness and their performance. That is how we encourage client diversity. Each of these entities are built by different dev companies, and it's in the hands of the application to price. Therefore, Layer 0 is the line of security there.
Makes sense. That's super nice. So security with bridges, with everything, it's a continuous process. So we have discussed a lot about things you can do really before launching the bridges or at any moment of time. But there is one aspect, which is monitoring and incident response, which you gotta pay attention to once you have launched the code, once everything is live. So on that aspect, an open question to everyone. First of all, maybe let's start with the good things this time. So any bridge you are seeing right now which is doing something right, any example you can share?
I don't want to speak too much, so
any bridge that is doing monitoring or incident response right, or any protocol in general?
Yeah, so
nobody is doing it right, I guess.
Yeah, so I think maybe this circles back to the recommendation part where you asked for recommended bridges. So obviously there is a spectrum, and obviously teams with less personnel would have less capacity to handle security processes and all of that. And when you have bigger teams which develop a bridge, they have much more capacity in order to initiate the right security processes, the right incident response plan, the right monitoring in place, mapping all the threats and monitoring for them. So of course there is when we I don't like this term diligencing a bridge, because eventually the UX has to be abstracted, and it really depends on what chains you want to move from. But for instance, if you take big companies running bridges, normally what you see is that they're really minded about security, and then they employ things like monitoring, incident response, in mapping out invariants in order to look for those invariants in real time and so on. And from our experience with working with bridges, what we normally see when a bridge is incorporated into securing the bridge, they work with us. We map out all the known threats. For instance, just given an example, if you're running even a layer 2, which I treat layer 2 to layer 1 token bridge, if it's doing a ZK EVM or type of bridge, it's a very complex technology, for just a few auditors to just audit and conclude a snark is okay. The arithmetics are okay, and all the circuits are just make sense. And if the bridge is that huge, it makes obviously a huge opportunity for attackers to actually research that and find a vulnerability. So, for instance, mapping all those threats as a company operating a bridge, and then monitoring for what happens if someone finds a vulnerability in the snark. Like without knowing what the vulnerability is, like maybe we can monitor when the snark validation breaks. So what we see as a company is that like normally when you mature and you grow, like those big companies like Polygon and others, when they launch new stuff like that, normally they also are really minded for monitoring, mapping all those known threats, monitoring for the unknown threats, and so on. So I think this is kind of a quick way to do a diligence of who is like have the capacity and security personnel to actually run an incident response plan and like security, like the right security processes in order to protect the bridge.
Yeah, that's good. Can I?
Yeah.
Yeah, I've always been like a little skeptical of monitoring. I mean, I think like, do you really care if, like, do you really want people to tell you that you've lost $5 million, or would you like rather not lose $5 million in the first place, right? Like, I think monitoring is kind of funny because it's like, oh, after we got hacked, okay, now we know that we lost $100 million. But it's like, okay, it's kind of late now, right? You know, I think bridges. I think there are like meaningful mitigations bridges can do. I just don't know if they're on the monitoring side. Like for example, one thing that I think Layer 0 does and a couple other bridges is having some sort of rate limit on the total amount of withdrawals. I think this is pretty intuitive, right? Like if we have some sort of random chain, it probably doesn't need to be sending $50 million back to Ethereum mainnet, right? Like where does that money come from? I think there's a lot of sane mitigations in terms of rate limits that probably make more sense, that could help mitigate, even in the case of say a relay compromise or like some sort of endpoint compromise on the other chain, at least you can limit the amount of damages. And I feel like that goes a really long way, as opposed to having some sort of monitoring setup that's like, okay, we lost $30 million, but it's like kind of late now.
Yeah, maybe a small comment from my end on the monitoring side. So, like there is a spectrum for monitoring. Like so, from our perspective, like when we monitor stuff, like our goal is eventually to detect the threat like beforehand. So in the case of bridges, like many times, like it really depends on the bridge. Like many times, especially for bridges, because there is the off-chain component, and sometimes there is a delay before anything happens, and also, like there is sometimes a natural delay for attackers when they deploy just the attack code, the contract, which gives like opportunity for companies like us to detect the threat upfront. But again, in bridges, like you have much more opportunity to also detect detect threats before they impact any digital assets. Like for example, if you monitor like for a bridge which does like a multi-sig kind of signing, so many times, like before withdrawal is even possible, like you could monitor like whenever the multi-sig has concluded that some withdrawal is possible. For example, there are many examples of multi-sig bridges which like do that, and if you had monitored like in real time the fact that something bad is going to happen before like the malicious withdrawal happens, then you're able, given like the right processes, because it's inseparable from monitoring, you're able to mitigate the threat. So monitoring can take like we're aiming for pre-hack.
Oh yeah, I think we're talking about similar things then. I guess you're talking about like monitoring as the transaction goes through the bridge and not like after it like lands on the other side.
Yeah, on that, like I can. Yeah, go ahead.
So I think probably bridges that are trusted probably need a lot of monitoring, because as we've basically been discussing most of this conversation is how do you make a trusted bridge essentially as decentralized and least trusted as possible whilst it's still trusted. But when it comes to something like an optimistic bridge, you still need quite a lot of monitoring, specifically to monitor, are people submitting fraud proofs? And because if a malicious event is missed, your window is finite.
One thing that we had observed and learned from with a lot of these bridge hacks was issues with accounting, for example, that show up in how these smart contracts are written. And so we created something called pre-crime, and we actually don't talk about it very much, but we'll do moving forward since we are working to scale this so that it protects all applications that have integrated layer 0. Pre-crime is a proprietary security module which forks every message that goes across the protocol and tests it locally against a set of invariants determined by the application. Only then do the messages get pushed back and run across mainnet. And it's called pre-crime to stop a hack before it happens. And so that invariant could be like accounting around avoiding the double spend problem. It could also be, if you're an NFT project and integrating layer 0 to enable seamless movement, native movement between chains. It could just be like whitelisted addresses, whatever you'd like for that invariant to be as the application developer. And this is what has protected Stargate since its launch more than a year and a half ago through its peak of 4.4 billion in TVL, the whole team just watching every single black hat attacker try and break the protocol. This is what protected it. And then in addition to Robert's point about rate limiting, which we have introduced, when we launched the Aptos bridge for the new non-EVM layer 1 last fall, we decided to adjust the block confirmations and set them to be incredibly high. It was, arduous. It took about 3 days for transfers out of Aptos. However, that was a security measure we took because it was a new chain and there are a lot of unknowns. Over time, we've been reducing those block confirmations, but one thing that layer 0 enables and we built into the protocol was ownership of the application developer to determine those block confirmations. And so if you're trying to avoid like reorgs involved with a particular chain, you might want to set those higher. If, again, pricing your risk. If you're just transacting 5-cent NFTs, maybe you set all of the block confirmations really low, and that's okay.
Yeah, 100% makes sense. Monitoring is like a lot more, obviously, than just detecting a hack once it has happened. So, yeah, obviously, like once the hack has already happened, then detecting it is not as important, at least for the protocol. But monitoring is a lot more than that, especially for bridges where there is a time delay between the transaction initiation and settlement. You can intercept a malicious transaction in between that time. So for optimistic rollups, as mentioned, like you need fraud proofs. So someone needs to be generating everything happening on the chain to generate these fraud proofs. For like other bridges, you can monitor smart contracts being deployed that might try to create malicious messages to your protocols and things like that. So there are a bunch of monitoring tooling that is definitely important. And even like oftentimes you can white hack during a hack. A good example would be Nomad Bridge. So Nomad Bridge was like slowly hacked over hours by many parties. It was kickstarted by, I believe it was a black hat. I don't remember if they returned the funds or not. And then like a bunch of white hats kicked in and started rescuing what they can. So that only like if they had even better, they had some monitoring, and that's why like all of this, they could respond in time. But if you work on monitoring more, maybe you have playbooks, define some automation around this that like kicks off automatically when something is detected, then maybe you can act faster, save more funds, and so on. So it is important. And this reminds me of a interesting war room story I had. And I think let's start discussing some war room stories, ideally around bridges, but whatever comes to your mind. I'll start with this one, which is related to monitoring and why it's important. So in this space, lots of people, not just protocols, are monitoring the chain for malicious transactions. And I guess we have only 1 minute, so I'll round off this story really quick. But there is one group which monitors for hacks so that they can short the token and make money. So what they do is they, I won't go into specifics of how they do it because like that's also a secret sauce for them, let's say. But if they detect anything that is about to go wrong, they will short the token. If something doesn't go wrong and now their short position is whatever, they will reach out the protocol, tell them, hey, like we detected this in your protocol, have a look. So it's a very interesting ideology, which is like sustainable. So I was in one war room where they detected something and then nothing happened. So they reached out to the protocol within like 10 minutes that, hey, we detected this, but your protocol hasn't been drained yet. The protocol without understanding what this is, immediately paused the protocol as their response, which is good. At this point, they only had a contract address, which was private source code. And all they knew was this contract has been deployed by a malicious address, a known malicious address, and it interacts with their contracts. So at this point, they don't know if it's a hack or they are just using the protocol, but they paused it. And then we spent next 1 hour decompiling the contract, understanding what it does, and it turns out it indeed was an active attack that they were going to pull off. Nobody knows why the attacker didn't execute the transaction. Maybe they were testing it. Maybe gas was too high. That was expensive times or whatever. But they deployed the exact, the attack contract, but didn't execute it yet. And within 1 hour, this team, although detected by someone else, but was able to pause the protocol, fix the vulnerability, and save all of the TVL they had. So monitoring can be important, just because in this space, although everything can be instantaneous, it usually isn't. People do things one by one. It's still being run by immature kids. Most of the hacks are being done by immature people, if I'm being honest. So you still have time to respond, and that's why it's important. Before we wind up, so I'll leave it open for final comments if anyone has really short, 30 seconds maybe.
The modern monitoring, I think it is important to have a mechanism that can minimize the damage even if your smart contract has an exploit or hacked, because yeah.
Okay, makes sense.
I think as a community, we really should focus on building trustless bridges, not making trusted bridges safer.
Okay, that's solid. So we have next panel on auditing. I'll warm up the audience with an auditing question, fun question here. So everyone, we started by asking everyone, name your favorite bridge and least favorite bridge. Let's do it for auditors. Name your favorite auditor and least favorite auditor. Go ahead.
I can give a shout out to some auditors, and I'm super lucky to have personal relationships with a bunch of them. One sitting next to me, which is Robert from OtterSec. We're also a huge fan of the Zelic team, the Zokyo team, Paladin team, and always looking for more. One thing I'm super proud of at Layer 0 is we have spent more money on audits across every single protocol in crypto. So we're in tens of millions at this point, and we are happy to keep spending money on audits. Every piece of code we push is immutable, and even if it's 4 lines of code, we will get multiple audits. So if you're an auditor and you also want to be my friend, come find me.
Anyone else wants to name anyone? I guess not. Then we'll round it up here. Thanks everyone for being on the panel, and thanks for the audience.
Thank you.
Hi, everybody. I think this is the panel that you all have been waiting for. So get ready. Stay calm. It'll be fun. I think there won't be blood. Let's see. The panel is actually, I think it's very different. It's a bit different than last year. I think we want to make it more like not just audit, but more community. Versus audit. And we have Rajiv here from Secure Realm, who has actually inspired this panel and will be moderating it.
We share this one. Sure.
All right. Yeah, I think they're all. Thank you, Muli. And thanks to Mudit for the segue and the spicy appetizer. So I'm Rajiv, the founder of Securium. And just to set the context, we'll assume that most of you are familiar with what audits are. But the topic of this panel is the flavors of audits, right? So audits have been around for a while, and recently we have seen different flavors in terms of who performs the audits, many other attributes as well. So we're going to focus on sort of a high-level question of conventional audits and the community-oriented ones, or the competitive ones, right? So, but before we start off, we have a fantastic set of panelists here. Would like to request all of them to introduce themselves and their projects before we kick this off.
My name is Hari. I'm one of the co-founders of Spearbit. Previously, I was working at the Ethereum Foundation, building the Solidity language and the compiler. Yeah, that's it.
Gonzalo, co-founder of Consensus Diligence. Been operating for almost 7 years now. Mostly services, off-chain, on-chain. A lot of tools as well, fuzzers, symbolic execution engines, so on and so forth. And also we have a stealth thing, well, kind of stealth, that it's called Creed, that is coming out. So that's cool.
Hey everyone, my name is Mehdi, co-founder and director of Sigma Prime. We are a blockchain security firm, been around for about 8 years, doing a lot of smart contract security reviews, but a bunch of L1, L2s, and bridges and whatnot. We're also the founders and maintainers of Lighthouse, the Rust implementation of the Ethereum consensus layer, currently responsible for about 35% of the user market share.
Hey guys, I'm Jack Sanford, one of the co-founders of Sherlock, and Sherlock has been around for about 2.5 years. We are a smart contract coverage protocol as well as an auditor.
Hey everyone, I'm Jocelyn Feiss. I'm the engineering director of the blockchain team at 12bits.
Thank you. We got a poverty of mics over here. No, it's okay. We're all good. We'll share. My name is Mitchell Amador. I'm the founder and CEO of Immunify. Immunify is the biggest bug bounty platform in crypto. So, you know, these DeFi and on-chain exploits are our bread and butter. Everything we do is about making projects safe post-deployment, and that ends up being a lot of things, but bug bounties is always the name of the game.
Hey there, Sok from Code Arena. I'm one of the founders and first handful of people in the Discord on day one. The Code Arena is a creator of the competitive audit, and we've just really been focused on creating as many opportunities for people in the field to level up and to create as many opportunities for protocols to achieve a greater level of security at a more efficient rate than a traditional audit.
Awesome. So let's maybe level set a bit more. So audits, we just use the term. We may want to use reviews or assessments, but I think we're just stuck with it, at least for this panel and maybe a few more years. But what do audits mean to each of you, right? For each of your projects, your missions? Because the way we see it, we may think of audits as something, the protocols may have different expectations, the users may have a totally different, zero bug expectations. So what do audits mean to each one of you? And also, what's conventional or unconventional about each of your approaches? I think that'll be a good start. And we can go around for this question because each of you is very unique. So maybe start with, you want to start on that side?
The poor side of mics.
Uh-oh. Well, I mean, the reality is that, I think actually there was a talk that Mitchell gave at TrustX last year and was talking about the fact that bug bounties are really the absolute last line of defense when it comes to security. And the idea that that in fact it is an indicator of the immaturity of the space in general that we have so much that's secured by bug bounties. And I think in reality, I would actually extend that a little farther and say that an audit actually should be the last line of defense. That a bug bounty is a break glass in case of emergency. You know, at the point that kind of the going rate is maybe 10% of user funds, you're maybe overspending at that point in terms of what you might want to spend. And so an audit is intending to prevent at the last bit as many bugs as you can from reaching production. So that's the main thing that I see. But it's actually an assessment of what you've been doing from day one when it comes to security.
Okay, so I mean, you're totally right. Just to call out that one particular point about the whole move. This is move left, right? In traditional security, right? Always move farther up the stack earlier in the process, more and more preventative. But if you feel that way about bug bounties, you should see what people say about their auditor spend. Of course, I think we've all spent a lot. Certainly, I have, and we don't really have a choice about that matter. The reality of the fact is, it's impossible to create secure software, and we've decided to put the most valuable things in the world in a extremely kind of finicky, young, immature technology stack. We're like, yeah, this is a good plan. And by the way, let's move the entirety of the world economy on here while we're at it. So under these conditions, where we have the highest possible security needs, and we just don't have enough time, we don't have enough people, we don't have enough anything, like, what is an audit? An audit is just another type of code review, right? We have our internal tooling inside, which is ideally, in an ideal world, we would have tools, or we would hire people, and they would just find everything, and life would be good. And then we would never need any external code review, but that doesn't work, right, for reasons that we all understand. And so then we go to the layer of external code review, and that begins the process. And usually, typically, best practice teams will start with a traditional audit, right, which you're going to have highly expert people from highly vetted firms who've been doing this for you, just phenomenal engineers who will help you not just look for vulnerabilities in your code, but say, hey, is the architecture here wise? Are you're getting boxed into such and such a choices? Have you, foreseen the second, third, fourth order consequences of that? And from there, right, then we have the remainder of the flow, right, the new types of audits, which I think are very, very exciting, and then bug bounties, which is really just another type of code review, right? You could think of it as another type of audit, but really it's the action of let us review this code and the entirety of this infrastructure with the scope widening and widening and widening as you get more and more closer to production. Let us review this and see if we can find anything that allows us to break the assumptions in such a way that causes irreparable harm to the mission of that protocol, which in our case, of course, is theft of money or damage of valuable assets.
Yeah, so if we think about what are our goals, what are the things we are trying to achieve, with this security review or audits or this type of things. From a traditional review, for better lack of term, what we are really trying to achieve is that we are trying to help developers to understand where they are at, what are the risks they have, what are the areas they should invest in terms of security. And to achieve this goal, we have a couple of things to do. First one is going to be, to look for vulnerabilities. That's the most obvious one. But a lot of the work that we actually do during security review is to advise developers, to tell them, look, here you have a systematic risk in the way you are designing your component. Maybe try to refactor it in this way. Maybe create like a single component for this multi-component step. Maybe improve your documentation on this specific aspect. So a lot of the work we do is really about helping and kind of filling the gap with respect to the code maturity of the client and with respect to the risk they might have.
That's interesting. I would actually disagree with that. I think there's only one thing you really care about in an audit, and that is finding problems that will cause losses for users. Like making sure whatever this protocol is supposed to do, it does it well, and it doesn't cause massive amounts or even a material amount of fund loss for users. And that should be the main goal. And gas optimizations, informational, findings, that kind of stuff is great, but it's not core to what an audit is. I even think a fixed review, Sherlock includes a fixed review after every audit we do, but I don't think that's core either. The core thing is, did you find as many of the problems that could cause losses for users in that code base at the commit you were given as possible. And to answer the second question, what is the conventional or unconventional approach of Sherlock? Sherlock is kind of the best of both worlds, so we have a foot in both worlds. We have the conventional auditing approach where we reserve auditors, pay them a fixed amount of money to show up and do an audit, and we also include an audit contest component. And yeah, I mean, in terms of the title of this panel, conventional versus community, which one is better? Sherlock thinks they're both absolutely essential to conducting a good audit, and you need both of them. And Sherlock is the only one that actually has both of them. And part of my talk at 5:20 later today, if anyone is interested, is going through the last year of seeing which of those two parties found more vulnerabilities over the last year in Sherlock audits, like who has been carrying their weight, I guess, between the conventional and community side. So stay tuned for that.
I'd be very interested to come to your talk because I wonder how you're able to qualify the number of critical findings, high severity findings that a firm like my firm or Trail of Bits firm or Gonzalo's firm has been doing over the past year, just because it's very difficult for us to publish some of our work, right? So it's yeah, I'm just curious about your data collection method, but I'll rock up in a few hours.
Good. Looks like we are warming up.
I'll see you in the audience.
Getting a bit cold as well, so this is good.
Yeah, sorry, just circling back to everything that was said. I don't disagree with anything that you guys have said. I think everything makes sense. The way we tackle security audits at SIGP is the traditional way. They're time-boxed security assessments. You got to think as well that not everyone's willing to spend, hundreds of thousands of dollars on a security review, right? And in some cases, people come to us and they're like, hey, we're cash-strapped, but could you work with us? It's difficult to say no, right? Especially if the project is interesting, the team is, keen to work with you. So in those cases, we may allocate a couple of weeks, but everyone knows that's nowhere near enough to dive into everything, to dive into every single component that makes up the platform. So I'd be hesitant to say, we shouldn't be working with these people. We should only be conducting assessments when they're 100% thorough. Because circling back to what was said earlier, I believe that it's just important to give feedback whenever you're ready for feedback, right? You may be conducting a bunch of experiments, you may be trying out a whole bunch of features, you don't necessarily know what's going to land in production, but at some point you decide to take a snapshot of your development and reach out to one of us. And that's absolutely fine, right? But this is, again, the disconnection in expectations, right? What do users expect from audit reports? What do protocol teams expect from audit reports? And this is a fight I've been fighting for way too long now, where, degens out there would take this guy's reports and say, yep, cool, sounds good to me. I've only seen, a couple of lows, a couple of informationals. There you go. I can dump a whole bunch of money into this stuff, right? Well, have you even looked at the executive summary? Have you even looked at what, Trail of Bits or Sigma Prime or any other firm has actually looked at? So it's a bit frustrating sometimes, and some of that narrative has been relayed by some people here, and it's every time I see that on Twitter, I'm just it's not helping. It's not helping. But all right, I'll stop bitching for a bit.
I'll answer the question. What is an audit for me? It's a checklist. So I think this part, like we've talked about it so many times, we don't do audits. That's the first thing. Maybe DeFi safety does audits. We don't. We never did. Second, I don't think bug bounties are audits at all. And I'm glad that we're calling it in the panel conventional versus community audits. And nomenclature kind of doesn't matter because I can call a table whatever I want, right? Like if I have a name for it and we all agree that that's what we call it, that's fine. But they are not audits or security reviews. They are a completely different thing. I'm not saying that they don't have a place in the stack of security procedures that you should do to your project, but they're not audits. The same way that
Community audits are not audits. So Code Arena is a bunch of people doing solo reviews that are then aggregated, which is not the same thing as a team doing a security review. So what we call them from now on kind of matters. I think we should all have a group discussion the same way that we had for not calling these things audits and they are security reviews. We should probably have the same conversation going forward for all of these things. And but I guess Sherlock's still winning because both in different places.
We're winning?
Yeah.
Thank you.
Yeah, for Spearbit, our approach has been to combine the best elements from all of these people. We bring some of the best independent talent to then collaborate on security reviews. We try to incentivize them, and we have more of a marketplace model where we just take a 20% fee on top, and some of the best researchers enjoy working with us because we are more fairer. We try to our collaborative approach ends up finding deep issues, even in outer scope dependencies. Yeah, and I do disagree with one thing by the Sherlock, which is I think while I agree that the end goal is to minimize the number of user losses, you can't really get there without focusing early on core architectural issues. We do also focus on that. I think the safest protocols are the ones that are very well designed. So yeah, we need to cover that as well.
Yeah, looks like others want to respond.
I want to go back to what my colleague from Sherlock was saying, because I kind of disagree with the statement that what only matters are the bugs. Finding the bug is obviously really, really important. It's, you want to prevent loss of funds, but that's not sufficient. What's going to happen, in practice, is that developers are going to continue to develop the software. They're going to make a new version. They're going to iterate over it. And if you want to kind of, increase your security, if you want to be in a better posture, you need to understand how to build better software. And to understand how to build better software, it's not just by getting a list of findings, because a list of findings is not going to be that informative in the long term. That's why having all this information, having all this feedback about design, about component, about structure, test, is really important in the long term. Finding the bugs are only going to help you in the short term, but not in the next in the iteration of your protocol, not in the long-term thinking. And if we want to kind of win as a security community, it's really important to focus on all this aspect.
Can I have a quick... Yeah, so I actually, still disagree. I think that, like Sok was saying, we want to make audits the last line of defense. The audit is really expensive, and it's something that you're trying to do at a point in time so that you can get your code safely to mainnet. And helping a protocol team during its development, helping with the architectural design, that kind of thing, that's really great. That's super important, but that's called consulting, in my opinion. And the audit is a specific thing to find the problems in the code base with the intention of having that code base go to mainnet probably soon.
Can I ask just one question, Reggie? Because I really don't know, Jack. How does Sherlock work? Because I really don't know. This is a genuine question. Do you, if I'm a customer and I come to you, what's the order of things that happens? What's the user flow? Do you do the security review first and then you put up my code for a code contest, all inside Sherlock? Are they different services? Do you do them always both for a certain client?
Yeah, so the right time to come to Sherlock, and that we kind of recommend, is having it be your last audit. And that's because we find, some other audits are more on the consulting side or whatever, and maybe the code base isn't quite ready, and Sherlock is really the most intense audit I think you can get, and the amount of findings that come out of it are sometimes unmanageable for protocol teams. So we think of the audit as that last piece right before you're going to mainnet, and a lot of protocol teams don't actually have a good experience because they think that it's maybe something else, and they aren't ready for all of the findings that come out of it. They weren't ready for the final exam, basically. And so Sherlock kind of thinks of itself as the final exam.
before you go to mainnet, before we add the smart contract coverage on mainnet. And to answer your question, the contest piece happens alongside the kind of reserved auditor piece. So those happen at the exact same time. And the reserved, you could call them more conventional auditing model with those reserved auditors are actually competing against the contest participants. So both sides are kind of extra incentivized in that sense.
And it always happens. You don't sell the services separately.
We have not sold the services separately as far as I know.
Yeah. So I think this is great. I think we may be too deep into the space, so we're probably making assumptions that people know how Sherlock works or how C4 works. So that was sort of the point of the first question. Maybe starting with SOC, can you take maybe 30 seconds and explain how C4 works? It used to work in a certain way maybe 2 years ago, but it has evolved, right? There are a whole bunch of services that you guys offer, and same with Sherlock. And we do, by the way, if you didn't realize, so we do have the convention, quote unquote, the conventional bucket would be TrailofBits, Sigma Prime, and Diligence, because they have been around for a while doing different things. And the community one is, again, sort of a loaded term. There is a contest-based, which is Sherlock and Code Arena, but then we have Spearbit, which is not entirely, well,
it's a hybrid.
It's a hybrid model. So you guys understand this, but maybe not all of us. Can you take 30 seconds to explain that, please?
Sure. So Code Arena is a competitive audit, which means that people show up in order to review as much, to review the code in the time that they're provided and find as many bugs as they can. The compensation for those bugs works on a model that was designed by Scott Lewis and Zach Cole. And the model is essentially that the more rare the bug is, the more severe the bug is, the higher the payout. And the bugs are judged by independent experts. Many of these originally were people who we sourced throughout the community. Nick Johnson was our second judge after Zach Cole, and had a number of folks just kind of come through on recommendation. But today, most of those are people who have competed in Code Arena and have moved their way into the ranks of being a judge. The thing that we have added over time is in the course of Code Arena, one of the things that I think is pretty essential as a piece that Code Arena contributes is, I think until Code Arena came around, one, there wasn't really a good way for people to identify who were good solo auditors and what the talent pool looked like in general. There were people who were out there doing solo audits, but there weren't necessarily people who could establish their talent in that same way. The other piece that I think is a key contribution is the fact that you have Code Arena has really driven down the price of well-known bugs. And we see that all the time in competition, where people who compete and have read all of the reports, because one of the things that we also did from the very beginning was we put all the reports public, we put all the code public, so that people who wanted to learn could go back and compare their results with the others who they competed against. But as a result of that, people studied those, and things that 6 months ago would have been worth, $10,000 or $1,000. That there are times when those bugs are only worth $1. And the first time I saw that, I kind of freaked out about it, frankly. And I was having a conversation with Scott Lewis, and he's like, "No, that's the algorithm working. Like, we want to pay as little as we can for bugs that are well known. When people have not added any additional marginal value in finding those bugs, that's a success. It means that we've actually educated more of the market on how to identify those bugs. And then we're putting more energy into finding the harder, more interesting ones." And I think that is something that Code Arena in general has really helped to pioneer for the space, just in that openness and that process of learning. And that's something that we're really focused on. The other piece that is a part of the process that exists today as a result of that is we started doing bot races where people who are building automated tools in order to identify findings are able to compete prior to the audit begins. prior to the beginning of the audit. So that way, we sort of get those things out of the way, and we have some really great bots that have actually started to identify more and more findings in the course of the in the course of competing. But the nice thing about that is then every single auditor who's competing gets access to that report in advance of competing, and those are all identified as known issues, right? So we're now not seeing. We don't have to have everybody submit the same bug, 100 times in order to reduce the value of it to its appropriate amount, because many times if they're that findable, they're usually more identifiable by bot. So, a big part of what we're trying to do is really identify talent and help talent to show up in all the various areas. For that same reason, we recently added analyses, which are intended to bring out the expertise of individuals who have more of a consultative view and are able to be, when booking as solo, are able to be taken in by protocols as a security advisor. And that's a big part of where we see and why we are investing in really the profiles that we've built recently on the site and enabling people to book solo engagements through the site, because we do want to get people earlier in the process from an expertise perspective. So there's a lot of elements to it, but there's some.
Anyone else wants to add to that?
Yeah, I guess I'll go next since our approach is similar to Code Arena. So the way to think about a audit contest is a protocol team has some code and they say, here's $100,000. And you can think of it sort of like anyone in the world can come get this $100,000 by finding bugs in a code base. And of course, multiple people will show up to try to do that. So then you want to split that $100,000 between different people. And the way it gets split is by who finds the most severe bugs, who finds the most bugs, and how many other people found those bugs, how rare they are. And that's pretty much, there's an algorithm that kind of helps determine who gets paid what out of basically anyone in the world who can come and try to find those bugs. And, we see, Code Arena sees 200, 300, 400 people compete in contests from all around the world. And yeah, you just find a lot of crazy things when that happens. You find a lot of bugs that might otherwise get missed when that happens. And Sherlock also layers on a more traditional approach as well, where we reserve 1 or 2 top auditors who we know are very good and have proved themselves over time. They're at the top of Sherlock's leaderboard, and we make sure that they're going to show up and also participate in that contest. And if they don't do well, they'll fall down the leaderboard, someone will take their spot. So they're highly incentivized, but we just want to make sure that there's a high level of quality in every audit, like a default level of quality in every audit. So we kind of combine that traditional piece as well. They help with the fix review, some of these other things that you might expect in an audit. And that's how Sherlock works, just with those two. So we have a foot kind of in both worlds on this panel.
Hari, do you want to add?
Yeah, sure. Our approach is like 3 different things. One, we are like highly collaborative. And the second one is we want to bring really the best talent to look into your code base. And the third thing, of course, is we believe in like multiple eyes being better. We want like 4 to 5 people looking into the same code multiple times so that we can be sure that a lot of the vulnerabilities are caught.
Do you behave as a marketplace, Hari? Can I choose who I get?
Yeah, you can. Yeah.
Okay.
I guess for the 3 traditional players out there, correct me if I'm wrong, feel free to chime in if I'm not representing our side of the industry well, but you reach out to Trail of Bits, Consensus Diligence, Sigma Prime, and you kick off a sales process, right? If you reach out to Sigma Prime, you get to talk to me usually, and I go through a scoping exercise, right? You share with me your code base, and I start going through every single contract, in the case of Solidity, EVM stuff, that you would like to see reviewed. And we essentially estimate how much time it would take for a team to perform a review to provide a decent level of security assurance. So for SIGP, we always include testing in our approach. That's perhaps it might be a little differentiator between our other friends, but so for each component, you'll have person days for manual review and person days for testing. And testing can be done in different frameworks, Foundry, Forge, or Brownie, or we don't really dabble in JavaScript, but yeah. And then we give you a proposal, take a look at that proposal, give you a timeline, obviously, the earliest we can get the job done. And I guess an interesting part of the job is for us to be able to spot within our team the right members for that particular target. It's very important, right? I've got team members who have reviewed, perhaps as of today, 4 liquid staking derivatives, right? They're across, all of them, most of them, if not all of them. So when I get a request from a client who's building a liquid staking protocol, I'm going to obviously do my best to assign that protocol to the testers that have that level of experience. We can circle back later on how we train people, how we make sure that the knowledge is spread across the team. But yeah, that's essentially it. We are a services company, so if you're happy with that, we then get started and kick things off and produce a report and a test suite that you essentially is yours. You can do with it as you see fit.
I agree with everything. I would just want to take it back to the stack. Just if we're trying to get people to understand, I'd say that and this is my personal preference. I heard different things today, but I think that you have the manual review on top, then you have the code contest below and the bug bounty. Like the only undisputed 100% market share that we have here today is Mitchell. I basically refer everybody to Immunify, right? Like bug bounties are completely undisputed. Then we might have, I don't know, like a choice between maybe Sherlock and in the Code Arena, or maybe not, because Sherlock is integrated, so it's monolithic, and then you have us. And so if any of these entry points, I guess like the 5 entry points over here, because like Spearbit is also an entry point, is probably the first people that you would contact, right? I wouldn't go talk to Mitchell first. That's probably the end game.
So let's put Mitchell on the spot. Mitchell, if you had a protocol on your bug bounty, which of these vendors would you recommend?
Wow, I'm in a rough spot today.
Well, it could be all 6.
So actually, this is a question that we have thought a lot about. We get recommendations, and I was, pondering to myself as I was listening, like, should I give the audience this particular model that we've developed for looking at this situation, which is, while these things all seem like, oh, here are audits, and there's all these different types and flavors to choose from. Who's the best? The way we look at it is that there are very specific things to prioritize at different parts of the stack. So to be quite frank, I would avoid, if I was, CISO or equivalent security lead at a project and they were asking me, how do we want to allocate spend here? We need to build out the ideal security setup. What are you going to do, Mitchell? Well, and they're going to say, hey, do you want to work with C4? They got like bot races and so many people. I'd be like, no, absolutely not. That's a horrible decision. Not because it's not a very useful service. In fact, it's an excellent service at a certain stage of the life cycle, but that's not my problem, right, as I finish my internal review process. So after I've made as many investments I could on the internal side, so that's hiring my security engineers, that's investing in tooling, that's documenting the hell out of our stuff, that's building, as a good secure code development process as I can, that's, threat modeling. After I've done all those investments, which are not, primarily monetary but time, then I want to bring my outputs, right, the outputs of my work to whatever degree is possible to the finest possible mind I can imagine. Okay, and it needs to be, and I need to pair that with my, my finest possible mind, and I need them both to attack what we have and see where it lands. And to be quite frank, while I am like truly the most pro crowdsourcing person here, maybe not truly, but I'm trying to be, I would absolutely go to one of the private firms first. So I would go to a Consensus Diligence, I would go to a TrailAbit, I would go to a Sigma Prime. I might also go to a Spearbit, but I think there are some questions, that I'm trying to answer about their service before I can have that conviction, right? There's something excellent about them, but it's not clear that they bring the level of comprehensive expertise that I would want at that initial engagement. Because that's where I'm having these architecture discussions, right? That's where I'm throwing them against my engineering team and saying, here's very expensive people we pay to tell you that you did everything wrong, and we're going to have to go back and fix it all. Thanks, man. It's a good thing we got this now. And I'm not really going to, I can only get that from an extremely, someone whose brand is both expertise, impartiality, and, awareness, deep expertise up and down the stack, broad. It's got to be everything. They have to have the whole world view. They got to be smarter than me. And the firms that are most likely to have that talent, quite frankly, are the traditional audit firms, because they can best allocate resources to best attract that talent and structure their whole brand, mission, and the life of their business around that. That's something that the crowdsourced businesses will never be able to do, right? Because we have to select for a different set of conditions and priors in order to build a compelling product. So I say that, right, would definitely pick one of those. Now, I don't want to name names specifically, because then the other ones will beat me up. But I want to make a note about Spearbit in that. So what's my doubt with Spearbit? Like, Spearbit has this interesting model where they have effectively been capturing the top end of the audit contest kind of population and many of the auditors. And it's great, right? They've taken kind of that model in a cost-plus fashion and just driven it as far as they can. They can pay big wages to people while giving them a lot of freedom and giving them, and by freedom I mean, they can do whatever they want. They're not necessarily on contract to go and do the most interesting work. I mean, it's a great deal. But is that, right, in my first initial engagement when I'm at this, say, architectural stage, my first security review, and hopefully the most important, are those people going to have enough sophistication? Are they going to be process-driven enough? Are they going to have discipline, right? And I need discipline really bad at this first engagement. I don't know if that's true. And that's my doubt about whether Spearbit can service that. If they do, that would be super exciting, but that's an open question. I need discipline. I need process excellence, beyond what I have. And I'm, a guy who invests in best practices on exactly that. Looking past that, now I have new needs for audits. And for context, Immunify, with any of the stuff that we do on chain, which we do, we always do multiple audits. Okay? Now my priorities are beginning to shift. So I may want to go with a younger firm that is, more of an attacker's mindset from there. I can tolerate less discipline if I know that they're really creative. And so, a great example of that is hacker-founded firms. Okay? Hacker-founded firms are crazy. And that's why they can make great attackers, but not alone, because they can't be relied upon to get broad coverage of the potential issues. Only towards the end of this stage, right? You can see I might pick from a few different options. Only towards the end of the stage am I going to look at a audit contest-like element where I'm really just throwing eyeballs, hopefully as high-skilled as possible, but I'm throwing eyeballs at my code base to see if they can find what's left. But knowing that, it's like I can't have any expectations that they're going to find everything. I can't have any expectations that they have deep expertise. It's a gig economy kind of stuff. It's open doors. And hopefully it's the best type of it, but the reality is there are limited quality controls on it. And so it's at that time that I'm like, the more eyeballs, the better. Right? And I would do, I'm very interested in that. I think it's hopefully will eventually become a normal practice in our industry to get these multiple rounds of reviews this way so that you get the benefit of top-class minds on every major deployment, and you get the benefits of, the best creativity you can muster, and you get the benefits of just lots and lots of eyeballs covering best practices. That would be phenomenal. But it's very expensive.
All right. Well,
I want to just answer the Spearbit question there. We do provide security across the entire stack, all the way from early engineering. We have a service called vCISO. You can hire one of our leading security researchers to work a couple of hours a week over your entire development cycle to have a gut check and give you advice on how to architect the protocol. In fact, many times we have completely re-architected, work with clients to completely re-architect the protocol to make it simpler and much more secure by doing this. Yeah. So if you are building protocols today, talk with us right away. We can help you build much better contracts so it can be secure by design almost.
Hey, so can we have content and case studies on that?
Sorry, can you repeat?
Can we have content and case studies on exactly that claim?
For sure.
And I would love to see that in public, right? Because there's an open question, in a lot of ways you guys are cherry picking some top class talent that could work out well this way. But discipline, there's no replacement for that? Can you guarantee that rigor? Can you guarantee that excellence, beyond just someone can sure they can find lots of vulnerabilities. I can find, lots of hackers like that would not make good auditors at all and certainly couldn't do what I'm describing, right? The skill sets are not coextensive with one another. So I would love to see case studies wide on the internet for anybody to see about how you went in and you re-architected something. That would just be marvelous.
Yeah, for sure.
And very valuable, very informative.
Yeah, I mean, we have like architecture protocols to like, just a single contracts. They were like pretty new to Solidity, and they would just, architect like contracts as if it was a Web 2 app. And this is the wrong mindset to like build things in Solidity.
Aren't you worried about the churn of talent? Like, there's people just dropping out. Have you ever wished you could hire someone?
I actually think our approach decreases churn. We talk with a lot of security researchers that work in traditional audit firms. They're pretty much burned out working, 4 weeks out of a month, 52 weeks perhaps. We only recommend people to work 2 to 3 weeks in a month. A lot of our auditors, they enjoy like researching. As an example, like I tell this, like Hiccup, he's probably sitting here. He spends like 2 weeks doing audits, and the other 2 weeks he likes to learn CK. This is something we truly encourage our auditors to work on, and we think this decreases like churn. We speak with so many people who are like completely burned out from working in a traditional firm, and we like to avoid that.
Yeah, burnout is real. Burnout is real, and it's to be taken very seriously. Yeah, we've had, obviously, occurrences of people burning out, myself included, and it's very important to keep a finger on the pulse of every single team member you have on your team. And the way we try to do it at CKP is to allocate a bit of time between each review. Obviously, every time DGens decide that it's a bull market, our inboxes explode, and some of our team members are sometimes a bit stretched. But yeah, this is a major point, and we're obviously always looking for ways to do better. And hopefully, I'm listening to my team, and they're the the best people to give me feedback on how we run things. But yeah, I just wanted to say that it's everyone's responsibility as well to keep an eye on the work-life balance. It's super important, because if we all burn out, then all of this is for nothing. So check on yourselves, check on your friends, make sure that you prioritize your well-being above anything else, because at the end of the day, that's what really matters.
So just to make sure I understand Spearbit model, when they do like research and things like that, are they paid or?
Yes.
Okay.
Our top researchers make 20K a week on base. Some projects pay even more. So they're very well compensated.
Sorry. Yeah, I don't think that's the question. The question is, when they're not doing engagements, when they're off for those 2 weeks, are they paid?
No, they're not. Yeah. But they are paid very well on the weeks they're working, so they don't have to.
I think that's an important point, because at Trade of Bits, our engineers on average are billed 50% of the time. So over a year, they are going to generate revenue for 6 months. What they do outside of that, they are going to be paid, but they are going to work on public goods, they are going to work on tools like Slither, Akina, so on, they are going to work on guidelines, they are going to work on presentation. And in addition to that, a lot of the work that they are going to do is that they are going to shadow audit. This means that they are going to participate in an audit which is outside of their area of expertise, but they are going to learn, and they are not going to be billed to the client. This gives them a huge kind of growth opportunity where, for example, you might be an expert in Solidity, you might be really, really good at Solidity, but you have no experience in Cairo, or you have no experience in West, and you want to learn by shadowing like an audit with expert in West or in Cairo or whatever, you are going to learn a lot. So it's definitely like some kind of benefit that people might not realize, but you are going to get by working on this type of company. Yeah.
Same thing at Diligence. But I have so many questions for you. And like the churn one was not exactly what you answered. So what do you do if someone doesn't pay you enough to pay the lead security auditor? Do you reject the work?
Yes.
Yeah? You just say no?
Yeah, we say no to a lot of clients. We like I said, when we see a client, we give our genuine feedback on what should be done. We tell them this is not ready. You have to re-architect the whole thing. And if they say no, we don't really work with them.
Okay. And well, you also don't care about deal flow because like you only pay people when they work. So you don't have to guarantee you don't give any guarantees to people. And when I talked about churn, I was more interested in hearing what's the bounce back rate? Like, do people keep coming to Spearbit?
Oh yeah, of course. Once they get a taste of Spearbit, there is no going back.
Good. Suck, yeah.
Well, I just wanted to jump in on something. So I'm actually wearing a shirt from him. I actually come from a traditional audit background. There's a firm that I ran with a partner who's here years ago. And working with traditional auditors, one of the things that I know is the case is, you talk about the question of discipline, you talk about the question of what it is to show up and work. And the fact is that traditional auditors working in a traditional firm, in a traditional process, have off days. And they do, honestly, because of just the nature of our capitalist society, they do push themselves well past where their ability to perform may necessarily be appropriate. So in terms of
how so?
By which I mean they get burned out.
Yeah.
Right?
Obviously, yeah. So if you're talking about burnout, yeah.
Yeah, exactly, right? So the thing that I see and absolutely love about the competitive model is the fact that there's a great quote from a guy named Peter Block, and community means always knowing that someone else is going to be there. And that's one of the things that I think is absolutely fundamental to the way that Code4Rena works, in that it's not all on those individuals. The weight on individual auditors, and I'm talking about in Web 2, when we were dealing with far less dire circumstances, the weight on those individual auditors was so significant. I know many people who burned out doing that after a few years, just in Web 2. In Web 3, it's even more intense. And frankly, most of the people that I know who work in and as auditors, work in the field and as auditors, they're conscientious people who actually care a lot about what they're doing and why. And so when I look at the question, part of the reason that I love the competitive model is that it removes the level of intensity and pressure on those individuals for things that really do fucking matter.
But let me say that
Can I quickly take back the mic for a second? So I think we have less than 10 minutes left.
Really?
Yeah, we're just getting started, but we have only 5 minutes or maybe around that left. So I think
Can we just react to what this is very important?
5 seconds.
You go
I was gonna say that I think that is a fair commentary, but I think we're thinking about consultancy groups that are huge, right? Typically that happens in EUIs, McKinsey's. We were just talking about this the other day. We work more like boutique shops, right? So there's a way bigger amount of care for the people that work in a 20 to 100 person team than there is in a huge behemoth of a company, right? And the flip side to what you were saying about the community thing, and I do agree with you. Look, the community is always there, but we are a group of vetted people. Not everybody goes into consensus diligence. We take huge pride in the people that are in there, right? Whereas Code4Rena, like Mitchell was saying, they're always there. It's just different. And I agree with you. Sometimes people's burnout.
This room is full of people who are absolutely amazing, who got their start at Code4Rena, and they're disciplined, and they're amazing, incredible auditors.
I just want to react to one thing you said. I'm a big fan of Code4Rena. The traditional side, often recommend my clients to go and run contests. One thing that people should keep in mind is that you're not hiring, when you go to Trail of Bits, Diligence, or Sigma Prime, you're not hiring a specific auditor. You're leveraging the entire team, and that's extremely important. The quality assurance that goes through those engagements is second to none. I come from the traditional web security background as well, and the level of QA that was done then was nothing compared to the stuff that we do, and I know for a fact a couple of other people here do the same. So
we have to go to the next question. I know we can keep reacting and overreacting.
I was going to fire a torpedo, but let's continue that.
So I think by now we have level set, context set, people understand the different models, all of us including. So let's sort of switch, right? If there were one thing for the conventional guys that you like about the community approaches, and vice versa, what would that be? I mean, you said you love C4.
Yeah.
Why is that?
Last year, Mitch said that last time, we were the bottleneck. The auditors were the bottleneck to go to market. Like, it was ridiculous, right? You couldn't get anything done within, it's like 6 months, 9 months. And I'm really thankful for everyone here for all the alternatives that we can provide to the community. And I think it's a great thing. You don't have to wait 6 months, 3 months to get feedback. You can get feedback within days, weeks sometimes, right? And this to me is a really, really good thing.
Yes, yeah, timeliness, pricing, there's so many things. Yeah, Jocelyn?
Yeah, I think it's a great also like learning opportunities for a lot of people that are newcomer and want to kind of try their skills. But there is a but. I do think that people that are starting in the security space and go through Code Arena, Sherlock, or other might focus on Solidity security, but might lack some awareness on the spectrum of security. And I might make a couple of friends here, but we are a security event. If you walk around like this room, you are going to see a lot of independent researchers that look at their laptop. They don't have screen protector. They look at sensitive information. There are like 600 people at this event. Most likely, you are going to have government agency, malicious actor working around. And the fact that some of the basic operational security are not followed by a lot of people at this event is kind of a signal to me that there is some lack of training in terms of security that when you are in a competitive environment, you might not get easily.
I love them for all the reasons that I wouldn't pick diligence, right? Like the same thing that is a pro is also a con in my view. Like sometimes we'll have scheduling issues. Like sometimes we won't be able to attribute the individual person that you want because like that's just not the way we work. And if that's your need, if that's your specific need, maybe you just need that one person that you really like. Maybe then you should go to Spearbed, and then you should still do Code Arena, and then you should still do bug bounties. They're completely different. So all of the things that you wouldn't use us for, that's why you should go to them.
What about the other side?
I just want to follow up to Jocelyn. I think training is very important in the space, not just for auditing firms, but across the ecosystem. In fact, Spearbed hosted the very first Foundry seminar. Shout out to Nascent and Brock for helping out with that. I think this seminar alone, 2-hour seminar, onboarded thousands of security researchers and projects building stuff. And I firmly believe today it's easier than ever to build secure contracts. In fact, it's easier to write a fuzz test in Solidity today than in any other programming languages ever. It's just a matter of adding an extra argument to your functions. It's easier to do formal verification in Solidity than in any other language today. I think the tooling is tooling keeps improving, and we believe we invest a lot in education. There's weekly talks. You can go to youtube.com/Spearbed to see what's happening. So yeah, that's it.
So Sherlock and C4, is there anything from the conventional space that you would like?
Yeah, I mean, I think on the tooling side, a lot of these firms up here have done incredible things for the entire space in an open source way, in a way that just benefits everybody. And that's actually if you look at what they've all built, it's really impressive. And I think another thing that they do well is kind of going back to Mitchell's point, I think they're really good at the consulting side. When you are maybe not ready yet for that final exam, they can help you get prepared, and they can help you, design some things and have conversations about different ways of structuring something that I think are really beneficial. And, that's not a knock. You want to have a professor or a midterm or some quizzes before you get to the final exam. And then I think, the Sherlock, maybe the Code Arena are sort of better structured to be that final exam where you have hundreds of people looking for bugs in the code. Sherlock reserves 2 top hackers in the world, basically, to look at the code alongside those other 100 people. And so I think, both have a really important place in the space if you can afford multiple audits.
Hold on. You think auditors are hackers? I don't know about that, man. Oh, the auditor hacker debate?
I don't know about that. I don't know about, I'm just saying. But do I have to answer? Because I like everybody. You know?
Go for it.
You know, so the long and short of it is, I always loved working with the auditors. First, they drove me nuts in the old days because I was like, why are we doing this way? And then I experienced some of those problems. I'm like, I'm so happy you guys are around. And then with these new crowdsourced security products, and by the way, we're really only scratching the surface. There's new techniques being developed. There's new companies in the making. There's new, like what we're starting to see is the formation of a substack, right, within that territory. Just as there was a stack within audits, depending on the type of firm and the type of value proposition they focused on, we're starting to see a substack emerge on the competitive audit side. And that's, I mean, I'm over the moon for that in terms of the value it's going to provide to customers, in terms of the value it's going to provide to users, in terms of the opportunities it's going to create for everybody here. It's just right there. But we should remember, right, we are, how do I say this in the best way? It's not enough. It doesn't matter. We are dealing with the most hostile, possible environment. I have criticisms for the approach of every single model here, some of which would be pretty biting, I think. And yet, I am so excited for them to grow and expand, and in fact, we need more of them because the dream is to put trillions of dollars through this infrastructure, and to hit those bars, you need to max out, right, the quality of security product that you deliver on every single measure. I think some people get that. The Layer Zero was describing their spend amounts, and I was like, yeah, that sounds about right. They understand. They understand the seriousness of this game. So I am incredibly excited, despite all the limitations, all the arguments, all the, friendly or unfriendly competition. I hope all these things proliferate, and we need more, right? Calling out to the audience here, if you have an idea, if you want to create something, if you want to contribute something, we do not have enough as it is. We need more innovation, we need more scale, we need more participation, and believe me, certainly at Immunify, but I also believe all my compatriots here would love to work with you in helping push these things farther along.
Fantastic. It sounds like we're just getting started, but we're out of time. So we should give at least a minute. We have a break coming up, so but maybe we can give some time for the audience. I'm sure they have a lot of burning questions.
Yeah, I have a question, might be a little bit too controversial, to Spearbit. So first is, do you have non-compete with your auditors? How you protect that people cannot go directly to your auditors? This is first. And second, how much fees do you keep to your company so that you run your operations from the, if it's a secret, please don't tell it, but it's very interesting to know.
We are extremely open, very few secrets here. We don't have any non-competes. We want to incentivize the best people to work with us, and we don't want to tie them down. That's fundamental to our business model. And our fees is one of the lowest here. We just charge 20%. The rest of it goes to the auditors. And that's how we incentivize some of the best people to come work for us.
Do we have time for one more? No? Okay. Yes? Just a quick question and maybe a quicker response.
Okay, then the quick one is going to be, if you don't have non-competes, do you have NDAs?
Sorry, could you? Yeah, with the clients and the auditors.
But not with the auditors?
Yeah, both of them. We do have NDAs, yeah.
All right, thank you. So you'll find all these people for the rest of the evening, hopefully. So please feel free. So we now have a 15-minute coffee break, but please be back after that. We have a whole set of focus talks.
Hey everyone, welcome back. We are about to get started with an interesting set of focus talks. First up, we have Ren Cryptofish from Electric Capital. He's going to talk about state of audits.
Hi, I'm Ren. I'm an engineer at Electric Capital, and today I'll be walking through the state of audits. So smart contracts are unique in the sense that it's kind of one of the first cases where we have all of the production code predominantly open source and transparent and running on chain. So what you get is this massive graph of cross-contract dependencies and rich data that is really valuable for both users and security researchers. However, one of the difficulties is publicly linking the contracts with the audit histories, which actually we believe will make protocols safer to use and easier for security researchers to dig into potential cross-contract impacts. But today there's a problem with the audit space because there's a large gap between audits and deployed contracts. Because in the workflow of engineers and smart contract developers today, audits happen pre-deployment. But most of the users, what they actually care about is the contract that's on chain. And linking the gap between the deployed contracts and the audit reports that are done pre-deployment is extremely expensive. And we actually find that a lot of security researchers, they spend the majority of their time reconciling commits with deployments instead of looking for bugs. So as a result, we went out and we collected pretty much every audit report on Ethereum since 2018 in Ethereum DeFi, and we open sourced this in the first version of the crypto audits mapping. We collected audit reports of a representative sample of Ethereum DeFi representing greater than 92% of Ethereum TVL since 2018. But just collecting these audit reports is very challenging. There isn't a very clean or easy process to do so because if you start off at DeFi Llama, what ends up happening is you end up going to the protocol website. Sometimes you go back to the auditor website, but eventually around 71% of these audit reports end up living on GitHub. But these audit reports, most of these audit reports today are in an unstructured format. They're predominantly PDFs, which means parsing them and extracting information, valuable information from these audit reports is actually quite costly. So we tried out so we built embeddings across these PDFs using GPT-4, and we subsequently asked a series of classification type questions, such as what is the name of the auditor? Can you give me the critical risk findings? But more importantly for us, we were really looking to link the audit reports with the contracts that are deployed on-chain, and more importantly, the repositories in themselves. One of the interesting findings that we found, which should be pretty common sense, is that the larger the TVL of the protocol, the more audits these protocols tend to get, with protocols larger than 1.1 billion in TVL averaging around 10.6 audits with a median of around 4 audits. So protocols in the space are using audits, but we think that there is still this gap between the audit reports in themselves, the GitHub repositories, and the actual deployed contracts. Luckily, most audit reports have references to a Git repo or a commit hash, so that solves the first link. But it gets a little bit messier when you actually try to, as a user of DeFi protocols, to link audit reports with the actual deployed contracts, because one thing that tends to happen is you tend to get a lot of audit drift between the time of the audit and the code that's actually deployed, with less than 2% of audit reports actually referencing the deployment addresses. And that's really concerning from a user perspective. And it really highlights this large gap in the current workflow between audits happening pre-deployment, but most of the users only really caring about what's actually deployed on-chain, because that's what's actually custodying the value. And as a result, we kind of see that most users instead of referencing audit reports or really reading the audit reports in themselves, they end up falling back to a measure of lindiness of a protocol to determine if it's secure and whether if it's secure enough for them to put their money into. So a user might look at a chart like a TVL chart like Lido and say, okay, this is a protocol that's been around for 2.5 years. It's custodying $15 billion. If I'm putting in 10 million, 25 million, probably okay, because I'm assuming that everyone else has done their homework. And this is actually the thought process that goes through a lot of the users in the DeFi side, because it's so expensive and difficult to make the tie between the audit report and the actual code that's deployed on-chain. We can view smart contracts as custodians of assets and live bug bounties. Smart contracts either are directly custodying assets, for example, an LP token, a lending protocol, a yield management protocol, or they're indirectly custodying assets through wallet approvals. And because these contracts that custody assets are a massive bug bounty, the longer the implementation of these smart contracts is live for, the more lindy they become. But the most important thing is that when we're trying to come up with a metric that defines how lindy a certain protocol is, it's important that we reset that lindy metric whenever the protocol upgrades its smart contracts. And they actually do quite a lot. So here's a simple example of a protocol that launches at time step 0, gains some TVL, kind of flatlines, but issues 2 upgrades. From a traditional user's perspective, they'll look at that TVL line on the left, and they'll think, okay, this protocol has been around for a while, like they're gaining TVL, but the problem is that with the upgrades, the lindiness of the protocol actually resets to 0. So let's get into, I guess, a bit of a spicy territory. Let's walk through an example of a DeFi lending protocol. Most users will look at a chart like this. Things seem pretty good. This protocol is custodying $100 to $200 million in assets. That kind of equates to a bug bounty of $100 to $200 million that's been live for a year. And it looks pretty good. But when we actually dig into the code, so here I'm using codeslaw.app, I can dig in, find the smart contract, and I realize that it actually implements proxy logic. That's actually not standard. I decode the relevant storage variables from the contract, and I pull the history. So for this, I'm using tokenflow.live, which is an EVM data provider. And what we see is that this protocol actually has quite a lot of updates. At the top of the table, you can see the initial deployment as the storage in the contract is being set from 0 to the initial logic. But then subsequently, you get a lot of module and proxy upgrades, because protocols do upgrade quite a lot, especially if they're very early stage. And if we overlay the upgrades with the TVL, we can start to see the issue of just relying on the TVL line as lindiness. So you can see that near December of last year, there was an upgrade that subsequently led to the exploit. But even after that upgrade was pushed, another $150 million went into this protocol before it was subsequently exploited, and then they paused the protocol by issuing another upgrade. Most users will just take the line on the left, the integral TVL, as perceived lindiness, but the security actually resets at every proxy upgrade, giving this more jagged chart. We don't want to give credit when there's new implementation logic. But we think that there is a lot of room for improvement on the audit side, and that the current state of audit reports and the lack of linking between audit reports and deployed contracts is not the future. We think that the future of audits is probably an audit metadata protocol. This isn't a new problem that the web hasn't faced before, and there are examples such as robots.txt or the Open Graph, which are examples of protocols that have standardized previously unstructured metadata to improve user experience. So in conclusion, we collected every audit report on pretty much every audit report on Ethereum DeFi. Very few of these audit reports actually link between the actual code and the deployed contracts. But we think that these first two issues are solvable with a metadata standard. But in the interim, we think that users most likely, unfortunately, end up falling back to derived measure of lindiness. But we think that one way to get around this is by exposing and making more transparent the prevalent nature of proxies and upgradability that is very prevalent within DeFi. And we propose STVL, which is a metric that resets the lindiness of a protocol whenever the logic and dependencies upgrade. Thanks.
Thanks, thanks for the talk. Next up, we have Zishan, who is engineer at Constam and will be talking about biggest hacks of 2023 so far.
Okay, so today we'll be talking about the largest hacks of 2023 so far, specifically in the context of their root causes. Now, any protocol that maintains collateral has to ensure that the user's collateral is sufficient to support their debt. And so this is done by calculating a health factor. If this health factor drops too low, then the position can be liquidated. So it's essential for all the appropriate protocol actions to ensure that this check is in place in these functions, or the position will become liquidatable, leading to unexpected states. Unfortunately, some protocols do forget to implement these checks in certain functions, and so far this has led already to a loss of over 206 million this year so far. The largest hack of 2023 so far is still the Euler Finance hack. And the Euler Finance is a lending protocol which supports liquidation, which is very profitable. In fact, a liquidator gets a 20% discount when purchasing the collateral of a liquidated position. Also, Euler Finance has a function called donate to reserves, and this allows the user to donate their collateral to the protocol. Unfortunately, this function was missing a health check at the time of the hack. And so this allowed the attacker to create a liquidatable position at will. And then when they did this, they could immediately self-liquidate, taking advantage of that 20% discount and making a profit at the expense of the protocol. And by repeating this step several times, they were able to drain this protocol. The root cause of the platypus hack, which also happened this year, was very similar. In this case, the protocol was exploited through the emergency withdrawal function, which was lacking this health check in the correct spot. So the protocol did not check the health of the position after deducting the collateral to be withdrawn. And so this allowed the attacker to withdraw as much collateral as they wanted to and essentially steal funds from the protocol. So you can avoid missing health checks by writing tests for all the appropriate functions in the protocol. These tests can attempt to bring the position below the liquidatable threshold, and you should assert in these tests that this attempt should revert or fail. You can also use invariant testing or fuzzing to find specific cases where this threshold can be reached. Most DeFi protocols require some type of configuration, and when misconfigured, this can lead to devastating consequences. Just this year, we've already seen 25 million loss just due to misconfigured markets. Now, one of the first large hacks of 2023 was on the LendHub protocol. LendHub is a compound fork, and it has L tokens instead of C tokens. So what happened here was that there were two LBSV markets. There was the new and current one, and then there was the deprecated one. The new LBSV market referenced the new comptroller, and the old LBSV market referenced the old comptroller. So this allowed the attacker to deposit their collateral in the old market, take a loan from the new market, and then immediately withdraw their collateral from the old market without repaying any of the loan. The root cause of the 100 Finance hack also this year was very similar, and it's also a compound fork. In this case, the comptroller was listing two different HWBTC contracts, the one that was used by normal users of the protocol, and then this duplicate empty market which had been completely unused. And the hacker exploited this to steal funds from the protocol. Here's another type of hack due to a misconfiguration, which happened on Yearn Finance. This is actually a pretty old contract, but the hack happened this year. So the problem here was that instead of listing the fulcrum market for USDT, it listed the fulcrum market for USDC. This allowed the hacker to manipulate the reserves and steal approximately $11 million worth of assets from this contract. Now, market misconfiguration can be prevented by writing tests for your deployment script, and this can be done on a localized mainnet fork before you actually deploy to mainnet. So you should not only assert the correct state of the contract, but you also should have negative test cases, such as checking for these duplicate or empty markets, because as we've seen, they can lead to very serious hacks. And auditing firms can also help to ensure the correctness of this state. Now, some DeFi protocols allow their users to pass in parameters which represent external contracts to be called, and some protocols even let you specify the function to be called on this external contract. When these parameters are not validated, this can lead to some serious hacks, and this has happened several times this year. So a great example is the hack which happened on Dexable. Dexable is a DEX aggregator, and it actually allows the user to specify the contract address of the DEX, as well as the function, the swap function, to call on that DEX. And so what the hacker did in this case is rather than specifying a DEX address, they specified a token address, and rather than using a swap function, they used a transfer function. This effectively allowed the hacker to manipulate Dexable into transferring its users' tokens directly to the hacker's account. And this was possible because the users approved Dexable to transfer their tokens. A very similar hack happened on SushiSwap this year. In this case, the hacker was able to pass an invalid pool contract into the SushiSwap router function, and this allowed them to take advantage of approvals given to this router by various users, and they were able to perform a very similar hack to the Dexable hack. Now, these types of vulnerabilities can be prevented by performing very strict validation on these types of parameters, these external contract addresses and call data. And you can also consider redesigning the protocol so that such flexible parameters are not required. This would greatly reduce the attack surface. So another huge trend we've seen in 2023 is the rise of read-only reentrancy hacks, and we've seen at least 4 major hacks happen due to this vulnerability. The first one that happened this year was on the Midas protocol. And so Midas is a lending protocol which allows Curve LP tokens as collateral. And the way it determines the price of this collateral token is it uses this get virtual price function on the Curve pool. The get virtual price function depends on the total supply of the LP token. So the attacker removes a large amount of liquidity from Curve, and then this results in a large amount of LP tokens being burned, resulting in the supply decreasing considerably. So this in turn affects the value returned by the get virtual price function, which is now going to return a very inflated price. And when the callback function on the attack contract is called, it's able to take this huge loan from Midas, which Midas allows because it thinks that the attack contract has a lot more collateral value than it really does. And there's been a couple of variations of this style of hack on dForce, which use liquidation instead of borrowing, and then on Sentiment and Sturdy, which use balancer LP tokens instead of Curve LP tokens. Now, this type of vulnerability can be prevented by using some type of function with a reentrancy guard before retrieving the price, or by using a library such as Balancer's Vault Reentrancy Lib. Also, generally speaking, we should be really cautious with LP token price calculations. So this brings us to the end. Thank you so much for listening.
Thanks for the talk. Super nice. Let's see if any other hack beats these ones this year. Hopefully not, but let's see. Next up, we have Yaniv from Hexagate, who will be talking about the best practices for securing Web3 protocols.
Hey everyone, super excited to be here. Today we're going to talk about building a strong defense, basically best practices in securing DeFi protocols. My name is Yaniv Nissenboim. I'm the CEO and co-founder at Exagate with over 20 years of experience in cybersecurity and a serial entrepreneur. Now, everybody here, I'm guessing, love to build Lego, right? And DeFi is a money Lego. Like, unlike the early days of crypto where systems were very simple, now we're talking about complex systems with many moving parts, from Oracle to smart contract that you are dependent on, to token that you're dependent on, to configuration and many, many moving parts that just makes security very, very complex. So it's not only that everything is open, accessible, we have multiple attack vectors, from cyber exploits to financial exploits to third-party dependencies to administration, governance, and many more. And it makes the hacker lives like very, very easy. They are highly motivated into hacking into this DeFi protocol. And again, it's not only like the systems are complex, they have many moving parts, everything is open. We have direct access to money, direct access to value. Now, a hacker in the traditional world, when he hacks something, you need to do some sort of a ransomware or to start a negotiation with the team to get money. Here, we are one transaction away from getting a protocol wiped and a hacker getting all of the funds. And we are seeing all across like the last year and before that, and I think like just the presenter before me from Quantum just like showed all of the hacks that happen. We're seeing it happening all the time, right? So it's not a question of if, and we're working with many protocols and many prospects, and like they're asking us, I'm not sure I will be hacked, I'm battle tested, I did so many audits, and we're saying to them all the time, it's not a question of if, but rather when. So what can be done? So first thing is get visibility and prepare. And I think that if you were here earlier today, so Heidi from Coinbase 0x Labs team talked about it so much. It's prepare, prepare, prepare. In some point in time, you're about to get wrecked. I can see you here. So how you get visibility and prepare, right? So first thing is you need to map. This is mapping your known threats. So this is what you're doing with companies like Certora, with formal verification, with auditing. You need to map your invariants. You need to map your first-party code. You need to hunt the zero-day vulnerabilities. You need to map all of your third-party dependencies. And this is just the first step. Then you need to go and review your internal security procedures. So you need to understand how you assess risk. Which personnel do you have in place? What are your access controls? So for example, like in Muted panel about bridges, so many hacks happen because like people don't really manage their multi-sigs, right? So you need to understand your security procedures. Then you need to take into account the way that your protocol operates, like who is or what is the profile of your ecosystem, right? What is your risk tolerance? What is significant loss meaning to you? Because, for example, not all protocols can pause their smart contract, right? So this is something which is very important. And again, prepare, prepare, and prepare. In some point in time, the worst case scenario will happen. And then this is the moment in time where you will be asked to give answers to the ecosystem, right? So I want to talk about how we are moving from periodic audits into ongoing protection. So you did an audit, right? You hunt for the zero-day vulnerabilities. Now you need to basically shift this paradigm. And instead of hunting for vulnerabilities, you want to start hunt for the threat themselves. You want to hunt for the hackers, right? So this is the next step after an audit. So you need to have, and we talked about it a lot here, you need to monitor for threats. And again, you're monitoring for the activity on-chain, for the malicious activity on-chain, because you want to detect this malicious activity before it impacts you. You need to have the remediation plan, right? And having the remediation plan is for each and every type of alert, because there will be alerts that you won't have time to react on, so they need to be automated. There will be alerts that can be semi-automated. There will be alerts that you will have a team inside, you will maybe take your developers, maybe you need to have a security researcher in place, but eventually you need to have playbooks and prepare for everything. And of course, incident response, right? Worst case scenario happened, what do? You need to have red team, you need to have proper war rooms, you need to coordinate everything, and we'll touch upon it soon. So the three pillars of ongoing protection, the way that we see it, and I'm guessing everybody in this auditorium from the space can relate to that. So you need to have early detection. Time is really important in DeFi. We are one transaction away from getting wiped. You need to be very accurate. And of course, I can't say that we are 100% accurate. And if you will hear a security company saying that they are 100% accurate, they lie, right? You need to minimize the false positive rate. You need to have, I'm guessing, more than, like in traditional cybersecurity, in some cases even more than one threat feed, because you want to increase your accuracy, and you need to have a way to minimize the response time. So how can we manage pre and post incidents? I want to give you a glimpse of how we work with our customers. Basically, our concept of pre-incidents response, right? So if you take a look, and we did it, and I think this is one of the benefits in crypto, in blockchain, everything is on-chain. So you get data from the Genesis block. It really helps us to build the models. So you basically try to track malicious activity. And malicious activity follows specific pattern, right? So it starts with funding. And in funding, your goal or our goal is to detect this like funding signals on chain, right? When we understand that there is like a malicious funding, we want to collect the signals and let the security team of the protocol that something bad is about to happen, but it's still not decisive. It's just funding, right? But you collect the signals. You want to reduce the noise. You want to reduce the noise in the system. Then you are in the preparation phase where the attacker is deploying a malicious smart contract. This is where you want to start to react upon, right? So we will send an alert to the security team, and then we want to see how they are blocking the malicious activity. Again, this is not one size fits all, right? You need to have the proper incident response plan. You need to know what to block, when to block. But the goal will be of when the hacker will run an exploit, you will be protected, and the next phase, which is laundering, will just not happen, right? Because you won't be hacked. But worst case scenario happened. So post-incident, what do? First, pause everything. Like we've been in dozens of war rooms. We contacted protocols when they got hacked, and we said to them, pause the protocol, and they take their time, and like the first hack was small, the second one just wiped everything, right? So you want to avoid the next hack. You need to be able to open a war room, and everybody opens a war room, right? It's on Telegram, it's chaotic, right? Everybody asks, who knows Coinbase, who knows Binance? You need to be able to prepare in advance. In the war room, you communicate with your community, right? You do a triaging, you do a full process of understanding what is happening and what are the next steps. One of the next steps will be contacting the law enforcement. You need to give them reports. You need to contact centralized exchanges. You need to contact Circle. You need to contact Tether. And why is that? Because you want to limit the blast radius, right? You want to be able to freeze assets. And of course, you want to track the funding sources of the attacker, because in many cases, it will allow you to identify his identity. Thanks. If you want to learn more, here's our contact details.
Thanks, Janev. That was a great overview. We'll have the next speaker now, Felix from OpenZeppelin. We'll be talking about 100% test coverage, but 0% security.
Hi. Yeah, thank you very much. My name is Felix from OpenZeppelin. You might know our security library of smart contracts, and we of course also do audits, monitoring, and many more things. And today I want to talk to you about testing. So we have like one really crucial question to answer. If we get 100% test coverage, do we get some security, no security, a lot of security? And I'm trying to answer this today. So let's take a step back. Why are we testing at all? Typically, you want to see whether your code base actually has some kind of functionality. Probably the functionality you intended your code base to have. That's kind of the point of tests. But then, looking a bit further, you have like additional points of your tests. Typically, you don't only want to do unit tests, you want to do like some integration tests or some end-to-end testing. And they actually have a descriptive functionality. So you can really see like what's the happy path through your code base. What are like the interesting ways a potential end user can interact with your code base. So this kind of descriptive functionality is also in there. And then, does it contribute to security? Well, we are hoping that it does, but we don't know at this slide. So let's move on and answer this question later. Now, talking about the quality of tests. After a while, you want to be done with testing. So we have like different quality metrics. The first one is a functional metric. It's the test coverage of your code base. And this is typically like a line coverage or a branch coverage. It's a nice number. And we're assuming that it's like 100% in our test example. So we're doing very good on this case. And then, again, descriptive means that you have kind of interesting test cases, not just like very small unit tests, but some very interesting end-to-end test cases. And now, it's again the question, do we need an additional metric, or are we just like accidentally already done with security and have perfect security as well? So let's look at a small example. This is like a very small ERC20 token I wrote. You can see above in the slide, 100% test coverage is ensured to us by like Foundry. And you can see in the lower part of the slide, well, I wouldn't really call it interesting, but because it's a minimal example, it's kind of like the 3 use cases I imagined for this token, that you can mint it, burn it, transfer it. Yeah, they all work out. They are all covered in this test case. So basically, we're doing perfect on the functional and descriptive side. So are we secure? No. This has a public burn vulnerability, so you can just burn any user's token. And basically, this is like a critical vulnerability, and the security here is really like 0%. You need to fix this. You can't deploy it in this shape. But so what is missing? This test case is missing. If you don't know the Foundry syntax, you see in the name that it starts with test fail. So it's kind of asking for the opposite of what you see in the test case. It kind of verifies that this test will fail. And yeah, it's a typical test that just tests that like an arbitrary address, like a non-owner address, can like burn 1,000 tokens of another user. And yeah, you really want to make sure that this cannot happen. So you want to write this kind of negative test case. Now, this was a small example. Let's move to the overall principle. What we typically see when somebody says they are doing testing is completely on the left side. They do functional testing, they are concerned with coverage. But this is just one aspect of testing. And it's good that you do it, but it has actually very little to do with security. If you want to do security testing, you have to be on the right side. And you have to ask yourself, like, how much testing of an absence of functionality am I doing? So for example, for unauthorized functions, am I really testing that like a message sender that is just an arbitrary person cannot interact with the contract in a certain way? And so this testing for absence is what we call security testing here. But now I want to take an additional step back and wonder about like how does testing look in theory and in practice? So in theory, numbers provided by IBM is that, yeah, we should invest a lot in testing because it really pays off. If you find something early during the design phase, the implementation, the dedicated testing phase, your cost is kind of moderate, and it really explodes in the deployment phase. And this is not for blockchain systems, where like the number 100 you see might be even higher because of like the TVL attached to it. But this is already like across arbitrary software systems. So in theory, everybody should basically do the best possible testing because the economics clearly tell you it will pay off. Now let's look at the practice. Testing is not sexy. Testing is really like uncool. Nobody says, oh, I'm really passionate about like QA testing, I'm a tester. Like all the cool stuff is basically associated with hacking. So of course for like your protocol, that's kind of like a bad thing, right? Like you don't want to be hacked, but hacking is rather cool, while testing is kind of like the ugly thing you have to do, but no one really wants to do. So let's now look at how we can like fix that. So this is my recipe to make testing attractive. Basically, do hacking as part of testing. So to do like really good security testing, we start with while true, because you can iterate this loop forever. What you do is you come up with like a creative POC exploit. You're basically trying to exploit your own protocol you're trying to develop. Then you verify that it doesn't work, hopefully, or you actually found something that you really need to fix. And then you just don't throw this away, but you integrate this as a test case into your security testing test suite. And that, from like a day-to-day activity of how you think about it, makes this a lot more attractive, because this is not like the unit testing or the boring kind of testing you know, and it's like the typical university curriculum, but this is more like the modern kind of like hacking mindset you apply. You just apply it to like an artifact that makes it into your test suite. So nice theory, but now to actually add more practical points to this, let's look at the projects just this year that had like some code level vulnerability. So this is no exposure of private keys, no rug pulls or something like this. Rather, they had a bug in the code that could have in principle be prevented by this kind of testing methodology. And we see that like the funds stolen today in this year are 250 million already. So I think this is like a good argument to potentially integrate this kind of like thorough security testing into the test suite. So now on a very high level, if you are a decision maker, you don't want to like recall the details here, you want like a really simple metric, count the number of interesting test cases based on proof of concept exploits in your test suite, and make this the metric of security testing. So to summarize, 100% test coverage is functional testing. It's not related to security. If you want to do security testing, which you should test the absence of something. If you want to do this in a good way, you need to like adopt a hacking mindset and really do exploit POCs as part of your test suite. And unfortunately, there's no silver bullet. This is not exhaustive. You can start this as part of your project internally, and then best reach out to your security partner to basically further enhance this kind of testing methodology. Thank you very much.
Thank you. Yeah, definitely people gotta start adding negative test cases, not just all happy, positive stuff. Next speaker, we have Jack, who is co-founder of Sherlock. He'll be comparing traditional audits with audit contests.
Screen mirroring or anything?
Full screen maybe? And if you can mirror.
Yeah, let's do mirror. Okay. All right, hey guys. Cool, so my talk today is going to be a little bit of a continuation of the auditing panel that we just had about an hour ago about kind of conventional auditing versus the community contest approach to auditing. The title here is Quality of Auditors or Quantity, you know, which one matters more. And so last DeFi Security Summit, Sherlock announced, released the hybrid audit contest model, which is sort of a combination of an audit contest and reserving well-known top auditors to also audit the code base in a more traditional fashion alongside it. And it's a really cool model. Basically, there's incentives for both sides to perform well. If they don't perform well, there are negatives. They lose out on money. They lose out on ranking. They lose out on potential leading opportunities in the future. So last DeFi Security Summit was end of August, so we're about 10.5 months into this new hybrid audit contest approach that Sherlock has been kind of pioneering. We've done about 85 contests, and we found around 1,000 high or medium vulnerabilities in those 85 contests. And so we're now at the point where we have like a kind of statistically significant data set that we can sort of look at and try to find some interesting things in. And one of the important questions, or one of the questions that people are very curious about, is who actually is finding most of the issues in these contests, in these audits that kind of combine both the traditional and the community approach. So just as a reminder, in Sherlock contests, there's usually 1 to 2 highly ranked elite auditors. We call them lead senior Watsons. They get paid a lot of money every week to show up and do the audit. And then there's roughly 200 security experts on average. I think it's closer to 300 to 400 at this point. But across that data set, it's about 200 on average that are looking at these contests. And so the question for you all is, who do you think finds more of the critical and important bugs in these audits? Raise your hand if you think the 1 to 2 highly ranked elite auditors are finding more of the critical bugs. All right, maybe like 30 hands. Raise your hand if you think the 200 kind of random security experts all over the world are finding the most critical bugs. About the same. All right, it's a split audience. So we'll start with non-critical first. These are like the medium vulnerabilities. These are things that are not super critical. They're not kind of crazy in terms of could hack your protocol immediately. As you can see, 1 to 2 lead senior Watsons, they find 46%. The community finds 81%. And that's not super surprising because a lot of these things are sort of creative. They're sort of edge cases that maybe you would find, maybe you wouldn't. It's not the worst thing in the world if you miss one. So having 200 people looking at code just kind of, yeah, you just find a lot more of these. But moving to who finds the actual critical vulnerabilities, it's really close. So the 1 to 2 lead senior Watsons found 66% of them roughly. The community found 76% roughly. So, I mean, I would almost call that a tie, but as you can see, the community kind of edges out the senior Watsons when it comes to finding those critical vulnerabilities in Sherlock contests over the last 10.5 months. So we think that's really kind of interesting, and the fact that both numbers are so high is really a testament to the skill of both sides, in my opinion. And another way of showing this data is basically, if you don't have lead senior Watsons, if you don't have those reserved auditors doing this audit, then you will miss roughly 1/4 of the critical vulnerabilities, in the code base. And if you don't have that community aspect, if you don't have the contest with hundreds of auditors participating, then you will miss about 1/3 of the critical vulnerabilities in your code base. And so here's a small case study. Sherlock did an audit on the Bedrock system of Optimism, their upgrade earlier this year. It was the 7th audit, so this was like a pretty well audited code base at this point. Sherlock was still able to find 3 kind of critical high vulnerabilities. We kind of categorized those together. And the interesting thing about those 3 vulnerabilities wasn't so much that we found them, but it was how they were found. And you can see here, one of the vulnerabilities was found by the lead senior Watsons, and it was solo. So only the lead senior Watsons found them. Shout out to Zach and Trust. I think Trust might be here for finding those. They were kind of the team, the lead senior Watson team that took on this audit. And then one person from the community found a solo finding that the lead senior Watsons did not find, and that was HE1M, really crazy bug. We can talk about that in another talk. And then there was another critical vulnerability that was submitted by both the lead senior Watsons and the community. And the interesting about this is it's kind of a perfect case study for if you had only had one of those parties, if you only had the community, you would have missed a critical vulnerability. If you only had the lead senior Watsons, you would have missed a critical vulnerability. And so Sherlock's stance on what's better, the community or the traditional style of auditing, is having both is better. There's not like this, you don't need to choose one or the other. You should have both. You should combine them in the audit. And Sherlock is the only one that kind of provides that right now. We're the only auditor that has both the contest model and that more traditional approach of including well-known security experts and paying them a fixed amount of money to show up. And another shill for Sherlock is that we have millions of dollars of smart contract coverage that any protocol that goes through a Sherlock audit is able to activate after they do the audit. So yeah, that's pretty much it. And the last thing to talk about is Sherlock is shipping, for the people who compete on Sherlock, which I know there are a decent amount of them in the audience, Sherlock is shipping a new feature that will go live for the index contest starting tomorrow, which is anonymous submissions, which people have been asking about for a while. And that means that your Sherlock username will no longer be shown in the judging contest. Basically, if you are an unknown security expert, someone might see that you're less well-known than the lead senior Watson, and they might say, oh, I'm not sure that issue is real. Now everybody gets the same green, spicy unicorn made-up name, and there's no way to tell who the lead senior Watson is. You have to only judge the issue on its merits. So that's coming out tomorrow. We're excited for it, and hopefully all the Watsons are too. Thank you.
Thanks for that. Audit contests are definitely a great addition to audits. They don't replace them, but a great addition nevertheless. Now we have Mark, who is from Paladin Security and Ambit Finance, who will be talking about importance of researchers and auditors at a DeFi protocol. If you have any slides to present.
Where should I plug? Yeah. See? Yeah. No HDMI. This one. Let's see. Yeah. 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 Is it working? Yeah.
Hi. Hi, I am Mark Weiss, and some of you may know me as UX Weiss on Twitter, and today I am going to present the importance of auditors at the core of the DeFi protocol. So I'm currently an independent security researcher and a private auditor at Ambit Finance. I do private audits there. I'm also a lead senior Watson in Sherlock DeFi, and I'm a security auditor at Paladin Security. So as my talk involves how an auditor researcher could help in all the stages of a DeFi protocol, I will first explain those stages and how an auditor could be helpful in them. The first one is development. It's the stage that goes from the ideation, the design of the code base, and the architectural decisions. Normally, researchers have audited or gone through hundreds of code bases, and they know the best architectural decisions and how to better design each type of code base. For instance, if you are doing a borrowing and lending protocol, whether you want to use a dynamic or a fixed interest model, whether you want to use upgradable or unupgradable contracts, which type of them you want to use, whether you want to use proxy pattern, TPP or UUPS, and if it's non-upgradable, whether you want to use a registry-based architecture. That goes hand by hand with the testing suite, so auditors could help similarly in both of them. The third stage would be the audit. The audit would happen once the protocol has already the contracts ready for mainnet. This would be most once the testing suite has a range of more or less 100% coverage, whether the protocol already also used fuzzing, whether it used the internal Foundry fuzzing or Echidna or whatever tooling. And for independent researchers, an audit would consist in a security review that would would just give the protocol and give the report to them internally. Once this report is done, the protocol would go to mainnet, or even they would set up a bounty with any of the bounty platforms. And in mainnet, the researchers are very useful because they have already a lot of experience there, and there are so many things that can go wrong that their experience could be very helpful. To complement the stages, we would have the root causes of hacks in the DeFi protocol. I would highlight 6, and the first one would be lack of knowledge. Lack of knowledge would be anything that has to do with like reentrancies, under overflows, or even not understanding some EIPs, like the EIP 150, that it's basically that you would forward 63 out of 64 of the remaining gas to external calls, or other APEs like 2929, where you would choose the gas that's spent on opcodes like call. It changes depending whether the call has value or not. The second root cause I would highlight, it's like external vectors. External vectors would be like private key leakages or something external to the auditors itself. Point number 3 would be contract maintenance. Depending whether you're having, for instance, an upgradable code base or non-upgradable, you would have to upgrade the contracts, point to the right implementations. If you have a registry-based architecture, you have to deploy new contracts and just set up the new state variables. Number 4 would be architectural errors. Architectural errors would englobe whether you are handling correctly external contracts, whether you are having, for instance, fallback oracles if you need them, anything that has to do, as I said before, with interest rates models, if it's fixed or dynamic for lending borrowing protocols, anything like that type. Number 5, we have logical errors. Logical errors would be anything that has to do specifically for that code base that the developers developed. For instance, some state that should not be getting at, some invariant that you broke, or the code base just can get to a denial of service state that you cannot recover from. And 6th and last would be deployment scripts, which is very underlooked by a lot of protocols. And actually, there are a lot of errors there, which normal audit firms, neither independent researchers do review. So I prepared an example for them. So this is a contract where it has 2 permissions, the operator and the owner, owner being the root permission. And a correct deployment script for this contract would be basically that you would call the constructor and just set the owner address, and after you would call set operator and set the operator address. As you can see in this contract, there is only one. There are more functions, but highlighting one function, withdraw funds, that it should be only going through with the operator address. As you see on the last require, that it checks that the signature recovery it's equal to the operator. So the operator should be the only one to be able to withdraw the funds. In a faulty deployment script, for instance, the developers would just forget to call set operator because it's not on the constructor, and then would cause, if this is underlooked and this is in mainnet and the funds are just entering the contract, anybody would just be able to steal all the funds because, as you know, EC recover with a faulty signature would return 0, and it would pass the require signer is equal to operator. So to complement all the said beforehand, here we have the benefits of having auditors and researchers in your DeFi protocol. This would complement everything like we spoke, the root hacks and the stages. So firstly, it's the benefits in war rooms. The benefits in war rooms, as we know, a lot of researchers have been, mostly experienced researchers have been in war rooms before. War rooms generally happen when a protocol gets exploited in mainnet. That now we know that happens pretty much every week. So they are quite common, and there's periods of time where it's critical to act fast and basically just you are in a lot of stress, and auditors and researchers are usually on that stress, and they have experience on this, so it would be a critical point where auditors would be able to help protocols here. Secondly would be breakdowns of bank boundary report that goes together with proof of concept building. Pretty much any researcher, auditor builds proof of concepts at least weekly, and it's very critical for protocols to actually be able to do this proof of concepts fast in case they are exploited, as it goes together a bit with the expertise in war rooms. And same thing with breaking down bug bounty reports. We know that bug bounty reports are not always the best quality. It depends on the experience of the hunters. And there are a lot of times that you can say whether a bug is actually valid or not by just looking at the report, but it's not always that case. There are reports that actually come with very low quality, there are findings that actually come with a very low quality report, that they are underlooked and they're probably not very good to understand by the protocol. So as auditors really have been through a lot of reports, they could just help breaking those down and implementing the fixes. Then you have much cheaper than paying a critical bounty. Researchers and auditors are not cheap neither, but would you rather spend $500,000 in a critical bounty or just hire 2 researchers that they probably are not going to cost that money and you might be able to save it? Lastly, security-based approach on designing protocols. This goes a bit with the beforehand design explained. It is clear that a lot of bugs actually are in the code bases because they are not designed correctly. It's critical that the code base have a secure mindset when designing them, and auditors do have it, so they could advise in the best way to those protocols. So thank you. I am Mark. Any inquiries that you have about private auditing, anything about the presentation itself, anything you want to ask me, you have my email, my Twitter. So yeah, I'm open to answer questions.
Thanks, Mark. That was super nice. We have a short break now, and then we'll reconvene later for another set of talks.
Do you know Noah?
Yeah, Noah has a long
Can I just check? Hello. Just checking for speakers of the next session. Do we have Noah here?
You're the one. You're the one.
Yeah. You can go.
I was just checking if they're all here.
Yeah?
Just
You can ask. You go ahead.
Do we have Noah here? Ah, Noah is.
Who else is missing?
Fabrizio. All right. Elon. Antonio.
Oh, hi, Noah. This is Noah. Who's missing? Antonio?
And do we have Irene?
We will wait for her. Okay. She was here earlier. And Antonio, right? But these are
Are we excited? It's the last session of the day. So we have Noah now. Noah, feel free to take it away. You're going to talk to us about honeypots, right?
Huh?
Honeypots? Hacker traps on the blockchain.
Here?
Take it away.
So, these work? Yeah? Oh boy, I have a timer. I didn't expect that. So, hi everyone. I'm Noah from Hacken, and today I'm going to be telling you about a really obscure exploit type called honeypots, which are pretty much hacker traps on the blockchain. So to skip about 25 slides, let's go to exploiting smart contracts. You want to exploit the smart contract, and here is you. You find a target, and you think you got an exploit. And there's two things that could happen. One, front-running bots. Somebody sees it on the mempool because you didn't use Flashbots Protect or something, and you miss your chance, buddy. Option two, you are a bad hacker. You did not correctly identify your target, and you were trapped by something called a honeypot. So, what are honeypots? Well, smart contract honeypots are a special class of smart contracts that look vulnerable but aren't. The big idea is to make you, as a hacker or a security professional, think that you can earn some money by sending funds to that contract, when in reality there is some quirk in the engine, in the Etherscan, or in the code that means that only the owner / the deployer can actually withdraw these funds. So some quick technical examples. Here's the multiplicator honeypot. That's like the school level example. And in this case, we have a simple function that takes that's payable, and it checks if your message value is bigger than the balance on the contract. And if it is, it sends you all the funds on the contract. Now, anyone here know what's wrong? I mean, it's written, but come on. So this .balance already includes your value. So this if check is really just going to be deleted by the compiler, and nothing happens. This is an empty receive block, and it's beautiful. And this doesn't really work in practice, right? It's too simple. But here's one that actually does. So this is gift box. This is a King of the Hill game, and in it you have a stake function. It checks if you sent more than the largest stake, and if you did, then you become the new owner, the new King of the Hill, and then using the withdraw function on the right, you can withdraw your funds, right? And this is all fair, except those eagle-eyed among you may have noticed there's two owner variables, one on the left, one on the right. The one on the left is set in the constructor on the left and defines the modifier on the left. And that one is never changed again. Well, one on the right does absolutely nothing and is the one that's modified. So the original owner of the contract is going to stay the owner till the end of time. and they can call the withdraw function and take all your funds. Sounds silly, does it? Well, would you like some money? Because these people did, and look what happened to them. It actually works, and it's somewhat profitable. Again, this is obscure. This is not 200 million Euler hack. This is like 1 million over the last 5 years micro hack. But this guy earned a few thousand euros, and nobody can tell him whether it was legal for him to do so or not. Actually, it's sort of illegal based on the most recent legal advice I got, just in case you want to run your own. But yeah. The next example, just keep it quick, gift box. So everybody here knows how to do passwords properly, right? You want to use SHA-3 and not just set a password because everything's public on the blockchain. And the get a gift function, it's okay, don't worry about it. The tricky thing is the set pass function, which is also in general good-ish. It checks if the password has been set and allows you to put some money on the contract to set the password, so pretty much set the gift box. But you come across this and you look on Etherscan, and there's already some money on the contract, right? And it looks like somebody set the money because he wanted more of a reward, but forgot to set the password and then call the set pass function. And by default, that's going to be a hash of 0, and I think that's something that you can get to. Or you just, call the set pass function. Sorry, you cannot get to that hash. But you just call the set pass function with 1 Ether and you get all the money out, right? But the thing is, there's a problem with Etherscan for the last infinity years. And that is that it's not very transparent about contract-to-contract transactions. And this is actually a good place for me to mention this, because now you can all go to Etherscan and tell them, please fix this. You see somebody called this set hidden function from a contract, and if you look at the Etherscan, nothing here. If you go to internal transactions and turn on advanced mode and read into every single transaction, eventually we figure out that the state changed here, which is a bit of work, right? So yeah, that's a fun one. These are the honeypot examples. Why do they work? One, hacking is a nasty business. You got about 1 minute to find your hack before somebody else does, right? When the contract is deployed. 2, there is a ton of hackers that don't really know what they're doing. They're just running a tool, like TO is a big example, if you know it. But in that case, somebody may be exploiting that tool. And 3, just Etherscan sucks. How do we detect them? So symbolic solvers, heuristics, as was mentioned yesterday. You need to be an expert. You need to know what you're doing and what you're searching for, and then you can create a solver that's going to check for specific scenarios. Option 2, transaction patterns. So that's something the incident detection crew is going to be really good at and be able to maybe find them that way. That only works for ones that have been exploited, though, because, I don't know, ML training on bytecode is sort of tough. So standard process, get all the contracts, get all the data, generate your training data using the symbolic tool, and classify using ML, right? And what can we get out of that? Well, there's, in that period that was tested, about 2 million smart contracts. There's a lot more now. And of that, only 150K were unique. I checked about 2 weeks ago, and right now there's only about 600,000 unique smart contracts. So it's still not that much, honestly. Of these, 50K cash flow and about 300 honeypots, not very common, which is 2,500 deployed ones when you account for the duplicates. What are the types? So balance, that's the silly one. Somebody fell for that, I know. Then we have a few code issues. And then we have a few Etherscan issues, and as you can see, the Etherscan issues are the big money maker. There's some additional cool ones that have been discovered recently. Role encoding. Okay, you know the Greek question mark? Replace the semicolon in someone's code with a Greek question mark and just watch them off themselves. Yeah, you can do that in Solidity as well. So you take OpenZeppelin's access control library, and you pick like a random language like German, and you find the normal, O with umlaut, and you find another similar-looking Unicode character, and you just mix those around as permissions in code, and somebody's gonna fall for that. So yeah, nice one. Another one is just, do not put the parentheses on a call, and watch what happens. It gets removed by the compiler, and you can make the code look a lot different for somebody reading it, right? Insights. Again, sorry, this is really fast. They work usually only once. You would expect after somebody falls for it, you get at least some info from Etherscan about it being maybe dangerous. They follow price peaks only when they're the most profitable. So I really wonder how many there are right now. Probably a few more of these patterns. And they're not very big, only 250 ETH, so 1 million in that time period, maybe like 5, 6 million till now. Not too bad. And right now, yeah, you can detect them pretty well for the known types using the symbolic solving approaches. If you're interested in finding out more, continued research on the honeypots projects is within the Smartbox project, which you can find the GitHub repo for here. It's a pretty useful general tool aggregator. So yeah, check it out, and I hope this was a fun topic for you guys, because that's all it is.
Thank you so much, Noah. I never liked honey or pots. So, next up, we have Fabrizio from 20 Squares talking about compositionality. Let's go.
Hello, everyone. My name is Fabrizio from 20 Squares. And today I wanted to talk a little bit about a technique, more of what we do or stuff like that. So, okay, this is the current state of the ecosystem. I'm going to be honest, I think that basically every auditor in this room has had to shovel enough shit to know that, we live in a time of often badly set specs, badly implemented code, and auditors are basically called to fix that. If you listen around and look at what many people have to say about methods to improve the situation, at least to me, it really feels sometimes that the proposed solution looks a bit like this. Like many people, propose some fancy new cryptographic primitive that is going to solve everything and stuff like that. But in the end, at least my feeling is that sometimes what we still lack is a deep theoretical understanding of, some of the things that go on in basically the smart contract and blockchain world more generally. So, for what I experienced, one of the worst parts where a lot of errors basically pop up are around interfaces. Interfaces here is a very loosely defined concept. For instance, a contract calls another contract, bad stuff happens, multi-chain interaction, bad stuff happens, off-chain, on-chain interaction, bad stuff happens. It feels like a lot of times when you have something of type A and something of type B interacting, bad stuff can happen. Now, basically, if you ask to programming language theory experts and people that do that, are that kind of kink, they will tell you, well, we invented type theory to solve some of these problems. That is true, but sometimes that's not enough. So in that picture, you can see, for instance, a very well-defined type, a very well-defined other type, a very creative type conversion between one and the other that, yes, works, but it really feels like duct tape again. So if we had a formal solution to solve this, basically the kind of thing I wanted to talk about in this talk is exactly that. There is a mathematical theory that is called category theory that I feel is very underrepresented in our community. Basically, category theory was invented in the 40s, and it's the formalism on which nearly all of the biggest achievements of mathematics in the last 50 years have been built upon. And the idea is that category theory is the superglue of mathematics. It really makes you able to describe what happens when things interact. So in this image here, for instance, we have the basic object, one of the basic objects of category theory, that is the concept of a functor. So the idea is that a category is basically a mathematical object made of objects and structure preserving maps between them. If you are versed, that could be types and functions between them. It could be sets and functions. It could be groups and group homomorphisms. It could be, I don't know, topological spaces and continuous maps. The list can basically go on forever. But the idea is that you can package the idea of a particular structure, a particular flavor of structure, into the notion of a category. And now you can basically have the notion of a morphism between different categories that is basically a kind of coherent transformation that allows you to morph this structure to map it to another kind of structure. So that's exactly what happens there. I have a notion of objects down, A, B, and C, and transformations between them that can be composed. And the idea is that I also have another category upstairs, and a functor is exactly a map that allows me to map objects into objects and transformations into transformations in a coherent way. Now, you could be like, okay, interesting, but what do I do with that? Well, funnily enough, basically in the last 20 years or so, category theory has been used extensively to model things that are kind of not really related with mathematics. So, I mean, yeah, joking, they are, but not as much as you would expect. So, for instance, this thing here, this kind of a weird bunch of dots and stuff, it's a pictorial calculus that allows you to do quantum mechanics. Basically, these kind of pictures can be manipulated in a very formal way, and they allow you to reason about quantum mechanical systems, and they allow you to instantiate quantum algorithms and quantum protocols without touching linear algebra at all. Like, you can basically play like a little kid with these things, and you can verify and prove properties about quantum stuff. How does it work? Well, it works because there is category theory underneath that basically says to us that we can consistently mapping all the linear algebra that we usually need to do quantum computing into these pictures. So the idea is that you do all this giant work, it took like 20 years or something, and then you can hide it, and you can basically let kids playing with these things, and they are happy, and you can do quantum computing. Similarly, here we have a picture of basically the bread and butter of what we do at 20 Squares. This is graphical calculus that allows you to do game theory. And in fact, those things depicted there are basically the prisoner dilemma. The idea is that you have two players that are the two triangles. They basically perform an action. This action gets piped into a payoff matrix. And the payoff matrix basically gives back the payoffs to the players. Again, you can follow this as a picture, but the funny thing is that, again, there are categories in the back that basically tells you, yeah, these things compile to games in the traditional sense. And I kid you not, basically we implemented this thing. You can compose these little Lego bricks, and then you can basically push a button and compute the equilibria of this game. So yeah, in here we have, again, other categorical stuff. I'm not really going to talk in depth about this, but basically, I guess that the gist of this talk is that, yeah, category theory is really the math of composition, and studying it in depth will, you know, really turn your understanding of mathematics and how interfaces work, interface between things, upside down. So that guy in the picture is a guy that did a ton of category theory, and I mean, you see how it started and now it ended. Probably that's not a good example, but yeah, I mean. And yeah, so all in all, it's true, theories are just theories, but when you have a good abstraction about your problem, I think that really helps you understanding what's going on. So yeah, I think that's it. I just wanted to point out to you that this thing existed, and look it up on Wikipedia if you want. I'm done. Thank you.
Thank you so much, Fabrizio. This is really good. Next up, we have Martin, Head of New Initiatives at Quantstamp. Let's go.
All right. Thank you for the introduction. So I'm Martin. I'm from Quantstamp, and I want to be talking today about flash loans and how we can synthesize such flash loans and attack vectors automatically. So here is a list of protocols, and very obviously you can guess that all of them were hacked, right? All of them were hacked within the period of 2020 up until 2023 using flash loans. Most notably, the largest one, Euler, was hacked for nearly $200 million this year. So altogether, this sums up to $300 million in damages. And I'm here today to talk about a tool at Quantstamp that we have that can achieve something like that. If we had that tool 3 years ago, nobody would have been hacked. So what is a flash loan? Just to be complete in our definitions, flash loan is simply an uncollateralized loan that you can take as a developer from a smart contract for the scope of a single transaction, right? So you will say, hey, please give me a flash loan of size X. If this liquidity is available, the smart contract will give it to you. It will run actions that you want it to run, and at the end, it will check whether you have repaid this flash loan. If you did, then the transaction will remain unreverted, and otherwise it will revert, right? So this is what a flash loan is. What they were developed for or designed for is closing arbitrage opportunities. And sometimes they're used for that, but sometimes because you can actually borrow a lot of money, they're actually being used to exploit DeFi protocols. So attackers usually take flash loan, they manipulate some market somewhere, and then they exploit another protocol that uses that given market as a price oracle for some purposes. And the reason why I'm able to be here today and why I was able to show you that slide before is that, unfortunately, due to composability of DeFi, flash loan attacks and attack vectors, they're actually really hard to find. So, for this reason, I've been actually on a lookout for a tool that could aid the discovery of such attack vectors for us. Pretty much since the very first flash loan attack. So the very first flash loan attack happened at ETH Denver in 2020. And right in 2020, we actually had some first attempts to use automation to discover such attacks. So the very first one that I am aware of, that was Bernhard Mueller, who used Mithril and MythX to discover flash loan attacks. And he actually gave talks here in Paris at ETHCC about that, still in July of 2020. But unfortunately, he was only able to handle some very basic cases. He was actually portraying it and framing it as discovering arbitrage opportunities. He was using Uniswap contracts, and the general performance and the quality of these findings were not sufficient for practical use in the auditing industry. Then last year in August at the Stanford Blockchain Conference, I actually saw a really nice talk about something called Clockwork Finance Framework, which uses formal verification and the CAME framework to discover flash loan attacks. It has a lot of caveats. It's a purely academic work, and it's also not suitable for practical use. And finally, there is also something, or there was also something called Vanguard. So Vanguard was a tool developed by Veridice. I checked it in December 2022, so last year. is no longer available. It was taken down from GitHub, and it was also attempting to discover flash loan vulnerabilities, but was not successful in doing so. So the bottom line is, if you actually want some automation and if you want help from tooling, you need some new ideas in here. There is nothing out there, or there was nothing out there up until this point that would work. So I discovered this work by a student at the University of Toronto who we partnered with at QuantStamp and brought into production a tool that works roughly as follows. It perceives the entire protocol and the sequence of actions that you can perform on the protocol as a profit function of the potential profits to the attacker. So, imagine something like Compound, right? You can deposit funds into it, you can withdraw funds from it, you can liquidate somebody else, and then there are various parameters that go into these function calls. So these parameters, those are some variables of a multivariate polynomial, and if you sequence them, if you plop in some particular values, you will get a value back, and that value back is what you would receive as an attacker if you were, performing this action. Now, if this action is positive, or if the result of this function is positive, then as an attacker you would make money. If it is negative, then you would not make money, right? And if you ran everything inside of a flash loan call, then such a sequence of actions would revert because you would not be able to repay your loan. And so this is what we actually do. We generate a whole bunch of random sequences of these actions and parameters that can be fed into those. And then we evaluate what profit would the attacker get if this was run inside of a smart contract that would take flash loan and run this as an attack. And then whenever we just get these whole bunch of random points, then we model this multivariate polynomial and we take a look at what are the local maxima that give us positive profit, right? And once we find something that gives us the positive profit, we actually take these parameters, this specific sequence of action, and we execute it in a simulated chain environment. So imagine something like a fork of blockchain on Foundry or Hardhat or something. And then, if this confirms that such a sequence of actions actually executes and gives us the profit, we have synthesized it automatically a full attack vector that would exploit the given protocol. And if it doesn't, if it reverts, or if the profit is actually negative, then we have obtained another function point, right? Another point of that polynomial that we can plop in back into our models and improve those models and keep searching and searching and searching. And this is showing to have a very, very, very good results. As I showed you on that one of those initial slides, we are able to find pretty much all the significant flash loan attacks and hacks from the past 3 years, including Euler. So, here is an example of an output, how it looks in our particular implementation for the Euler protocol. And that's about it. So, in summary, what I wanted to tell you is that at QuantStamp, we now have a tool that is actually capable of automatically discovering flash loan attacks. It uses completely new approach. You will not find any symbolic execution or formal verification in there. It just uses pure numerical analysis and modeling of polynomials. Unfortunately, for the whole time I was saying, yes, it's automated. Yes, it is automated. The search runs automatically, but the tool still requires a little bit of manual guidance and a little bit of retrofitting for every single protocol. But thanks to all the work that I have done together with Jeff within this past half year, this pendulum of work that is actually required is not so much. It is very, very comparable. It's actually a little bit less of the amount of work that we do when we perform a normal, regular audit. So it is extremely applicable and it's extremely executable and repeatable in practice for discovering such hacks. So currently we have an implementation. It applies to all EVM chains, but as you can guess, this technique is actually super, super generic. So it could be applicable to other runtimes, and we would be able to apply it to other blockchains or even cross-chains interactions as well, but we have not done that work yet. And finally, the main reason why I'm here, we are looking for DeFi protocols and blockchains and funds and whoever else who is interested in this topic and wants to pioneer with us. So if you do, please get in touch with me. There is a QR code in here. That's the Telegram contact for me. I will be in Paris for the whole week. And yeah, thank you for your attention.
Thank you so much, Martin. Apparently, QuantStamp has ended flash loan attacks. Let's hope so. Good talk. Next up, we have Alon. co-founder and CTO of Redefine, talking to us about DeFi scams and how to solve them with symbolic execution.
Hello, everyone. Today, we are going to talk about DeFi scams and how, with the power of symbolic execution, we can detect and expose them. Let's get started. My name is Alon Ram. I'm the co-founder and CTO at Redefine. Redefine is a Web3 security company, specifically helping users and institutions to manage and mitigate risks, including DeFi scams and hacks. Prior to that, I worked for the Israeli government for many years, doing cybersecurity and crypto. We all love DeFi because it's a permissionless and trustless nature. But the trustless ain't always trustworthy because you depend on the security and the credibility of the smart contracts. Now, anyone can write smart contracts, even bad people. Over the past 3 years, more than $2 billion have been stolen in DeFi scams. There are more than 100,000 scam tokens. Most of them are traded on known dexes like Uniswap. Rug pull is the most common scam. It's when a scammer develops smart contracts with a backdoor, convinces user to buy it, and when the price goes up, suddenly he withdraws or pulls the rug out from under the investors, causing them to lose their investments. There are several types of such backdoors like prevent selling, hidden mint, and forced transfer. We'll cover them all. What is symbolic execution? Symbolic execution is a software testing technique that uses symbolic inputs to analyze all the potential execution paths of a program. It is used to detect bugs, to verify the correctness of a program in code coverage and in security analysis. We will see how symbolic execution can help to detect DeFi scams. How does it work? Let's say we have a simple function with some computations and if statements. The first step is to replace the concrete inputs with symbolic inputs. The symbolic inputs can represent any given value, any possible value. In this example, A and B are symbolic inputs. Then we execute the program symbolically. Operations in the program that involve these symbolic inputs are carried out symbolically. In this example, Z equals 2 times Y, which translates to symbolic expression Z equals 2 times B. The symbolic engines create symbolic inputs and gather path constraints. Path constraints are conditions derived from the if statement that the symbolic inputs must satisfy in order to follow a certain path. In this example, there are 3 possible paths, and at the end of each path, we can see what is the path constraints that define this path. The final step is to solve the model. We use constraint solver, also known as SMT, to find concrete inputs that satisfy the constraints. In this example, there are 2 solutions. Let's take, for example, one, A equals 2 and B equals 1. It means that if I put these inputs into this function, the function would follow this path. Sounds complicated? Let's try to explain it in a simple way. Imagine you are in a large maze full of twists, turns, and dead ends. Normally, you would have to go through the path, making decisions at every junction. And if you hit a dead end, you would have to go back. This is like traditional execution of a program. You give it inputs, and you see where you end up. Now, imagine that you have a magic bird's eye view of the maze. You can see all the possible paths at once. You can see where each junction will lead without having walking in this maze. This is like symbolic execution. You can see all the possible execution paths of a program at once. Let's see how symbolic execution can identify actually scam tokens. The ERC-20 standard only defines the interface of a smart contract token. And the functionality can be anything. So here we have 4 steps. The first one is to run the token smart contract symbolically, like we've seen before. Then we add constraints on important variables of the token smart contract, like balances, total supply, allowances. These variables plays essential role in the behavior of the smart contract, and we want to make sure the behavior is fair. By solving the model, we'll find concrete inputs that satisfy the constraints, and we'll prove if the behavior of the token smart contract is fair or not. Let's see 2 examples. Who can mint my token? The risk with an uncontrolled minting is inflation, which can lead to drop in price. Here we see a real-world scam example where a scammer added a backdoor to the token smart contract with a functionality to be able to mint an infinite amount of tokens. To use symbolic execution, we should first define the constraints. The first constraint is increasing the total supply, which means the total supply at the end is greater than the total supply at start. The same as for the balance of the caller at the end should be greater than the balance of the order at start. Now, minting can be legitimate, for example, in wrapped token and LP token. So we need to find a way to differentiate between legitimate and illegitimate minting. For that, we add another constraint, minting for free, which means the caller doesn't give any value in return for the minting. So we also define value equals 0 and allowance equals 0. By solving the model, we find that there is a specific input that satisfies the constraints that we defined earlier. There is a burn function, and if you give it a specific input, amount equals to 11, anyone can mint an unlimited amount of tokens. If you can see on the right, this is the source code of the scam smart contract token, and you can see that if b equals 11, it returns a big number, and the burn function uses this function. So actually, instead of burning tokens, it's minting tokens. The second example is who can steal my tokens. Let's define theft as a privileged caller who isn't the holder, can reduce the holder's balance without an approved allowance, without permission. So we define constraints. The caller shouldn't be the holder. The balance of the caller at the end is less than the balance of the caller at start. And the allowance equals 0, which means no permission has been given. By solving the model, we found that there is a function called approve with capital A, which isn't defined in the ERC-20 spec. Usually it's approved with lower a. And you can see here in the implementation of this function, the owner can set the balance of any holder, which means he can reduce his balance, which means he can steal his tokens. To summarize, there is a known phrase in crypto, don't trust, verify. Sometimes it's hard to do that. Even if you have the source code of the smart contract, sometimes the malicious functionality is hidden, and we've seen yesterday several examples of how can we trick the verification method of Etherscan. What if you don't have the source code? Symbolic execution can fill that gap. It runs on the bytecode of the smart contract and can prove if there is some functionality of the program, of the smart contract, that is unfair, that is a scam. It's a necessary tool across the board. Developers, auditors, security companies should use symbolic execution. At Redefine, we automated at scale. We provide due diligence API for users, for exchanges, for wallet providers. Recently, we announced the integration with Gnosis Safe, and every of their users can benefit from it. If you want to know more, please reach out. Thank you very much.
Thank you so much, Alan. This is great. And now we go from symbolic execution to fuzzers. And give a warm welcome to Antonio. And I hope I'm going to see some Harvey in there. Maybe? No? Maybe? Okay. Let's go.
Oh, that's fine. So, hi everyone. My name is Antonio Vigiano. I'm an independent security researcher, and I'm currently working on audits and tooling. One of these tools is Fuzzy FYI. It's an automated fuzzer on the cloud. So today I'm going to show a comparative analysis of fuzzers' effectiveness. And yeah. So for this talk, I'm just go through a brief introduction of how a fuzzer works and how to measure an effectiveness, the performance of a fuzzer, what would be the methodology for that, and some key takeaways. Yeah, so first of all, yeah, like from a high-level overview, a fuzzer will just throw some random inputs into your code and try to break it. But going a step further, we can think of it as like you start with some random value and maybe a corpus of previous transactions, maybe previous input that you have sent. Then until you are satisfied, maybe you have breaked some invariants, maybe you have crashed your program. You will pick one of those observations, you will mutate them, and if they are interesting, you kind of add them to the list, and you do that until you are satisfied. So maybe you reach a timeout, and maybe you find a bug. So yeah, naively, we can already think that all fuzzers kind of are equal because they will just throw random input, but that might not be the case since all of these functions and these kind of bold functions here, they might influence on the performance of or effectiveness of a fuzzer. So yeah, so like measuring how well a fuzzer can be at finding bugs is challenging. So first of all, because it's inherently random, and also because the performance can vary a lot depending on the run. So you might find a bug or bugs in the beginning of your campaign, or maybe like after many hours. Also, because like it's difficult to compare different fuzzers, because how do you know that you've found a bug? And finally, because yeah, so there are different ways of measuring like performance. So some solutions that are proposed here, they come actually from a paper shared by some folks from 12-bits. So like the methodology suggests not using the average, like average time to find anything, because of the randomness, you might have very different results from run to run. So you should definitely compare medians and standard deviation across different runs. Trying different seeds, so depending on the seed value, you can have different results. And also depending on the test environment. So maybe you are running on a multi-core instance, or maybe on like just a single worker, you can have different results. Also, it's important to fuzz over long hours, like not over only like a few runs, so that you can have a very wide range of values tested. Yeah, you should definitely try to look for unique bugs, so not double counting the bugs or the inputs that will make your code crash, basically. And also using a statistical test so that you can like make sure that your observation is accurate from a statistical point of view. Yeah, so here the research that I've done is basically comparing Echidna, the latest version, and Foundry using on Uniswap v2. So basically, we injected different bugs on Uniswap, like 12 different bugs, and we measured the time to find invariants that would break under these bugs. And then we run them for 30 different seed values, and we set a 1-day timeout, 24-hour timeout. And finally, we compare the median of those times to break those invariants, and we use this statistical test to assess which median is lower than the other under a specific confidence level. And here is an example more in depth of what that looks like. So basically, on the left-hand side is an instance of the mutated code. So basically, when you're providing liquidity to Uniswap, you need to make sure that you are providing the same value of tokens, of both tokens. So on Uniswap, you take the minimum value of both tokens that you are providing liquidity to make sure that you incentivize LPs to not imbalance the pool. So a mutated code, like with an injected bug, would be taking the maximum value instead of the minimum value. So this is like an example of a manually injected bug. And on the right-hand side is like what we are doing for our Foundry tests and Echidna tests. So basically, we have a add liquidity fuzz test, and then we check if any of the Uniswap v2 invariants break. So for example, one invariant is that whenever you add liquidity, you increase K, and also adding liquidity increases the total supply of LP tokens and many more other invariants. So we have 22 invariants. And if any of those break, then kind of there's a bug. And here are the results from this study. So I'll just take some time to understand the chart here. But basically, on the vertical axis, we have the time to find, to break any of those invariants for the mutated code. And on the horizontal axis, we have all of these 12 different scenarios. So each one is a different bug injected there. So it's interesting, like from first insight, is that the results vary a lot. So some bugs are much harder to find than others. For example, like bugs number 6, 7, 8, 9, they are kind of very easy to find, and others not that much. The ones with the higher, the bigger bars, and also the dispersion is not the same across different bugs. So for some tests, you might have a higher variance than for the others. And we can also see that the performance may not be the same for any of those fuzzers. And yeah, so here are some key takeaways. So basically, the performance can vary substantially from run to run. So if you are using a fuzzer, it will pick like a random seed by default, and it will use that seed. So depending on the seed, you should find you should break your invariant faster or not. So up to 1,000 times faster. Like that can mean either finding a bug in 1 minute or 1 day. So you should definitely perform many runs and let your fuzzer run for many hours. And also, like Foundry will break invariants faster in some tests, Echidna in other tests. In other tests, it's not conclusive. So you should definitely try using more than one fuzzer. It's not that hard to do it. You should just like change a bit your code. There is an example on the repo that I shared. And Yeah, and that's about it. So if you have any questions about fuzzing or security in general, please reach out to me.
Thank you so much, Antonio. Great talk. And last but not least, we have Irene, I hope. Hi, Irene. Yeah, she's there. Irene to talk to us and teach us how you spend tens of millions in security. Sure. Yeah. I don't know. I actually don't know how this works. Rajiv, Muli, yeah? The cable is there? Yeah.
There's USB-C and
It's nine minutes, right? Is it pretty short? Or how long? Yeah, I think 10 minutes. Okay. Hi, nice to meet you all. I know this is super brief, and it's getting to American dinner time, so I don't want to take up too long, but hold on. Let's see. Yeah, it was there for a moment. Sorry about this. We're going to be talking through security principles for cross-chain messaging protocols, and 3 in particular that should inform how you select cross-chain messaging protocols, but also how you design them. That works. Yeah. Oh. It's not updating. Yeah, it is. Sorry. Let's see. Okay. I don't know if that, hold on. It's actually not plugged in right now. It's still showing up. Hold on. What's the Wi-Fi password? Anyone know the Wi-Fi password here? All lowercase? Exclamation point at the end? This is community engagement. I appreciate it.
maybe you can try lower resolution.
Okay. Let's see. Hey.
Can you do the mirror mode? Otherwise, we have it in the backstage if you want.
Oh, why don't you just do that?
Yeah.
Could you do that? Thanks. And then do I use this?
Yeah.
Oh, amazing. Okay. Thanks so much. Thank you, guys. Sorry about that. I'm going to run through this really quick. We'll be talking through security principles for designing cross-chain messaging protocol. So we often see multi-chain, cross-chain, omni-chain. What are the differences between those 3? Oftentimes when we're saying multi-chain, we're thinking about isolated instances of your protocol deployed to multiple chains. For cross-chain, it's actual value transfer between different chains. So that could be through a wrapped asset bridge. It could be through arbitrary message passing, many different implementations. And then omni-chain is this sort of concept of mesh network and actually enabling seamless movement of assets and information, essentially arbitrary contract invocation between chains. And why is this important? I think everyone in this room understands the security risks, and we'll run through that in a second, but also the user experience and developer experience involved. For me, when I first got into the space, I started as a developer at Layer 0 and thought about different chains like different programming languages. You would never think to yourself, what can I build with C++? You would think, I have this problem that I want to solve, and here's the product I'm going to build. What are the tools at my disposal to build that? And so with the piping underneath the hood, which is a cross-chain messaging protocol, you can now leverage the best of ZK Sync or Linea or Polygon ZK VM, and then also Filecoin VM for storage, pull in liquidity from Ethereum, and maybe launch your own app chain for sovereignty and to avoid gas congestion for maybe the game that you're building in that subnet or supernet. What is Layer 0? I'm head of strategy at Layer 0 Labs. We are the creator of Layer 0, the protocol, an omni-chain interoperability protocol, and Stargate Finance, which is the most widely used native asset bridge. It's arbitrary contract invocation, and our protocol architecture and design is very particular to these three principles I'll walk through, and also the concept of evolving with research. So these three principles are immutability, permissionlessness, and censorship resistance. This right here is the architecture of Layer 0, which may be useful later, but I think it also might be hard for you guys to see it. So I'll dive right into the first principle, which is immutability. When I say immutable, what I mean is the contracts. Are they upgradable or non-upgradable? And the issues with mutability or upgradable smart contracts are that when you push code to, let's say, the core contracts for your bridge, you, one, are actually resetting the security that has been locked and secured all over time, but also pushing existential risk for all of the projects that have built on top of your bridge, integrated it, and all the users who might hold assets from that as well. In the same way that, and I was speaking on a bridges panel earlier today and used this metaphor, if your Trezor or Ledger were to push an upgrade and you saw that, you would likely reject it, or it would give you a lot of pause. Why would you accept the same for your DeFi protocol? And for many cross-chain messaging protocols, they do use upgradable smart contracts. And so even if a developer is introducing a benign patch or is trying to introduce a new feature with good intentions, the chances that there's a smart contract bug in that, which all of the applications built on top did not opt into, is incredibly high. In fact, the majority of bridge hacks over the last 2 years were because of smart contract upgrades, not because of architectural flaws. So, even great and well-meaning developers make mistakes. We all know this. This is a graph that demonstrates what I meant by resetting security. When you upgrade the protocol, it resets the perceived security over time, which is measured by value secured in time. And where you see that blue bar is the upgrade to the smart contract. How can you design a protocol that enables applications to opt in to the smart contracts that they've vetted and have seen secure value over time, but also have optionality? Because let's say the validation techniques we use today will not and likely should not be the ones that we use 5 to 10 years from now. How can you offer that without doing a complete overhaul of your protocol? And that's exactly what the architecture I may have time to walk you through achieves. And here it is, a solution, library upgrades. So how we designed Layer 0, the protocol, was by deploying endpoints on each of the chains which we support, and these endpoints are entirely comprised of immutable smart contracts. However, we can always launch new endpoints, and applications can point their contracts towards those. That means we could launch a smart contract library, which are the endpoints that leverages ZK technology or some new validation technique in the future. In between all of these endpoints are the off-chain entities that are involved in validating separate components of the state data. And as you can see here, it doesn't reset the security clock. There is no forced upgrade. It's always opt-in for applications, and it allows for time and money secured to reach a threshold that is acceptable before applications opt in. The second principle is permissionlessness. We talk about this a lot in many different contexts. In the context of cross-chain messaging, what I'm referring to is the ability for a developer to leverage your protocol in whichever way they'd like. And in the case of Layer 0, we are open and permissionless. And Application devs can use it to create something that we might not align with from an ethos perspective, but there's nothing we can do as Layer 0 labs to interfere. It also means that participation, the validation, and network is also open permissionless. So if you'd like to run one of those components yourself, the oracle, the relayer, multiple oracles, multiple relayers, you can, and it doesn't require any coordination with Layer 0 labs. This also enables and encourages client diversity, since maybe you have a set of 20 validators and you're requiring 13 of them to agree, but all of those validators use the same code. Ultimately, that client diversity is one. By leveraging different oracles and relayers provided and run by, say, like Chainlink, Blockdaemon, Gelato, Layer 0 Labs, your own team, you have that client diversity, the optionality, but also the backstop if your team were to run one of those yourself without unilateral control or centralization. And this also leans into the dichotomy between protocol and service. So when I say service, I mean a product which requires the creator company to maintain its integrity and liveness and the actual value it's meant to provide. A protocol is something that is evergreen. It's a primitive, it's immutable. You can use it as you like. And when you're choosing these really important parts of your infrastructure stack, you don't want to be, one, adding more code exposure, but two, relying on a founding team that might get arrested, which happened recently with multi-chain, or a team that may run out of runway and actually just shut operations down. Or a team that needs to constantly be patching code. So without immutability, permissionlessness is never guaranteed. And the final principle is censorship resistance. We talk about this a lot in different contexts, but in the case of bridging and cross-chain messaging, it's actually even more important, in my opinion. If you have the ability to reorder messages as they're submitted, that means that a high-frequency trading firm could extract more MEV, for example, by reordering messages and front-running. It means that if a nation state were to leverage cross-chain messaging or just blockchain technology for voting, it would be possible to possibly censor a tranche of those votes. Layer 0 is designed to be non-sorter enforced, and so every message must pass across the protocol if validated properly in the order in which they were submitted. And so, like I said, cannot reorder delivery of messages or censor individual messages, and applications can also always choose different off-chain infrastructure by swapping in and out. And again, without immutability, censorship resistance is not guaranteed. I have about 2 minutes left. These two graphs just show the growth of contracts that are building cross-chain, omni-chain, multi-chain. These specifically are contracts that have integrated Layer 0 in some capacity. So on the left-hand side is testnet, right-hand is mainnet. This is back from April, and it has continued to steep up and to the right. So it's actually just really exciting to see what's going to be coming out over the next few months. We're seeing, and I personally have been involved in traveling the world to be in person with teams building omni-chain stablecoins. Tokenized T-bills, for example, that will be native on multiple chains and seamless transfer between them, leveraging Layer 0. Games that under the hood are leveraging ZK Sync and a Polygon Supernet and Ethereum, but abstracted away so the end user is just playing a game. There is no tribalistic affinity of it's a Solana game or a Polygon game, and they use one gas token and do one click in order to move their in-game assets between chains. We're seeing NFT projects moving between chains as well. TradFi, leveraging cross-chain messaging to communicate from permission chain to public chain. And then, of course, across all of DeFi, there are so many interesting things happening with LSDs and also lending and borrowing from one chain to another. Lend in one chain, borrow across 5 different ones, collapse it into one click, and use one gas token. So it makes me incredibly excited for the next year, the next 5 years, since some of these projects take a really long time to develop, and security really is at the forefront of this. It's unfortunate that nearly every single month there's some sort of hack, but it comes down to the violation of these 3 principles, and something that I encourage all the developers in the room to think about. So I have 20 seconds left. I want to thank you all for helping me with my Wi-Fi and being super patient. Really nice meeting you all, and happy to answer questions.
Thank you so much, Irene. This is amazing. Amazing work. I like the upgrading libraries. It's a really good idea. I'll hand it over to Molly for the closing remarks.
Yes, so I'll go upstairs.
Do we have time for questions? Yeah, absolutely.
There's one question. There's one question, Irene.
Irene, there's one question. We have time for questions.
God, I hope it's not a dumb question. Hi. I was wondering if you could explain a little bit more about pre-crime, because that sounded technically really interesting. And yeah, I know there's quite a few experiments going on around in the ecosystem with local forks, simulations, etc. And so this is really cool because it sounds like it's something that's actually used in prod.
Thanks for the question. I'm being instructed to come back on stage. Yeah, so pre-crime is a proprietary security module that we created actually prior to the launch of Stargate, which is the native asset bridge that came out about a month after Layer 0, the protocol, went live last March. And what pre-crime does is it forks every message that goes across the protocol and tests it locally against a set of invariants that are defined by the application. And so that could be a formula that helps prevent the double spend issue. It could be a set of whitelisted addresses for an NFT migration. It can be quite literally anything the application developer wants it to be. And only then will the message be pushed back to mainnet and run across the protocol. And the idea of it is stop a hack before it happens. And the efficacy of monitoring once that hack is actually happening is as ineffective as a Twitter thread saying $100 million has been withdrawn from this bridge. The auditor sitting to my right on the panel earlier today was talking about that. And pre-crime is meant to solve that issue. No, but actually, interestingly, right now, pre-crime is only opt-in, and it was used to protect Stargate, like I said. 2 weeks after Stargate launched, it reached 4.4 billion in organic TVL, which was astounding. It was the fastest growing DeFi protocol of all time in that respect. Since then, we have made the protocol so much more efficient, and we haven't actually even reached peak efficiency, which would involve, I think, around 200 million of protocol-owned liquidity instead of needing external LPs. But I remember, all of our devs were at the time in the Bahamas and just saw every single black hat attacker try and break Stargate, and we built pre-crime just for it. What we're doing right now, and we'll launch in Q4, hopefully sooner rather than later, is we're scaling pre-crime, as we say, like to infinity. So every project, all of those 6,000 contracts on mainnet can leverage pre-crime. Right now, it's not at scale to be both fast enough and to, to be fast enough and support all of these contracts. Okay, yeah.
Thank you, everybody. It's my pleasure. I think actually, when we started this event, I think I told you, we actually didn't know that this will be so successful. I really want to thank, first of all of you. Thank you a lot. Couple of announcements, and so I think we told you, but we are actually launching this virtual event, so it's coming soon. Stay tuned. It's more focused. Every month we're going to pick a topic and cover it. We're looking for more topics, but we have many ideas, and please let us know about things. I think we have a lot of people who already expressed interest in speaking in this event. We will try to be as inclusive as possible. Please stay tuned. I think everybody wants to know numbers, so basically what I was told that there are 700 people who participated. Thank you all. I also want to thank the people who participated remotely, and actually it seems like today, thanks to the auditing and many others, it's actually bumped quite a bit. I think we have 4,300. Is it true? Are we? Okay, so 4,300 people attended. It's amazing. I think special thanks to the AV team. It's working hard at the back, please. And I think I'm now coming to the sort of the most pleasurable thanks. I think maybe I could have the volunteers, if you don't mind, don't be shy, come up front, please, Nathan. Yes, so I think everybody here, they work so hard. And I think I want to thank specifically Nathan. Where is Nathan? Here. From the Ethereum funds, basically making this event so successful, picking the event, making sure we have the food, getting the deal with everything here. And I guess not many of you know, because everybody thinks that I did something here, but actually Uri Kirsten has actually been working here for 2 years, actually taking care of everything, talks, everything, Uri. And of course, thanks the speaker, and thanks you, and enjoy everything. Thanks a lot.